Okay, let's see, because I think now there's a different link than the one that you posted in the Slack channel. Let me see. Yeah, we're live. We're live on the channel.
About the presentation. So he has to be co-host at some point.
Ilias and Leslie, just to let you know that we're now live on YouTube as well.
Yeah, sure.
Thank you.
Was he presenting from 9:40 to 10:40? From 9:40 to 10:40. The next session. Are you presenting in the next session? The first session is like 3 talks. The next one is from 9:35 up to 10:40. Yes.
Okay, hello. Can everybody hear me? Good. Well, a very big welcome to everybody to the 4th Natural Legal Language Processing Workshop. It's hard to believe we've already had 4 of them. And I know this one was maybe hard for some people to get to. It's very far away from some people, but we're all here together. And we really appreciate everybody coming and presenting their work. We had a lot of submissions this year, more than we ever have. And it was very exciting for us to see how the work has evolved over the last 4 years and how popular legal NLP is becoming around the world, really, which is exciting to see. So as people file in a little bit, we need to get started. We have a lot of presentations, as you can probably tell from the schedule, and this is really a result of really so many high quality papers being submitted, and we just did accept quite a number of people. We're so happy to have you all here. I know the talk's a little bit short, but we're very excited to hear all of them, and we will have a little best presentation award at the end. So stay tuned for that. And so with that, we'll start. I'm going to hand it over to Ilias, who's going to present our morning sessions. So thank you very much and welcome.
Cool. Hello, everybody, from myself as well. So we start with a mini session. There are 3 papers which are about summarization and generation in general. And let's start with the first one, which is for the Multi-LexSum paper. I think it has been accepted to Newrich, right?
Yeah.
You presented it earlier this year. Okay. So yes, you can go there.
Come on up.
Oh, wait a second. Okay, I think I could do this.
Cool. Are you muted? You're muted.
I'm muted. Whoa. Okay. I think it's your. I think your machine is also.
Let's start.
Cool. Awesome. Well, hi, everyone. Let's make this quick. I'm Kyle from the Allen Institute for AI, and excited to present Multi-LexSum. This is work led by Shannon Chen, who's a PhD student at MIT, and this project was in collaboration with the University of Michigan School of Law. Multi-LexSum, in short, is an abstractive summarization dataset for multi-document summarization. What's exciting about this is 3 points. It's a real-world use case. These are summaries written by experts, and these are summaries written at 3 different granularities. I'll explain these throughout the talk. So what is the Civil Rights Litigation Clearinghouse? The CRLC is a free law initiative running out of UMich Law. What they do is they collect metadata and court documents about civil rights lawsuits in the US. They organize these, they write summaries of these cases, and they host them publicly on their website. These are used by lawyers to efficiently review these these lawsuits, as well as educate the general public about major events that are happening in the US. This is super challenging to do. These lawsuits involve 200+ pages of source documents per case. These are the types of documents you have to wrangle. They're heterogeneous, they reference each other, they update over time. And each summary takes a trained expert about 1 to 10 hours to summarize per case. So obviously a lot of opportunity for NLP. The way that these summaries are written is lawyers will wrangle all of these different source documents, and they'll first write a single long summary where every paragraph corresponds to one major event, such as like a motion that was filed or an outcome of the case. And using these long summary and all the additional source documents, they'll then generate a short and tiny summary. The tiny summary is used for tweeting. These go through a really rigorous review process throughout the entire writing. They have to adhere to strict guidelines. An example of this is, say for a summary like this that was written, they have to guarantee all of this information is present for every single one of these source documents. And we collect all of this metadata and also release it alongside the summaries. This has been 10+ years of writing, and it has involved 500+ authors. All of these are legal scholars, attorneys, students at the University of Michigan. So really excited to share this publicly. And what's really cool if you're an NLP person is you can do lots of cool, interesting experiments here. For example, one of the experiments we tried was you can train a single model to generate summaries of different granularities. For example, by prompting the training process with long, short, tiny summaries. And it turns out summaries that come out of this model actually outperform the summaries generated by models trained on just a particular length, which we found quite interesting. But we're not done yet. These summaries are full of factual errors. They get everything wrong. They hallucinate really strange legal reasoning for things. So there's a lot of room for improvement. In fact, we built an assistive writing tool for lawyers to use this. And what lawyers basically said was that the model was completely unusable, even if we fed it gold evidence snippets in generation time. And they ended up spending most of the time just editing and rewriting everything. It was actually easier to just not use the system at all and just write the summaries from scratch. So a lot of room for improvements. All of this is available on Hugging Face datasets, a few lines of code. Really excited to share it. Please check it out. Thank you.
Cool. Thanks to the first author. As you already know, probably we have a shared QA session, so you'll take questions later. And now we have the second talk, which is extract summarization of legal decision using multitask learning and maximal marginal relevance. And the authors will not be with us, so I have to share the video. Sorry for this, guys. What? So I can't open it right now, so I'll have to go to the web. So can someone help me? What's the ID for the second talk? Because for some reason it's corrupted.
Findings 1134.
1134. Okay. And I guess this will work.
Hello, everyone. My name is Abhishek, and this is a short presentation for our paper. In this work, our objective is to design an automatic summarization system that can overcome the existing challenges. We implement different implicit and explicit redundancy checks to make sure that our summaries are informative. We use rhetorical role labeling as an auxiliary task in a multitask learning setup to leverage more data. And we also perform qualitative evaluation with the help of legal experts to compare our summaries. Our dataset consists of decisions from the United States Board of Veterans' Appeal. There are 3 possible outcomes for each case: granted, denied, and remanded. Our objective is to generate summaries that explain how a particular outcome was reached based on the evidence available in the case. We model it as a binary classification problem where we decide whether we should include a sentence in the summary or not. The dataset consists of only 112 expert annotated cases in total, with 1 summary each for all the 92 cases in the train set and 4 summaries each for all the 20 decisions in the test set. We also use rhetorical role labeling as an auxiliary task. We transform it into a binary classification problem to align it with our extractive summarization objective. The rhetorical role labeling dataset consists of 53 decisions with equal number of granted and denied outcomes. Unfortunately, we do not have any remand cases in this particular dataset. Our summarization model consists of different redundancy checks, both explicit and implicit. Maximal marginal relevance, or more popularly known as MMR, is the unsupervised method used to generate summaries that are less redundant. It tries to maintain the balance between selecting the most representative sentence, but at the same time, diverse from already selected sentences in the summary. We use the neural variant of MMR known as MMR select, which replaces the similarity between query and target with the confidence score generated by the sequential model. We also perform implicit check for redundancy. Here, the idea is to penalize the model if it chooses 2 sentences for the summary that are very similar. We modify the loss function by dividing it by the square of the number of sentences in the source document to prevent it from exploding if the document is too long. The redundancy loss term is later added to the weighted cross entropy loss function. The parameter beta helps us balance the importance we assign to the 2 loss functions. Here we have the overall architecture for our extractive summarization task. For each sentence in the case document, we generate the sentence embeddings using the domain-specific EMNLP. Next, we focus on sentence scoring. So for each sentence, we want to generate a confidence score. And to do this, we input these embeddings to a bidirectional GRU layer followed by a fully dense connected layer to generate the required scores. Once we have the scores, we move to the sentence selection part, and we use the neural variant of MMR select to pick the final sentences from the summary. Now, coming to a multitask learning setup, we use rhetorical role labeling as an auxiliary task to learn better representations and improve the performance of the summarizer. Again, we have 2 different variants. We have multitask shared on the left and multitask hierarchical on the right. Multitask shared as shared bidirectional GRU layer for both rhetorical role identification as well as summarization tasks. For multitask hierarchical, we use the first layer just for rhetorical role labeling, and we add another layer on top for extractive summarization. Now let's first discuss the quantitative results. Here we have the root score for the different annotators, the baseline methods, and the proposed methods. Overall, all our proposed methods score higher than the baseline, and most of the inter-annotator scores as well. Additionally, the multitask methods perform better than the single task method, showing the effectiveness of the multitask setup. And score for remand cases are higher than those compared to granted and denied cases, as almost 50% of the cases in the training set are remand cases. Qualitative results. We also do a qualitative comparison between expert annotated summaries and model generated summary. A legal expert ranks these summaries in terms of quality and checks if they are adequate or not. Single task with redundancy loss performs the best for granted, remand, and overall. Most of our methods score better than the annotators except for multitask hierarchical model, which probably overfits to the annotator lexical bias. So in conclusion, the redundancy checks help produce more informative summaries. Also, for models with redundancy loss, the parameter lambda has higher values compared to those without the implicit check, indicating its effectiveness. Multitask methods perform better than the single task methods in terms of root score, showing correlated tasks can help us learn better representations overall. And our approaches don't require us to train a large model or a data set and can work effectively with a very small number of annotated cases. Thank you.
Cool. That was the second talk. Unfortunately, they can't hear you clapping, but that's okay. So we are gonna go to the last talk of this session. It's towards cross-domain transferability of text generation models for legal text. And I think, Kasturi, you are here, right?
Yes, I am.
Okay, so you can share your screen and start presenting.
Yes.
Thanks.
Okay, I hope you can see my screen. I think it's sharing.
We see your slides, so it's fine.
Okay, cool. Hi, everybody. Thanks for being here. I'm Kasturi, a scientist at AWS AI Labs, and I'll be presenting our work on cross-domain transferability of text generation models for legal text. It's a work done in collaboration with my colleagues, Vinay and Rashmi. Legalese can often be filled with verbose domain-specific jargon, which can make it difficult for non-experts to understand. And therefore, summarizing legal documents is a vital step in making that more accessible to users. However, as expected, obtaining label data for every domain of legal text is challenging and can be expensive. Therefore, studying cross-domain transferability of existing state-of-the-art neural text generation models is an important area of research. In this work, we measure the extent of cross-domain transferability of T5 and BERT-based summarization models on 4 different legal domains. We create and release a dataset for privacy policy summarization to enable further research in this area. We also compare the effectiveness of various summarization metrics and illustrate differences thereof. We use 4 datasets of different legal domains for this work. These include BillSum, consisting of US congressional bills, the English subset of JRC Acquis, containing data from treaties, legislations, etc., pertaining to the member states of the EU, and a legal contracts dataset. The 4th domain consists of privacy policies, containing legal documents that disclose ways in which a company collects and manages their user data. While there has been work done to summarize sections of privacy policies, there was no open-sourced dataset available for this task. Thus, we create and release a dataset for privacy policy section summarization to promote further research in this area. You can refer to our paper for details on the dataset. In order to further highlight the domain differences between these datasets, we demonstrate in the table here the number of characters in the context summary pairs of these various datasets. In order to study the cross-domain transferability of T5 and BERT-based text generation models, we conduct experiments in 2 settings. In the single domain setting, each model is fine-tuned with label data of a single domain, and summaries are generated for both in and out of domain datasets. Cross-domain performance determines transferability across domains. In the multi-domain setting, each model is fine-tuned with training data of all the domains, since we hope that this would enable the model to incorporate domain differences during generation. We measure model performance using standard summarization metrics such as RUGEL, Meteor, BERT score, and BART score. Here are a few of our experimental results. We observe that for the single domain setting, the cross-domain transferability is low for both BERT and T5 models across all domains. On the other hand, models trained in the multi-domain setting yield superior performance for every domain, thereby demonstrating that this setting enables the model to learn from the domain differences of these datasets. We have more detailed results across all domains in our paper. Here we show some qualitative results generated by the fine-tuned models. As is evident here as well, that the multi-domain models perform better as compared to the single domain ones. We further compare between the summarization metrics themselves for this task. We find that the percentage drop in performance between the best and worst performing models, as reflected by BERT score and BART score, is significantly less as compared to Meteor and BlueGen for 14 out of 16 settings in this study. So to conclude, we find T5 and BART-based generation models to yield low cross-domain transferability for legal text. Our experiments demonstrate benefits of combining various domains to train models for such tasks. We also compare between the different summarization metrics and demonstrate their differences. We further curate and release a data set on title generation for privacy policies to enable further research in this area. In the future, we wish to explore text generation specific to legal text for low resource scenarios, including 0 and few shot settings. Thank you.
Cool. So that was the last talk from the very first session about summarization. Now we can take questions for the authors. So we have with us Kyle for the first paper, and we have Kasturi online for the second paper. So anyone who's willing to make a question? We have questions. All right, cool.
Hi, I have a question to the first paper. You did this user study, right, where the lawyer said that the summaries are not really usable. Can you maybe say some more words about kind of what they find, kind of what the problems were, and maybe let's say if maybe like an extractive approach might be better in their eyes?
Yes. So the study itself was basically, we tried to do end-to-end generation. 100% of the writers were like, this is so garbled and unusable that they couldn't use it. The follow-up, and I'll talk about what these are. The follow-up was we had them go through each of the documents as they were writing, highlight the exact note that they wanted to include, the fact they want to include in the summary, and giving this as goal to the summary, still had to generate paragraph per paragraph, and they evaluated, and they still found that user study result. The problems are mainly facts. So dollar amounts are wrong, number of years, dates are wrong, names of people are generally preserved, but their positions, like if they're a plaintiff or the defendant, it's just, those are flipped. And also legal reasoning is strange. So they'll say that something happened, which is correct, but they'll say it was a consequence of discovery, which came out of nowhere. So those are the two main types of measures. Extractiveness can help, but there's a good paper at some previous workshop conference that was like extractive summaries can also hallucinate or can also be factually incorrect. So I would recommend looking at that. They found that most summaries were missing just way too much information, and it would actually cause it to be misleading because of the missing information. So just extraction won't help.
Cool, thank you. Another question?
So since the summaries that you guys have to generate have to contain certain information, I wonder if you use the neurologic decoder, which imposes constraints on the output, which I think came from AI too, right?
Yeah.
And you know.
Yeah, still experimenting. Actually, we were working on that, and then ChatGPT and stuff like that started coming out. So now we're working on that. We'll see. We'll report, I guess, as we find, but I'm not sure yet. Yeah. Cool. It's a good idea.
A third question.
How for Kasturi?
Hi, yeah.
So in your data set, I mean, you do on privacy policies, the title generation, which may not be complete sentences. With BILSUM and other data sets, you have complete sentences there. So do you think in that cases, the transfer really works because there is no controllability there? So how do you tackle that particular problem, or are there any thoughts on that?
That's a good question, actually. So for 3 out of the 4 data sets, I would say characteristically the summaries were of similar lengths, although I don't know if you noticed the table where we demonstrate the number of characters, that is the length of the summaries in each case, which does vary quite a lot. But for the privacy policy section title generation, yes, a title would tend to be shorter than a sentence or 2 long summary. So what would be interesting as future work, which we didn't do for this paper, of course, is to be able to see how these models transfer across various tasks as well, even in the domain of summarization. Because here we were treating every single, each of the data set summarization, the task we were treating it was summarization at the end of the day. But yes, there could be a nuance that we fail to capture, which might show up in the privacy policy data set. So it might be interesting to see how models generalize across tasks as well.
Cool, thank you. And we still have time for questions, if you have any. There are no more questions in the room. Is there any question online, Catalina, Daniel?
So far, not.
Okay, so we better move to the next session, I guess, to save time for later. Cool. So we're moving to the next session, which starts with parameter efficient legal domain adaptation. Do we have the speaker here?
Hello.
You're online. Cool.
I need screen share.
Yeah, you just have it.
Great. Can you see the?
Yeah, we can see.
Yeah, we can see.
Yep. So yeah, hey guys, my name is Jonathan Lee, and I'm a research intern at Ingenuity Labs Research Institute at Queen's University, and I'm also a grade 11 high school student at Kingston Secondary. And today I'm presenting my work, Parameter Efficient Legal Domain Adaptation, which was done in collaboration with Rohan Mamboria and Xiaodan Zhu. So as legal NLP researchers, our goal is to make legal services more accessible to the public. However, there are typically a few challenges to doing so. Firstly, models such as GPT-3 are very computationally expensive to train, and they require much disk space and memory for training and inference. Even models like Roberta Large take up much disk space when saving model checkpoints during training. And secondly, labeled data is very expensive to come across in the legal domain, where hiring legal experts is expensive. So we often have many unlabeled samples and few labeled samples in the legal domain. So if we can resolve these problems, we can make legal NLP somewhat more accessible in law. So how can we solve these two problems? Well, to reduce memory usage and disk space, previous works explore parameter efficient tuning methods, such as prefix tuning. They match the performance of full fine tuning while training about 0.1% of the parameters, and they work by tuning a relatively small prefix and freezing the rest of the trained language model. And so this prefix can then be efficiently stored. However, parameter efficient methods don't work in low data scenarios well, especially prefix tuning, which is limiting in the legal domain. Many other papers, such as AraLegal-BERT, use unsupervised domain adaptation in domain-specific examples to improve the performance. However, they're not parameter efficient because they train the entire model during the domain adaptation step, requiring much storage and compute. So this work explores how we can solve both of these issues at once through prefix domain adaptation, which is a novel approach to domain adapt a prefix prompt. Essentially, we show that we can use an unsupervised domain-specific piece of text corpus to adapt a prefix that is 0.1% the size of the model. And it's also storage and memory efficient. But because we domain adapt the prompt, it also works well in downstream tasks with little data. More specifically, we start with a pre-trained model such as Roberta Base, and we also have a large corpus of domain-specific text, and which in this case is law-related Reddit posts. And then we train a prefix, recall that's the 0.1% the size of the model, for the masked language modeling task, which to our knowledge has never been done in an unsupervised way before on a prefix. And this leaves us with a prefix that captures domain-specific information, which in this case gives the model a better understanding of informal legal questions from Reddit. And finally, we use this prefix to improve performance in domain-specific downstream tasks, such as a classification task. So we evaluate our approach on two new tasks that we introduced. And since our goal is to make legal NLP more helpful to laypersons, we use datasets that are more representative of that group. So Legal Advice Reddit and Law Stack Exchange. And the task is specialty of law classification in one of 16 categories. And additionally, we test on the ECHR binary legal judgment prediction task, which many works have previously studied as well. So we test our approaches under a few-shot setting, as this is the case in most legal tasks. And we also run 5 runs to account for the instability of few-shot learning. And we use baselines of fine-tuning Roberta and AraLegal-BERT, regular prefix tuning, and full domain adaptation. So for results on the Reddit dataset, we observe that our approach in the blue is comparable to fine-tuning in the orange. And also note that normal prefix tuning, which is in the green, falls behind with fewer samples. And additionally, fine tuning is less stable for this task, as denoted by the orange shaded area representing the standard deviation across the 5 runs. In general, prefix domain adaptation, which is our approach, is comparable to full model tuning approaches, which are represented above this line in the table here. And our approach is even often comparable to full domain adaptation and fine tuning. So additionally, we show results on calibration, which is intuitively how closely the model's confidence scores match the actual accuracy. So we find that calibration is similar to that of AraLegal-BERT, or matches that of AraLegal-BERT, which is important in the high stakes nature of the legal domain. So to conclude, we introduce a novel training framework, prefix domain adaptation, and in the legal domain, this framework matches or outperforms AraLegal-BERT or related techniques while tuning around 0.1% of the parameters. We improve few-shot performance and calibration compared to other parameter-efficient methods, and also finally introduce 2 new datasets to better facilitate legal NLP that's targeted towards laypersons. Thank you.
Cool. Thank you, Jonathan. And now we'll move to the next talk. Do we have a speaker for that? Okay. I'll give some instruction for the rest of the papers because we have to be fast. We have a very short time. So whoever is going to present, he can either present for the local labs that we have here, but we need to have your slide beforehand, or you can just join the Zoom call. And then by joining the Zoom call, you can share your slides from your own laptop, which I think it's better for you. Cool. So, no, we can't. I should have said that earlier, I guess. Yeah, but the rest of the people who are here and want to present, please log in to the Zoom. If you're going to present. Maybe if someone has to present this session, he should either have already sent us the slides or try to join the Zoom call in their own laptop, and then we will give you share rights to share your screen from your own laptop.
Yeah,
it's cool. We'll have it.
Okay, so hello everyone. My name is Gil Samo, and I'm data scientist at Adero. And I'm happy to share with you our paper in collaboration with Dor Berenson, Ben Hajjaj, Gil Hayat, and Joel Nicolaus. Our main research question is whether you can predict the outcome of class action case based on the text input alone. By using only the facts and allegations, we try to simulate a scenario where a judge addresses a case based on its merits alone. On our work, we mainly focus on class action cases, which are a unique type of cases that's used to seek relief on behalf of large group of consumers or businesses. Those cases are complex, unpredictable, and rich in facts and allegations, and we truly believe that gaining insight into those areas has great social and political impact. The most relevant passages within the complaints that are relevant to our task are the sections that contain the factual background and the legal allegations. So we didn't rely on any metadata features such as date of filing or party information or geographical locations. Instead, we built a heuristic-based system in order to trim out the relevant sections from the complaint that was written by the author of the complaint, which is the plaintiff. Class action cases can end up in many different ways, not only win or lose. So we took a simplified approach and we binarized the data into 2 labels, win or lose. And applying this approach resulted in more balanced data set. After extracting the most relevant passages within the complaint, we still left with a very long passages. So we've constructed multiple data sets in order to feed the transformer. And for that, we've split the original complaint into 3 different setups. So the first one is full text, which means facts and allegations combined into a single document. The second one is unified allegations, which mean all the allegations combined into a single document. And the third one is separate allegations, which mean each allegation is a different document. In the following graph, you can see the difference it makes when it comes to the number of tokens and number of documents generated overall. So our approach through this task was using pre-trained transformers for classification. And we use stratified cross-validation, and we optimize our model using the accuracy evaluation metric. We tried different setup of hyperparameters, and finally, we chose the presented ones. So we mainly focus on three different type of models. So long text transformers, legal transformers, and generic transformers. As you can see, the legal transformers outperform the generic ones. We achieved 66.8 accuracy with custom AraLegal-BERT, which was our best model. The full text setup contains the effects as well, so we decided to use a long former in order to deal with it. Although we expected that it would achieve better results, it did not. We believe that the messy structure of the facts caused these results. So we backtested our models with human annotators, which are certified lawyers from the US, that had to decide for each text based on the text input whether the case would win or lose, and they had to rate their confidence level in their predictions from 1 to 5. So our model outperformed the legal annotators, and we believe that our model is better suited for generic verdict prediction task. And another interesting note is the calibration results. Humans tend to be less calibrated, resulting in more extreme predictions, and our model is better calibrated, resulting in more reliable results in terms of confidence level. So our work here could be enhanced much further, and we plan on expanding our model to a domain-specific set of documents, align with domain experts to tweak the accuracy. And we are considering using more approaches like featured learners and researching the linguistic structure of successful allegations. We've decided to share our datasets and model with the community, and we'd be happy to collaborate on future ventures. And this is it, guys. Thank you, and happy to be here.
Cool. Thank you, Jill, for the presentation. We'll keep going, and then we'll have again, as I said, the joint QA. So have the third author, presentation. You have to go to the podium.
It's all set.
Yeah, the third paper is zero-shot transfer of legal judgment prediction as article-aware entailment for the European Court of Human Rights, and the presenter is Santosh. Okay.
So good morning, I'm Santosh, and this work is called Zero-Shot Transfer of Legal Judgment Prediction as Article-Aware Entailment for European Court of Human Rights, a joint work with Oana Isham and Matthias Grabmeier. So the current approaches for legal judgment prediction, the task of legal judgment prediction is to classify outcome of the case given the textual description of case facts. And most of the LJB approaches tackle it as a classification problem where they rely on the textual input of case facts description. But training the LJP systems only based on case facts description is that they're unable to classify based on the legal provisions, which they haven't seen during the training time. So in this work, we try to model LJP as an entailment setting for human rights adjudication, where we try to pair case facts description with ECHR convention articles and try to predict the binary outcome for a particular task. This is as similar to the legalistic realistic setting because judges try to interpret the new legal rules which have come on a very new basis. So we try to emulate that setting of how judges deduce the outcome of a case based on new legal sources. This gives an opportunity for the model to understand that case facts and apply the legal rules present underneath. So we've benchmarked it in a zero-shot transfer way, which provides a testing ground for generalization of legal judgment prediction models. And we use domain adaptation components using domain discriminator and Wasserstein distance, and they try to improve the generalization performance. So we use the ECHR dataset from the LexGlue benchmark, which comes up with 11K around case facts description, and it is evaluated again as two tasks. One is the allegation identification, which is called task B, and to predict the violation prediction, which is a task A, which includes 10 set of prominent ECHR articles. And the current baselines only use the textual descriptions of case facts, which we refer to them as case fact classification variant. We augment the text of those 10 articles along with from the ECHR convention and formulate it as an entailment variant. So we experiment with two zero-shot settings, one which is called zero-shot restrictive, the other is called zero-shot wild, which are also known as unsupervised domain adaptation and any domain adaptation. Both of the models have access to all the source articles in the form of their case facts, article text, and the entailment labels. Whereas with respect to the target data, in zero-shot wild, we only have access, we don't have any access to the target data information. That is, the goal is to learn zero-shot wild entailment classifier in such a way that it can adapt to any test distribution. Whereas in zero-shot restrictive, the model knows which target data it has to adapt to in future. So it has access to case facts and articles, but not the entailment labels. So the model will adapt to a given unlabeled target data distribution. So this is the entailment setup along with the domain adaptation components we have. It takes case facts and the articles pair, has a feature extractor, and in parallel, it has an entailment classifier and domain adaptation components. We experiment with two domain adaptation components called domain discriminator, which tries to predict the ID of the article. And then we have a Wasserstein distance, which tries to minimize the mean between the features. The goal here is the feature extractor to extract features in such a way that it does not memorize the article information. Rather, the feature extractor learns how to reason between the case facts and the article and tries to apply, thereby improving the generalizability power. So a brief discussion on how the research questions and the results are. Just to first question being, does entailment really help better than the normal fact classification variants? We observed it helps marginally and consistently better with greater improvement noticed in macro F1 scores, which means it's helping to transfer across parser articles very well so that it's about to reason very well. The second question is to understand, does domain adaptation components really help to have a zero-shot transfer? We observed a consistent improvement when compared to the target transfer, and it performs similarly on the source. But you can observe a striking difference between the source performance and the target performance, which means there is a huge room for improvement to provide more worthy neural LJP models, which can generalize better. And finally, we observed legal BERT performing better than BERT on target, but it's comparable on source. That is, you can use a normal BERT when it needs to perform on source data, but when it needs to have a transferability power, it needs to have a domain-specific pre-training capabilities. So a final takeaways, we cast legal judgment prediction models into an entailment setting, which helps a testing ground for zero-shot legal judgment prediction models under both the zero-shot settings. We experiment with domain adaptation components and see they have capability to improve transferability power. And we show that the divergence is very high and there is a huge room for improvement for building zero-shot legal judgment prediction models. And finally, we observe the interaction of domain adaptation interacts with the law-specific pre-training of encoders. Thank you.
Cool. Thank you, Santos. And then we'll go to the next presenter is Dai, and the paper is Revisiting Transformer-Based Models for Long Document Classification. This is a EMNLP findings paper, and we are glad to have you here.
Hi, everyone. I'm Xiang Dai, a postdoc from CSIRO Data 61. Today, I'm going to talk to you about our paper on long document classification. This work was done together with Ilias, Suna, and Desmond from University of Copenhagen. So the original transformer and early pre-trained models may not be a good option for long document processing because standard self-attention operation has quadratic complexity in terms of sequence length. On the other hand, real-world applications may be deployed to process very long documents, such as legal cases. Taking the European Convention of Human Rights dataset as example, you can see most of these documents have more than 1,000 tokens, and some of these documents even contain more than 10,000 tokens. So we found the existing efforts of solving this problem either aim to build efficient replacement for self-attention operation, or use standard transformer as part of a task-specific architecture. So in our paper, we conduct an empirical study of two representative models, long-former and hierarchical transformer. We aim to identify some important design options in these two models and understand the impact of these design options. So here are more details about these two models. Long-former relies on local attention and global attention to replace for self-attention. Here we investigate two design options in long-former, the impact of local attention size and how to choose tokens for global attention. The right side shows the architecture of hierarchical transformer. So document is first split into several small segments, and each segment can be encoded directly using any standard transformer. And then we build another 2 transformer blocks on top of that to generate contextual segment representations, which are finally aggregated into a document representation. Here we focus on the design option of how to separate the document. We use 4 classification datasets from different domains, actor from legal domain, mimic3 from clinical domain, and 2 other news articles datasets. So now let's move to our findings. First, we find a small local attention window in long formats are still effective. For example, if we reduce the local attention window size from 512 to 32, the performance drop on both mimic and actor are negligible, but both the training and test speed increase 3 times. Regarding global attention, the default configuration of long format use the first token for global attention. We find using more tokens for global attention does not improve the effectiveness. However, evenly choosing a small number of tokens based on token position seem to improve the training stability. Moving to hierarchical transformer, we find the choice of segment length is very important, and the optimal segment length is dataset dependent. Actor, which are legal cases, benefits from larger segment lengths, whereas small segments perform better on mimic3, which are clinical notes. So we also observe separating document into overlap segments is better than disjoint segments. And small overlap segments perform well on both mimic and actor. So finally, we compare these long document models processing up to 4,000 tokens against the baselines. We observe a clear benefit from being able to process longer text when these datasets, for example, mimic and actor, consist of documents with more than 2,000 tokens. But the benefits becomes much smaller when your datasets, for example, the other 2 datasets contain documents has around 700 tokens. So here are some takeaway messages. If you work with long documents, saying these documents contain more than 2,000 tokens, long format may be a good starting point because the default configuration is very robust and it does not require hyperparameter tuning. On the other hand, hierarchical transformer can further improve the performance, but it requires careful hyperparameter tuning, especially regarding how to separate the document. That's all. Thank you for your listening.
Cool. Thanks, Dai. And we'll move straight away to the next talk, which is attack on unfair term of service, close detection, a case study using universal adversarial triggers. And we have with us Sansa.
Yeah.
Okay, cool.
Oops.
So do you already have presentation rights?
Oh, yeah, but sorry, my Zoom is not working.
Cool. Who else is presenting in this session? We have AraLegal-BERT. Who is here to present AraLegal-BERT? No one. Okay. And then no. And then it's an efficient active learning pipeline for legal disclassification. We have the presenter here. A legal approach to hate speech. No one here yet. And then it's validity assessment of legal will statements as natural language inference. We have the presenter here as well. Okay, so for 2 papers, we still miss the presenter. But we have time, so no worries.
She's coming up on hers and it's saying she's sharing, but it doesn't.
Yeah, but are you gonna share from your laptop?
Yes.
Do you have? Yeah. Just share from your laptop. We don't have to do anything in this laptop.
Okay. Okay.
Okay, cool. Let's start.
Hi, my name is Shanshan. This is our work, attack on unfair TOS clause detection. Okay, TOS, every day I've read and understood the terms of service. I don't know how about you, but I almost never read it. But sometimes they do include unfair clauses. So it would be great if we have some NLLP technologies to help the customers. But in the meantime, can imagine some TOS drafter might want to bypass the screening. And previous work have already shown that transformer-based classifiers are vulnerable to adversarial attack. Even slight text modification can cause incorrect classification. To the best of our knowledge, adversarial attacks remain unexplored in the legal NLP domain. And in our work, we have successfully attacked unfair TOS detector with universal adversarial triggers. We have also used artifacts from the training data to attack, and the results show the threat posed by leaked training data. We did also human evaluation to study the detectability of the triggers, and the results shows that there is a trade-off between the attack effectiveness and trigger detectability. So what is a universal adversarial trigger? Given that we have a text classification task, we want to find a short phrase which we concatenate to the input to flip the prediction label. So it's universal, so we can insert the trigger to any input in the data set. For example, here we have two unfair clauses. Once we insert the trigger, the model's detection flips from unfair to fair. For the details of trigger generation, please read our paper. So we worked on the Claudette data set. We binarized the label to fair and unfair. For the victim model, we fine-tuned AraLegal-BERT on Claudette training set, and it achieves an macro F1 of 89%. First, we attack by simply analyzing the training set. We use the words with high PMI as triggers, and the PMI trigger can reduce the model's accuracy to 60%. Which highlights the threat posed by leaked training data. And then we generated triggers with embedding gradients. We found that trigger of length 8 can decrease the model's accuracy to 17%. And the intuition holds that longer triggers are more attack effective. We noticed also that some triggers contain special tokens or subtokens, which are quite obvious to the human readers. So we post the no subword mode, which is slightly less effective than the original triggers. We did also human evaluation to study the detectability of the triggers. The task is given 4 sentences. The participant should identify which one is modified. We collect both answer accuracy and response time. For the full analysis, please read our paper. Here we want to point out that longer triggers are more attack effective, but participants are also better at finding them. No subword triggers is slightly less effective, but they are also more difficult to be detected. So we can observe a trade-off between the attack effectiveness and detectability. So here's the takeaway messages. In this work, we have attacked the model using universal adversarial trigger and shows that transformer-based classifier is vulnerable. We have also attacked by simply analyzing the training set, shows the leakage of training data can pose risks for adversarial attack. We did also human evaluation study, and the results shows there is trade-off between attack effectiveness and detectability. So future work can focus on generating more natural triggers, especially in the legal domain, which may deceive even readers with formal education in law. That's all. Thanks for your attention.
Okay. Thank you, Shansan. And then we have the next talk is AraLegal-BERT. Do we have a speaker for that? Okay, perfect. And I think we have your slide. Right. Perfect. Okay. So let me find them. 65? 64. Okay. And you can see them here. I guess you don't have to download them, right? I can see them already here. Are you okay with that?
How to just.
Yes, yes. We can click the arrows and go from slide to slide. No, no. Let me download them. Okay, I downloaded that. I have to share the screen. Perfect.
Hi, everybody. My name is Sarah Ghassemi, Associate Data Scientist, NL. I'm here to present our paper, AraLegal-BERT, a pre-trained language model for Arabic legal text. Most of us know that the effectiveness of BERT is well documented because it has advantages. Where it is bidirectionally trained, we can fine-tuning your data and the specific language context and the problem you face, as well as there is transfer learning, so you can pre-train your model furthermore, and you can use it in any type on any size of data. But however, its potential for narrow and specific domain is not explored well. For example, when you're talking about legal, the generic approach of the BERT doesn't work well in the specific domain, which is the legal. So because there is significant differences between the vocabulary used for everyday purpose and for specific domain, and it's highly specific terminology. For example, shahada, the word it means certificate when in the domain specific different in general Arabic language. As well as the Arabic language has many challenges in NLP, like lack of Arabic data set. So there is a need to a lot of annotated data to train a language model for a specific task, as well as we have to collect it manually with a lot of work of reprocessing and cleaning. Also, if we have already application or pre-trained model in another language, for example, legal BERT for English is not work well with Arabic. We cannot translate it. Furthermore, there is the morphologically complex pre-trained to the nature and structure due to the lack of dedicated letters to present short vowels, for example, prefix, lemma, and suffix. We have two choices to solve this problem, because if you wanted if you want to focus on legal in Arabic, either continue specializing in a pre-trained model or train a model from scratch with relevant materials from the domain. We choose the second choice. We build AraLegal-BERT from scratch based on original BERT, which is specific to Arabic legal text that we have collected. We followed the same procedure that's done with original BERT model to optimize our model on Arabic legal text. The experiment was based on the data. We have collected all the data manually because, as we said, there is lack of data in Arabic, collected from multiple resources and regions. It was 4.5 gigabyte, 13.7 million sentences with different document types, as you can see the table. We pre-training the model with 8 GPUs NVIDIA DGX with 500K training steps and 152 total batch size in parallel. There was 64K unique vocabulary. Fine-tuning done in 3 common NLU tasks: legal text classification, keyword extraction, named entity recognition, and we compare our result with the 3 language models. These in fine-tuning legal text classification, we use different data. Also, we collected this data: SJB and MOG. In keyword extraction, we made same and collect another data: sentence extraction, then keyword tagging. as well as in named entity recognition, and we have 17 different classes that related only in legal, named entity legal classes. Okay. The result was, as you can see, and the classification for BOG and SJB, they are close, but our model is outperformed, especially in recall. But when we focus on keyword extraction and named entity recognition, we can see the difference in recall. That means there are in keyword extraction 48 of the correct word return back, as well as in named entity recognition. So you can how it's outperformed the other language models. So we can, as you can see, that there are many challenges in Arabic text. For pre-processing is very important. So the word hukum, al-hukum, they are same, but in the text pre-processing considered as different. Also, the text segmentation, sentence segmentation is difficult to the lack punctuation in legal language. As you can see, BERT model pre-trained for a specific domain is better than typical language models for a specific NLU task, also and when fine-tuning stage. Our future work, we make additional possibilities for pre-training other models, Electra, Roberta, and for small pace and large versions of our AraLegal-BERT. Thank you.
Cool, thank you too. And now we're gonna go to the next talk. The paper is called An Efficient Active Learning Pipeline for Legal Desk Classification. We have with us Sepide, right?
Yeah.
Cool. So yes, let me deactivate the share screen here. Okay, so we see your screen. Perfect.
Yeah, that should be fine.
Yeah.
Close the PowerPoint for some reason. I'm supposed to go. I think we're good. Sorry for that. Now we see the random thing. I have no idea what happened. Should I move it here? Maybe. Okay, sorry for that.
No worries. So good morning, everyone. I'm Sepide, a master's student at EPFL, and I'm presenting you an efficient active learning pipeline for legal text classification. This project was done at Distributed Information Systems Lab at EPFL together with my supervisors and co-authors. So this is just to give you an overview of what I'm going to talk about in the next following minutes, and let's dive right in. So the end goal here is to efficiently and effectively classify legal text. And the obvious solution, perhaps, at this point in time in natural language processing would be to take a pre-trained language model and fine-tune it on legal data. The problem, however, is that fine-tuning requires big annotated data sets. And in the legal domain, annotation requires experts' knowledge, and which makes it quite expensive. Unlabeled data, on the other hand, is abundant in legal domain. And the common practice when there is annotation limitation is to use active learning. That being said, we put the following question as the core of our research. How can we leverage the available unlabeled data to make the fine-tuning process with active learning more efficient? And in the process of looking answers for this question, we identified 3 challenges. First of all, legal text contains specialized vocabulary, which has not previously been seen by off-the-shelf pre-trained language models because they are usually trained on general text. The second problem is that, as shown by Reimers et al. In the previous work, the embedding space of off-the-shelf pre-trained language models is not suitable for semantic comparison of sentences using measures like cosine similarity. And this can be problematic because many active learning strategies compare their inputs semantically in some way to find their labeling candidates. And the second problem is that in the most existing works around active learning, it's assumed that for the first iteration of active learning, there already exists a large enough annotated data set, which is not necessarily realistic in the legal domain. So having these challenges in mind, we developed and designed an efficient active learning pipeline for legal text classification. And the main idea here is to leverage the available unlabeled data in 3 phases. In the first phase, we use task adaptation, and we continue pre-training the off-the-shelf model for the mass language modeling task on our available unlabeled data. In the second phase, we use knowledge distillation using a sentence transformer as the teacher model. And the goal is to map the embedding space of the task-adapted pre-trained language model to a more suitable space for semantic comparison. And in the third step, we use initial method sampling, meaning that we take the embeddings after knowledge distillation, we cluster them, and we sample from the cluster metoids to obtain the first set for the first iteration of active learning. We evaluated this pipeline over 2 data sets, Contract and Alloy and LEDGAR, and 4 active learning strategies. And we compared our approach named Distapped Roberta with and without the proposed initial sampling strategy with off-the-shelf pre-trained Roberta, task-adapted Roberta, and legal-BERT. And our results show that the effectiveness of this pipeline, especially when the training data set is very small. And compared to the fully supervised approach, we obtained comparable results with 2 to 3 orders of magnitude less annotation. So to better understand the effect of knowledge distillation stage, we compared the task-adapted Roberta before and after knowledge distillation for the 4 active learning strategies in both data sets. And the results show that knowledge distillation indeed helps and boosts the performance of the model, again, especially when the data set is quite small. And finally, to evaluate the efficiency of the proposed initial sampling strategy, we did some simulations comparing the full data set, which samples from, comparing the standard approach, which samples from the full data set for the initial set, for the initial iteration of active learning, and our proposed approach, which samples from the cluster metoids. And the results showed up to 60% reduction in the annotation effort. So to conclude, we proposed an efficient active learning pipeline for legal text classification. The idea is to leverage the available unlabeled data, which is there for free. And the model outperforms the standard approach and achieves comparable performance to the fully supervised scenario with far less annotation effort. And with that, I'd like to thank you for your attention. I will be happy to answer any questions in the Q&A session.
Cool. Thank you, Shepide. And now we move to the next paper. Do we have Frederick with us? I think so. Okay.
This one. How can I?
It's a PDF? Okay,
Yeah,
let
it's a
me
PDF.
download it first, probably. Okay, and then I have it out of it here. I still try to open it.
Oh, okay. And no, this was the other one.
Okay, sorry.
No problem. We have time. Yeah, we have time.
We have time.
Yeah.
Okay. And I'll put it to full screen. You have to go here, share screen and share. Just that. Okay, but now the people in the room don't see anything, of course. So I have to go out. Move this as well here for some reason.
People in the Zoom conference may see it, maybe.
I have to bring the window back here. So I have to go the other way around. Yes.
Maybe just share the full screen.
Where is the view button? Maybe use the view is here. This one. Okay.
Yeah.
And now I have to share. Now I have to share the PDF. Okay. Do people in the Zoom have access to the slides?
Yes. Good morning, Frederica.
And I can, how can I go to the next one?
Okay,
Okay, it works, I think.
have to look here, I guess.
It does not change, okay.
Change the slides.
The slides change online.
But I have to read it actually.
Yeah, the problem is that
Okay, wait 1 second. And maybe I can do both at the same time. Yeah. Okay. Okay, I can manage to do it. Okay, sorry. So our paper, A Legal Approach to Hate Speech, is based on the idea that there has been a lot of hate speech research in NLP, but most of the research has used very vague definitions of hate speech. And we wanted to complement the existing research by proposing a different approach, a legal approach to hate speech. And oh, I'm sorry, but now it doesn't go to the next slide. I'm sorry.
I have zero experience with Windows the last 10 years. So
Yeah, we also brought a MacBook, but then it's fine. I try to look. I try to look at this one.
Yeah, that's a good idea.
No, it's okay. I try to manage. Okay, sorry for the interruption. Yeah, so our idea was to take look at the potential legal definition of hate speech, and what we did is we based our research on the EU framework decision, which is a binding instrument for all EU member states to punish incitement to hatred as a criminal offense, just like a minimum standard. And this will become even more relevant in the future because of the new EU Digital Services Act that will bring new obligations for social media providers to for instance, detect illegal content on their platforms and also delete it. In the future, we also may have a directive that will replace the EU framework decision. So this was our starting point. And what we then did was to look specifically at Article 1 of the framework decision and translated that into the decision tree, a legal decision tree that you can see on the right side. The idea was to have this as a rule-based actionable algorithm with a structure that is actually derived from the legal assessment that a lawyer would perform in order to assess whether an online post, for instance, consists incitement to hatred as a criminal offense. So with this decision tree, we have a starting point that we also use as annotation. So the decision points are annotation labels, and we use it also then for classifier training. And later on, we can again use the classification output of our submodels and bring this back to the reasoning structure of the decision tree.
Right. And with this decision tree, we wanted to find out whether the annotation or guidelines could be used effectively by legal laypersons to annotate data reliably. And to find out, we did an annotation study where we compared our scheme against what we call a holistic approach as a baseline. So in the holistic approach, people also laypersons just got the legal text and were asked to classify data that was handcrafted for the annotation study and decide whether it constitutes incitement to hatred or not. And we compared this with our scheme, and also we had legal experts classify the same data, and the results are on the slides. And what you can see is that our scheme is more reliable, so the laypersons could annotate the data more reliably. And also the annotations produced were more valid, so they had a higher correspondence with the legal experts. And in the next step, we collected more data from hate speech data sets and used our scheme to annotate it and train some models. And here we also compared two different approaches for classification. The first approach is a standard end-to-end approach that most of you are probably aware of. We just used a standard BERT model to fine-tune on the annotated data and just the incitement to hatred label in particular. And then we took our approach where we took all the annotation labels and trained a separate classifier for each, and then used the legal decision tree to come to a final decision. And the results are quite comparable. So the performance is about the same, but our approach comes with the added benefit of higher transparency, since you can trace the decision through the decision tree and identify potential potentially wrong decisions of the submodels.
Yeah, so our contribution are the following. We have a system design that is actually derived from an actual legal assessment. We can use the benefits of neural net classifiers in combination with a rule-based reasoning structure. And we have, this has the advantage of having an easier learning task for each submodel, and we can use the full information in dataset for each training compared to end-to-end models or holistic models, how we call them. The advantage is high explainability and transparency with regard to the actual steps of the legal decision-making process. Thank you very much.
Cool. Thank you both, Frederick and Marius. And now we'll go to the very last talk of this session. Is validity assessment of legal with statements, natural language inference.
Thank you.
So sorry, I'm trying to find a.
Yeah, it's right there. I'm pretty sure we moved it in the.
Thank you.
We moved it here. This is the one.
Yes, yes, correct. Thank you.
But it's already here.
I don't think so. I can try opening it.
Oh my God. Stop sharing.
Yeah.
And we still see the slides from the previous talk.
Thank you. And I
Is this
think
open?
no, I don't think so. But I can
This
try.
is open on the other screen for some reason.
Yeah, I can try opening it. Wow.
Okay.
Yes, there you go. Yes. So from the beginning, but
There was just.
But we have to share first. So let me go first here.
oh, thank you.
Have to go to the Zoom. And I'll move this to the other screen. Let me close the slides. don't see anything on the other screen. Maybe we can. Okay, let's start sharing. And then we figure out the rest. So the screen. And then we'll give me a second. I'll try to do this.
Yes, perfect. Thank you.
Do the people online see the full screen of the slides?
Yes, yeah.
Thank you. Perfect. Hi, everyone. My name is Alice Kwok, and I'm from University of Arizona. And today I'll be presenting our work, Validity Evaluation of Legal Will Statements as Natural Language Inference on behalf of our team. So simply put, the project goal is to explore how NLI models can be employed to evaluate the validity of legal will statements. So to that end, we created a new NLI dataset based on 23 wills that we collected from US wills and probates dataset in Ancestry. And once the data collection is completed, we annotated those wills. And the first step of the annotation was to identify a statement from a will. And after that, we found a law that is either relevant to the validity of the statement or is unrelated to the statement. And we also needed a condition under which the statement is probated or executed to evaluate the validity of the law of the statement. So we added those conditions, like under which, the conditions under which the statement is either supported or refuted. And for unrelated cases, we actually didn't need that information for evaluation, but we randomly assigned those conditions in order to prevent a case where the models just rely on those information. For example, if all the supporting or refuting cases have conditions while all unrelated cases don't have conditions, then the model will just learn that if there is no conditions, it is unrelated cases. So we wanted to prevent that. And once we are done with assigning laws and conditions, we assigned labels such as support, refute, or unrelated based on those laws and conditions. And with the created data set, we fine-tuned NLI models. And we fine-tuned 8 models in total, 4 vanilla transformers and 4 sentence transformers. So let's have a look at the results. And before we move on, we introduced a new metric called group accuracy for our work. And group accuracy is calculated with a group of positive and negative examples from the same statement as a unit rather than each text as a unit. So if a group has 1 or more incorrect predictions, the entire group is deemed incorrect. And the motivation behind this metric is that if a model correctly understands a will statement, it should perform well on all examples from the same statement. Bearing that in mind, let's have a look at our result. So overall, the models had a good performances. All the models attained over 80% in F1 scores. However, if you have a look at our group accuracy scores, it is quite low. And these low group accuracy indicates that the models have rather superficial understanding of task despite its good performances. And to understand whether the models correctly rely on all 3 types of inputs like statements, laws, and conditions, we did a evaluation study. And the results shows that the F1 score is very lower than the original ones. And in the original settings, these models all had over 90% of F1 scores. So with that, we can see that those law and condition both matter to the model's predictions. And we also tried understanding the behavior of models with local interpretable model agnostic explanations, or LIME, which provides explanations on the machine learning classifier's behaviors. And the results from the LIME showed that our models correctly rely on all 3 types of inputs, statements, conditions, and laws, but it also revealed that in some cases, our models rely on incorrect tokens. And what we mean by incorrect tokens is the tokens that is not intuitive to humans. So in this case, here the statement is intending to excuse the executor from filing inventory. And this is neither not contradicted by condition nor laws. So this has to be classified as support case. However, the model wrongly predicted this as unrelated case based on tokens bearing little semantic relevancy to the gist of the text, which is like making, and, or the. And this shows that there is still a room for improvement for this task. So here's our conclusion. So we introduced a novel NLI data set for evaluating the validity of legal use statements. And with the newly created data set, we trained NLI models, and the results show that our models trained on our data set perform reasonably well on a task assessing the validity of legal use statements. And subsequent evaluation study demonstrated that the models rely on all three types of inputs, statement, law, condition, when making a prediction. And low group accuracy score and line results suggest that the model's understanding of the task is superficial, and there is still a room for improvement for this task. Thank you.
Cool. Okay, so this was the last talk of the session. We saw 5-minute presentation. That was a lot, but as long as we remember the presentations, we should take questions because we have all the authors here. So any question for any paper we saw so far? Yeah.
Thank you. I wonder for the entailment, there was a paper that used entailment, Santos. If you use a generic one, or do we need I heard about contract NLP, I heard about entailment in the last paper. Did you use a generic one or a legal specific one, or what do you recommend in terms of entailment for any of these legal tasks?
So in general, we have observed that there is something called transfer or generalizability performance. With a normal BERT, even if you fine tune for a longer time, you can achieve good performance on the source data, but you want to transfer to the unseen data, we need a domain specific pre-trained encoders. Yeah. The entailment, when you have your fixed set of hypotheses, because our hypotheses are the articles, case law articles. So it's like, let's say a couple of articles which you have known during the training. For them, using a normal BERT helps. But for the articles which you have not seen during the training and wanted your model to perform better in the test time, having a domain pre-trained BERT really helps there.
Okay, cool. Another question? Other papers? Catalina and Daniel, you let me know if there are anything online because I can't
Yes.
check. There are more questions right now. Do you want to take? Oh yeah, here. Cool.
Yeah, question to the last presentation. So you evaluated which tokens were relevant to the models. Did you also gather data on which words were interested or were relevant for humans for the final decision, so that you have like a ground truth that you could compare future analyses like this to?
One of the other co-authors. This is work in progress. That's a very good point. And we're working with a domain, with a team of legal experts, and we're preparing a journal version of this paper that will compare sort of the human assessment of the classification against the machine. So there is overlap with the machine classification, but the overlap is not great. So there's a very long and interesting discussion there. But yeah, that's exactly what we're doing. Thank you.
Jerry has a question.
Yes, I have maybe 2 or 3, and then I keep coming back. Yeah, hi, I'm Jerry Spanakis. I'm from Maastricht University. I have a question for the terms of services paper. Great. Yeah, I was trying to find it. So, as far as I understand, you insert these triggers quite randomly, right? So, or at least what I'm going to say is that the adversarial text in the end you get, it doesn't make any sense, right? From I don't know, language point of view, right? So is that the case for all cases? Because I mean, what I want to say is that one criticism for all these adversarial attacks we do, at least, from the main NLP, is that, yeah, okay, but the text you generate doesn't make any sense. So in any case, it won't appear. So do you have a comment on that?
Yes, you are right. They look quite obvious to the readers. That's what we suggest. The next step is to generate natural triggers. So there are already studies use generate triggers with generation like a GAN model or something. That's a very interesting future direction to work on.
I can keep going now, but I have. You can alternate, yeah.
If I can have one more. Just to introduce myself, I'm Diana Inkman from University of Ottawa. My question is from Jonathan Lee for the first paper on efficient legal adaptation, if it's online. Is your approach a kind of form of further pre-training on that data, and you are doing it in an efficient way?
Yeah, exactly. So the approach is we take some large unsupervised corpus, like, for example, many unlabeled Reddit posts from Legal Advice Reddit, and then we use prefix tuning to, essentially perform pre-training on that data to give us a domain adapted prompt.
Right, so you are further pre-training a BERT model, or
Yes,
what?
correct.
And what do you
so
mean by prefix learning?
Oh, yes. So prefix tuning is an approach that's fairly recent, that has been proposed to reduce the number of parameters that you need to train. So you start with like a frozen language model, something like Roberta, and then you add some prefixes to each of the layers. So essentially you overwrite or you concatenate some values to the key and value matrices in the attention computation. And that allows you to train the model while freezing most of the parameters. And like in the original paper, they show that doing that, you can get away with training around 0.1% of the parameters, but still like have comparable performance to training all of the parameters. And so what our work does is we look at how we can pre-train using prefix tuning.
Thank you.
Yeah.
I can do a very short question to Jonathan as well. Is this close to what adapters do to the models? Because you say you just introduce some extra parameters to the key and value matrices.
Right. So adapters are a different kind of parameter efficient tuning that inserts neural networks between the layers of the transformer, if I recall. We're using prefix tuning, which is, separate from adapters. It's a separate parameter efficient training method. But again, like we didn't introduce prefix tuning. We're using prefix tuning and applying parameter efficient pre-training or domain adaptation.
Cool. And do you have any intuition why this method, although it uses so few parameters, has better performance compared to?
So I think actually like the inspiration for the original method comes from like, you can prompt GPT-3, for example, with like, this article falls under the category of, right? You can use natural language to prompt a model to do some zero-shot classification, right? So if you can tune some continuous embeddings, so like, what if like instead of having like word embeddings, we can just optimize whatever embeddings we want to the model, right? So ideally you could train some prefix that's perfect for the model to give the output that we want. And that's kind of like the intuition behind prefix tuning is we train this continuous embedding that we feed into all of the layers to try to modify the behavior of the network to do what we want.
Yeah. Cool. Nice. Any questions in the room? There is a question in the room, and then maybe I should give questions to the online people. Catalina, do you want to go first with online questions?
No,
or-
just go ahead with the room questions and then I'll ask my question
Okay.
later.
I have a question for Santosh. Do you remember what the accuracy of your predictor was for the case outcomes? For the legal case prediction?
So the accuracies remain the same, or it's better, marginally better compared to classification variant, but the entailment variant has consistently performed better compared to the numbers are, let's say it's around 70 for task A and 80 for task B, and it has been plus 2% when using the entailment method. But the more interesting observation is in macro F1 score, which means it helped for sparser articles or the articles which are less alleged. For them, the entailment approach really helped.
Cool. And I have one question for the AraLegal-BERT. So I guess it's the very first approach to Arabic legal NLP, which is great. And I want to know if you have any future plans for releasing datasets or new models or whatever.
The dataset itself?
I mean, you have future plans to release more resources?
Yes, we will release this, but under the policies of our company, but it will be released soon, inshallah.
Any other future plans?
We will make it the other version of BERT because what we done is the base. We will make the large and small.
Nice. Catalina, I think you can.
Yeah. So good morning from the Netherlands, where it's still very dark outside. I actually had a question for Frederike. So I was fascinated by the paper, and I was wondering, and perhaps this is a little bit more of a legal question, which also reflects my legal background. I was wondering what kind of issues did you come across when working on the operationalization of the legal framework on expression of hatred, because of the fact that this is a concept that leaves so much discretion for interpretation that very often cannot be formalized. So I'm just curious what your discussions have been in the team while writing the paper.
Yeah, thank you so much for the question. Yeah, a lot of challenges. First of all, different legal systems, different legal regimes across the EU and worldwide, because as you may know, US have a totally different concept of free speech. So this was one of the reasons why we focused on EU law. And we also wanted to have start with this as a minimum standard that you can extend, that you can also use for specific regulations in different EU member states. What we experienced was that it was easier to detect, for instance, groups that are discriminated, but rather difficult to detect conduct. So what does it mean to incite hatred? There's a lot of possibilities to express hatred in a tweet, for instance. You may be able to identify the group, but there are just so many possibilities in the language. And one way to tackle this might also be to look at court decisions, or to, or this is maybe for future work, to go beyond the legal assessment that we see in the legal text and attach case law, try to operationalize different situations or groups of cases that have been decided in the past, and but it remains challenging. Yeah.
Thank you so much. And maybe just to follow up, Ilias, before we move to the next questions. So I find this fascinating, Frederike, also because perhaps also for those in the room, at least in the European Union, with some new regulation, we seem to be moving towards having a need for creating a computational regulatory framework beyond just legal text. So there will be a lot of new topics, I think, in legal NLP in the next years. But we will also have a wonderful panel at the end of the workshop to further address this. So thank you very much.
Yeah, thank you.
Any other question? I have a question for the class action prediction paper. And the question is that if I remember correctly, you saw that long former is outperformed by standard BERT models. So models that were using much shorter sequences, like truncated text, were much better than long former. And I want to know if you have any intuition. Was this the results, and what can you do in the future to improve that?
Yeah, so actually we're using Former for the setup that contains the fact as well. So we believe that the facts contain a lot of mess in their structures, and it was really hard to extract the fact itself. So we would like to do on future work, we would like to try hierarchical models or try different setup and to test out the effect, it's only the facts without the allegations. So we believe that the combination of the allegations and the facts together cause the confusion.
Nice. We have another question. Let's say that this is the last question. We have a short break and then we'll continue.
I had two. Yeah, okay. I think for the hate speech paper, Frederica and yeah, sorry. So first of all, I really like that you split the targets. That there was one target for the hatred and for the group. I was wondering, what was the performance difference maybe among the different groups you had, or maybe even the hatred versus the. So was there some group maybe that you underperformed?
Yeah, so there were differences in the performance for the different groups, but those were largely related to the amount of mentions in the data set. So no surprises there. Yeah.
Yeah, so also the reason why we did not continue to extend the data set was because our findings were already that we could do this submodular approach, and we could, based on the submodels, we could identify which classifier had problems and why, for instance, we had two less cases in the data set for certain groups, so the model could not learn it.
Okay, so I guess we can close the session and we'll have a very short break for how big it is, like 15 minutes or something. We'll get back at 11.
Please be back by 11 o'clock, and we'll start the
Okay, so it's
keynote
like
speaker.
a quarter or something. You can have a coffee and then we'll come back here for the keynote from Mike Livermore. Yeah, the coffee is outside. Thanks. The process will be at the there's a corridor, which corridor? So if you go to the corridors, there is a monitor and say for this workshop is from this number to this number. So any of the boards that you put or no, I mean you will see a monitor. Okay, we have to say for each workshop what is the numbers. Okay, and then in this range you can put anywhere in that area. Your paper, because you was trying to find all the NLP paper. I thought I found this paper with this nice. Oh, it's nice. I get to see a small I'm going to go to the bathroom.
like the wind blowing through your hair. Well, come on, roll with me till the sun goes down. Texas sun. Say you wanna hit the highway while the engine roars. Well, come on, roll with me till the sun goes down. The Texas sun, oh yeah. Texas sun, caressing you from Fort Worth to Amarillo. Well, come on, roll with me till the sun dips low. Texas sun, Texas sun, oh girl. Texas sun. When I'm far from home and the cold winds blow, stuck down somewhere, folks I don't know. 'Cause you keep me nice and you keep me warm. Wanna feel you on me, can't wait to get back there again. Texas sun. Texas sun. Texas sun. Texas sun. You say you like the wind blowing through your hair. Well, come on, roll with me till the sun goes down. Texas sun. Texas sun. Oh, baby, you're so gorgeous. How about you and me? Take a little trip. In the big body. Take a ride with me, babe. You by my side. How does it sound? You and I. Oh, girl. Take a ride with me, babe. You by my side. How does it sound? You and I. Baby.
Yeah, I think now it's the Keynote.
How do I share my PowerPoint to this
Pitch black like the midnight sky. Eyes like the jungle, you're something wild. Her sweet melody sings wherever I go. Running through my mind, singing this song. Maybe I'll write a letter from this little old country town down in Texas. change, seasons go by. You said hello, you said goodbye.
Oh, did you already get it working?
No, I have no idea.
Okay.
What's the issue?
So the issue is that when somebody's trying to present something, go to the list of papers.
Somewhere over. Maybe I ever wanna live alone in a country town down in Texas. The memory,
Why is the power not on?
I'm just checking. Send it via the generic EMNLP platform. Suppose. Yeah. Sorry to take your brain.
It's not working right now, so I can't do much. Sorry.
We can try later. But there won't be a break.
It is working. Yeah, so
Leslie, anything anything that I can assist you with? Leslie, anything that I can assist you with, or is it the computer that's not working?
The computer itself isn't working at the moment. I have a question for you anyway, though. Paper number 49 said they just sent it. I don't know where it is. I can't check right now.
1 second.
Oh, you sent it a long time ago. Okay, well then we
40.
should have, right?
49. Yeah, 1 second.
49.
Yeah, 49, yes.
I don't have anything for 49, neither slides or video in Dropbox.
I see it. Yes, no, we have 48. No, we don't have it in here.
You don't have it. What can I do?
Do you have it on something? Can you put it on a drive?
This is the same.
No, sorry, we have the slides.
Leslie, did you get that? Daniel said that we have the slides for 49.
Oh, we have the slides. Okay, they're just
I
not.
found them.
Some.
Yeah, they're not in Dropbox, but I'll upload them. I found them on the email.
Are they in the folder?
They will be in the folder soon.
Oh, they'll be in the folder. Okay. Well, I can see the folder. So. Oh, we have the first two.
Oh, the link is not working for some reason. The link sent by email.
The first two papers should be in the folder, right?
Leslie, did you hear Daniel? So the link that was sent via the email for paper 49 does not work.
The email doesn't work.
The link in the email does not
The
work.
link in the email. Oh, that's okay. Well, she's going to try and put it onto a thumb drive right now. We can always swap her out for later. So we have 3 papers that need to be played from the folder, right?
Oh, never mind. I got it to work.
Oh, you got it working.
Yeah, I'll put it in Dropbox immediately.
Well, right now we're trying to find the underlined people because or other underlined people because it isn't working.
Maybe it's better if you just use one of your laptops, right? And call via Zoom and have people present from your laptops.
You want to see this there, you can't write it.
Say that again.
If you want, whatever you open here.
Yeah.
To use there, just open anything, I'll show you.
So for example, this one's going to be the first one to go, right?
I'll show you. Just hold it from there and drag it through that.
Oh, okay. Well, that's easy.
It's like we're having to screen on here and
Presentation, the slides for 49 are down.
We don't know why, right?
and we do phase that.
All right, so let me try some. I'm going to open one of these. And then I wanted to put it. Oh, I have no idea where that came from. Yes, that's why. So I didn't share my.
Can we help you?
Hello. Well, trying to figure out why we put this. Oh, so you reacted that in the 14 now?
Okay, and you're trying to look at this.
Oh, okay, okay. It says that it's plugged in now. Yeah.
Not the one I sent by you. The one I sent by you was like 4 days before. Okay, it's my flight. Maybe it was a bit late.
That's fine. Did you put it in a mirror mode? Can you do that? Because before it was extended. We don't understand.
Leslie, just to notify that it's 11 o'clock for you now, I think.
So I'm gonna say that if you put mirror mode, then you can fix, right? You can do that for now.
That would be great.
Once it's shared, it might overlap. Because that issue, we start saying this screen, and then the people online were watching a black screen, and then the opposite. And then I had to move it, and then the presenter had to be like that to see the slide, and they couldn't.
Summaries.
Yeah, you need to.
Okay, you should be all set, actually. He says your stuff is in the Dropbox now. So I'm just gonna.
Another record.
No, I know, your slides should be in the Dropbox now, and what he said.
What, I have it here.
But you have it.
In case,
Back up. Thank you, sorry about that.
They start from recordings.
That's there.
That's here, yes, in the Google Chrome. This is the local folder, but it's only for people who have USB sticks. And then this is the Zoom one. But the first one is my Livermore, right? So I have to put his slide there. It's this one. And then
Okay, folks, we're going to start in about 5 minutes. Remote here, not here. That's weird. There we go.
That's the right one. And then.
Even if we put it in the calendar. Yeah, because they record distance. All right, cool. Catalina, are you here?
Yes, I am. Yes.
Do you see the full screen mode or the presenter mode?
The presenter mode.
The presenter mode.
We have the same issue.
Stop sharing.
You have to first, I think they have to first put it in the first screen, so you could go presentation, put it in full screen mode. Try to share that. And find it.
What did you press to go to the
F5. Oh, presentation mode, F5.
Put it.
about?
Put it first. Tab.
Okay.
Sure.
got it. So just have to do this.
And you can ask now if this is what it is.
And now you should see the full screen, right?
Yes.
Yes.
Well,
Okay.
this what you did right now is really an extension of the screen. Because if you have this,
Okay. But then we'll go back to mirror mode or not?
you can go back with this, what you created now. It went from duplicate screen to extended mode because you have presenter here and then full screen there.
Okay.
So this acts like your second monitor right now. That's why it created the extension.
It's what PowerPoint
It's what
does
PowerPoint
by
Okay.
default.
Can
Yeah.
you please put it? Can we just see the slides without this? I don't know. I don't want presenter mode. We don't need it.
So
It's okay, but
No, the thing is, you can, it doesn't, sometimes it doesn't act like an extension.
can I see the slides here?
full screen, right?
Yeah.
Full screen without the presenter view at all.
Yeah, just disable it.
Very good.
Okay, now.
And then you just share the full screen. Share, and then you can share the full screen, just the screen, this screen. And then.
Okay, Katarina, you see again the full slides, right?
Yes, I do.
Thanks, God.
So how did you sync it?
And now we completely disable the presenter mode, so we won't have these issues.
Yeah.
So the
Oh,
presenters will see this and not
Oh,
this. Because I guess most people don't have notes or something, so we don't care.
That's actually a good idea.
Do what?
Control Shift again.
Okay, fine.
Thank you. Well, he's not here yet. They might be outside. Where's Nika? All right. Got the issue ready.
Perfect. How we solve it?
So, yeah, so what we're gonna do is we're just not gonna show presenter mode anymore. Just everything's gonna be in.
Okay, yeah, cool.
Yeah, that shouldn't happen. No,
Yeah,
no,
it's
no,
here,
it's
right?
fine. It's just, it won't be in presenter mode. That was causing the issue. with
yeah.
myself.
It is, yeah, it's, I mean, just like mirroring the screen, right? Yeah. I'm just gonna keep track of time. So, I mean, yeah, if we. Right, okay, so are we ready to start? Yep, cool, right.
Come on back, everybody.
Welcome back, everybody. That's the session number 2 of the natural language, legal language processing workshop. I'm Nikos Aletras, and we're gonna now continue with our keynote talk. I'm really pleased to introduce you to Mike Livermore. We had actually the chance to host him in as part of the NLLP talk series that we had, I don't know, probably a year ago or something, and it was like a very, very interesting discussion in one of our papers there. Mike is a professor at the University of Virginia School of Law. He's very, very interested in empirical legal studies, especially using data science techniques and text analytics. And today he's going to present Finding the Law. Mike, the floor is yours.
Great. Thanks all for joining me for really interesting set of papers already this morning, and I'm looking forward to the papers this afternoon. And thanks to the organizers for putting together both this workshop today and also the online workshop that goes on all year, which is really a wonderful thing as well. Okay, so this talk is it's called Finding the Law, and so I'm going to be focusing on two different themes around, like, basically what is the law that we're talking about, right? We do kind of talking about natural legal language processing, and kind of there's this core question of identifying the object of study here. Okay, I start a lot of talks with this quote from Oliver Wendell Holmes, a very famous justice of the U.S. Supreme Court. And this basically this was in 1897. For the rational study of the law, the black letter man may be the man of the present, but the man of the future is the man of statistics and the master of economics. Of course, the gender language here is a little outdated, but other than that, it's very prescient. So over 100 years ago, predicting that we're going to move away from kind of the studying of the law and the doctrines of the law, and then focus on these questions of using economics and statistics to understand the law. Now, one of the things I think Holmes gets wrong about this is the idea that doctrine is going to fade away as an important component of the law, right? So that it is true that statistics, economics, perspectives on the law are very important these days, but it is not the case that black letter law, the doctrines of the law, don't matter, aren't an important object of study, and don't drive decisions in the courts. So one of the distinctions that I sometimes make that I think is useful when thinking about NLP in law, or just empirical study of law generally, is this little 2x2. So you can have two different perspectives on the law that I think are useful. It's useful to understand these two different perspectives. And H.L.A. Hart came up with this distinction, many decades ago. But the idea is that you can either have an external perspective on the law or an internal perspective on the law. So the external perspective on the law is someone who's outside looking at the law from a kind of like a sociological perspective. Okay, so you're not a participant in the discourse of law. You're someone who's trying to understand the law from the outside the law, the way that you would understand any other kind of causal system. Okay, the alternative is an internal perspective on the law, where you come to the law as a participant, like a lawyer or a judge does. Okay, you take the reasoning that's given by courts seriously. Okay, you don't try to look for external causal factors. You look internal to the legal discourse for the reasons that drive the system. Okay, and those are actually, this distinction between the external and the internal is quite an important one that drives research even today. And so one of the ways that you can kind of, just mapping this onto Justice Holmes, is that you can take the quantitative external perspective. That's the perspective of economists. That's the perspective of, others that are essentially predicting what courts are going to do using the entire sociological context. Okay. A qualitative external approach would be like a historian or an anthropologist, okay? Someone who's outside the law, studying how the law works as an institution. Then you've got, by contrast, an internal perspective is like a black letter perspective. This is the idea is that you take the doctrines of law seriously to try to understand how legal decisions get made. And then the final interesting point here for this group is the internal quantitative perspective, okay, which some folks in the NLP community could be understood as embracing this perspective, okay, as one where you take the arguments of the law seriously, you take the doctrine seriously, but you then quantize that, and so that you can use different kinds of techniques in order to understand what's going on. And so I think that's a very interesting field of study that at least some of the folks here I think are engaged in. In any case, this is a framework that I sometimes use to think about that. All right, so another kind of just preliminary set of ideas just to put on the table is 3 different ways, again, of thinking about the enterprise of NLP and law. So one is a law as data approach, what I call a law as data approach. So here, what we're doing is, we treat the text of the data, the text of law, legal text of different kinds, like we all do here, as raw data inputs that we're trying to do something with, okay? Now, what I often am doing with the law and data approach is more of a social science kind of inquiry, all right? So the question is, I'm trying to understand the development of the law or legal institutions over time. We could be interested in using the law as just a kind of a sandbox for NLP tasks. Like we're just saying, okay, can we build classifiers that do like a nice job on this data? And like we could do that with, I like the paper that uses the Reddit posts, right? That's great. It's a great source of data. You could do that with like the legal advice portion of Reddit. By the way, as a lawyer, don't take your legal advice from Reddit. That would be my legal advice for the day. But in any case, you could also do that same, you could have a kind of a similar problem that you set up with, I don't know, anything else on Reddit, like how to, gardening Reddit, okay? I'm sure there's lots of Redditing advice on gardening, and you could build an NLP task that kind of use that data. So you could just think of the law as like one of the kinds of data that we might be interested in for an NLP, training or, testing models or whatever. Another approach would be the law as code approach. So the law as code approach, there's a whole field out there that's a little bit adjacent to, but is distinct from what the folks do here, which is oriented towards thinking and trying to model the law as a kind of logical executable program, okay? To say that the law is a set of concepts or structures or, that you could then translate into symbolic structures or forms of symbolic reasoning, and at least in theory could execute this as code. So the hate speech paper, right, embodies a form of this, right? You have a decision tree, you say if this, then that, and then you kind of structure your decision tree. And so that's the law as code approach. And there's a whole field of journal AI on law is really big on the law as code approach. And there's, people write papers on that all the time. And then you have hybrid models, right, that try to instantiate some overlap between the 2 different approaches. Actually, that was really nice. The hate speech paper does this, right? It says that you build the the kind of formalized structure of the law that you're kind of reading off of the code, and then you then kind of parameterize that, or you then kind of use that as a guide to to then building out a model that's fundamentally data oriented. And so this is that I really see these hybrid approaches as probably a very important kind of domain for future research that is at the intersection of like kind of more traditional AI knowledge representation, expert representation approaches, and then using that domain specific knowledge to do a better job of essentially representing the law as data for whatever your task might be. Okay, so these are preliminaries of just kind of situating how I think the project that a lot of folks are engaged in here fit within kind of broader discourses around law and the study of law, kind of the academic study of law and also legal practice. But what I really want to talk about today is questions around law search and a couple of projects that I have that are relevant for that. So, okay, so I'm going to talk about this question of finding the law in 2 different contexts. One under the law as code domain, okay? And then the second one under the law as data domain. So one of the things just to start with is, a prerequisite for legal reasoning in any context is identifying the substantive legal doctrines that are relevant for a legal question, okay? So can I fire this person? Can I lawfully fire this person? Well, how do I know if I can lawfully fire this person? I have to know what the contract is. I have to know what the relevant law is. I have to know something about labor law. I have to know something about discrimination law. And there's going to be, specific legal texts that are relevant to that question, okay? So this is actually a really interesting and under-theorized part of legal reasoning is that preliminary step of identifying what are the legal documents that are relevant for a decision. And And so, this is actually a preliminary of law as code thinking. Okay, so if you're going to build your decision tree, okay, about whatever legal question you have to know, what are the legal texts that I can then extract out the kind of, the legal rules that are going to be relevant for my decision. So again, this is a really under theorized area of law from a jurisprudential perspective, and I think a really interesting one for like people who are interested in NLP and data science and law. So what I call this the problem of law search. Some people refer to legal research. I think that's a bit of a misnomer, but the idea is that you're doing the search process over law. So I have a project on this that I've kind of had for several years that I'll just talk to you guys a little bit about. Okay, so you can model the problem of law search as one that involves like a couple of different, there's different ways of doing it, but the way that we kind of decided to structure the question of law search is that you're navigating over a corpus of documents, and there's going to be ways that you move between different documents. Okay, so the way we structured this is textual similarity and citation information. It's a pretty natural way to do this. I think it's actually pretty close to how lawyers actually navigate over a corpus of text. So citation information encodes an enormous amount of information. So in judicial opinions, certainly in the US, there's citations of prior cases. That's an incredibly interesting resource, because it's basically a court saying, we think that these are the cases or the sources of authority that are relevant for a legal decision. And then you have a long natural language description of what the relevant issues are. It's really an incredible resource when you think about it. And so you're moving through this, so what you can think of the process of law search. So if I'm a lawyer or, a regular person, but mostly a lawyer, and you have a legal question. So the legal question here is, what if any limitations on sentencing discretion are constitutional? This is in the US. And then here are US Supreme Court cases that are relevant for that question. And so you might do a text search to try to get some cases, and then you might look at the cases that are cited, and you move through the citation network, and then you find other cases, and then you identify snippets of text, and you do other text searches, and you kind of construct your list of relevant authorities that way. Okay, so this is kind of a heuristic model of how one might engage in the process of law search. So you've got citation information and textual similarities. These are very natural things that we could try to leverage. So the way we constructed this is we developed two notions. One was the notion of the search space. So it's a way of constructing the documents over a multidimensional space in which citation and textual similarity are going to define the distance metric. And then we're going to model different search strategies over that search space. So how do you navigate over the search space to identify the documents that are most relevant for your legal question? So, okay, so step one is to build the search space. And we have a paper on this, kind of each of these steps we have different papers on. And then we have models for how you navigate the search space. So one model is what we call the proximity model, which just instantiates the search space. So you start with a target document, which you can randomly select those. We assume that you get that through like a natural language search. But anyway, that's the red document. And then we just find we just draw a circle around that and say, what are the closest documents in our search space to our target document, our originating document, and that's the proximity model. And then so you would just return, depending on how many recommendations you want, you would just say, okay, what are the closest documents to the original document? And you could just get a return of like 10 documents or whatever. Another approach we call the covering approach. This is like slightly more sophisticated. What you do is basically you don't want to cluster too much around the source document, so you kind of shoot out in different directions in the multi-dimensional space. So this is a toy representation of it, but the idea is that you've got a big multi-dimensional space, and you kind of find a close case in one direction, and then you kind of go out in different directions to identify cases, all within a relative area. And then finally, we have what we call the adaptive model, where what you can think of the proximity and the covering model as having kind of corner solutions to two different strategies. So the proximity corner solution is to go really deep in a small area, and the covering is a corner solution that goes in lots of different areas. So it's, you're balancing breadth versus depth. Okay, and so the adaptive model is you just learn how to how to balance those things from the corpus that you're dealing with. Okay, so we'll describe how we do that. So that's by far the most interesting one that we have is the adaptive model. So how do we actually do this? So we've done a couple different versions. For data, we use Supreme Court decisions of the US. We also have used the appellate court decisions of the US appellate courts. Again, we have citation networks. And then for textual similarity, we use topic model representation. You could do word embeddings or some fancier stuff, but we like topic models because they're kind of simple. So that's how we construct the space. For the adaptation model, we use a reinforcement learning algorithm. It's actually, I think, a really interesting insight, not mine, one of my co-authors came up with in order to train the model. So what we do is we take an opinion, take the US Supreme Court opinion, for an example. We take the citation information out of that opinion. Okay, so you just have the text and then you have the citation information over here. We then we pull that opinion out of the corpus, train the whole model without that opinion. And then we go back and we say to the model, okay, from the text here, predict the citation. Okay, and we do that over and over and over again. So that and the parameters that are being learned are this breadth versus depth parameter. Okay, so that's what's being learned. But what I think is the really interesting, useful insight here is there is a ton of information. There's a ton of data that you can use to train this model. Every single document includes a natural language description of a list of relevant cases that are embedded in the document too. We actually do this in a very high level way. We have a topic model representation of a case. We have a citation list. You can actually do way fancier stuff than that. You can take it down to the sentence level, certainly the paragraph level, and you can say this sentence is, stating that this opinion, this opinion is relevant for this sentence. So, so there's a lot of really interesting stuff that you can potentially do with this. And so we're really just doing a proof of concept for how we in these papers. So in any case, that's how we constructed the model. We use US-based decisions for this. There's a couple of different ways that we kind of test the model. One is on that prediction task, and we just have standard kind of performance-based metrics. There, I think the model performs quite well, but it really depends on what you think the baseline is. I mean, basically, it's a very difficult task. So the paper, one of the other papers I thought was very interesting today was the the predicting class action lawsuits, right? So the base task is really hard. So lawyers can't do it, right? You start with a 50-50 coin flip and the lawyers get up to 53 or something like that, which is real bad. And then it's amazing that the model can get up to 60%, but it's a very hard task. And actually this is a hard task too. Taking a legal opinion and predicting the citations that are going to be in that opinion is something that is not easy to do. And we're getting like recall of like 15%. Precision around that, some precision a little bit more, which I actually think is quite good, but it's, in any case, that's the prediction task. But we also have a related ground truth thing that we have here where we look at, and we have student RAs that are given a task, 7 student RAs, small group here. We have them assigned, they're given a random Supreme Court decision and they're asked to find 10 similar Supreme Court decisions. And they do that, and then we see, what's their intercoder agreement. And so what you're looking at here is essentially the students' intercoder agreement compared to the different models and how much they agree with the students. Okay, we're not worried about how the models compare with each other. And so what you see is, there's actually a fair amount of divergence within the students, and the models are not performing at the level of the students. They're not agreeing with the students as much as they agree with each other, but they're kind of moving in that direction. We're kind of getting more sophisticated, and the adaptive model is performing in the neighborhood of the students. I think I'm certain we can improve on that. And we have a very simple, in some sense, kind of model that we use. So, okay, so that's kind of the outcome of that line of papers that I did, and this with a bunch of collaborators. Let me just show you the collaborators. So it's a big group of people there. But I think not a humongous, but a reasonably sized team. So I think there's a couple of different lessons that we get out of this project for the domain. So one is this problem of search is really core for the question of legal reasoning. Like if we want to build models of the law and models of legal reasoning, like one of the basic things that we need to do to get on top of is this question of identifying relevant documents. That's like really fundamental thing. And it's something that I don't think the field is focused on nearly enough. I think if we could get on top of that, that would actually take us a very far way in questions of, using NLP tools to think and to make the law more accessible. Like it's one thing to have, like in the US, you can actually get access to all the statutes, you can get access to all the cases, and it's totally worthless. Like no one knows what to do with that information. So if you actually want to make information usefully available to the public, search is like at the core of the problem. And even summarize, so that, say you get a really good summarization tool, you still need to know what to summarize, right? And so search is like upstream from a lot of these tasks. So that's one, I think, interesting issue here, or interesting kind of outproduct of this project. Another one is, I think that this data set of text and citations is super underutilized and something that could be taken advantage of in the field. We've written it much a couple of times, but I'll just say it again here. Like we're talking about lots of examples of really interesting, important stuff that the field really hasn't taken advantage of. And so smart NLP people, with this data should be able to get better and better and better at this task. One of the things I think is really interesting and that no one's done yet, which would be cool, is to go in the other direction. Okay, so getting a list of citations and then producing text that would be associated with those citations. So that's I think a really cool problem. The fact that we can go text to citations, at least in an okay way now, and probably in a better way if we get serious about it, would indicates to me that you can go in the other direction, right? Which would be super interesting, right? Because that's basically a version of a summarization problem. Okay, so that's that first project. So the other issues that I wanted to talk about today is this question of finding the law, but more from a law as data problem. And so here, what I'm focus on is the problem of sampling bias in judicial decisions. Okay, and so this is a problem in the U.S. context. It's also a problem like basically everywhere, because I'll talk about the U.S. because it's the system I'm most familiar with. But the reality is that the portion of judicial decisions that are actually available is a very small, non-representative set of the total body that you would be interested in. Okay, so if you're building a model, say a predictive model of the law or whatever your model that you're trying to build is, you have this problem, which is essentially your data is extremely biased. Okay, and this is something that has been only somewhat recognized in the U.S., even in the U.S., where people have been kind of doing studies of judicial behavior for like many decades. So, just to kind of set this up to give you a sense of how serious the issue is, or kind of how it affects kind of research. So there's decades of social science research in the U.S. and in other countries. The goal of which is to understand the influence of different factors on judicial decisions. Okay, that's something that political scientists, economists have been interested in for a long time. One of the major questions in the field is how characteristics of judges affect how they decide cases. Okay, so you might ask in the U.S. whether a judge being a Democrat or a Republican matters for how they decide criminal justice cases. Okay, or you might be interested in whether women decide cases differently from men judges. Right, and these are questions that social scientists have studied. Right, and what they do is they take data sets of judicial opinions. One of the things that we have that's nice in the U.S. system from a research perspective is that cases are assigned randomly to judges. Right, so you just get a random draw of cases. So that's interesting. You get a random draw of cases, goes to the judge, and so the judge, in theory, you should be able to say, well, if Democratic judges, let's say in cases with criminal defendants in front of Democratic judges, the criminal defendant wins in a higher percentage of those cases than before Republican judges, you should be able to infer, because of random assignment, that Democratic judges are more lenient than Republican judges. And in fact, that's what social science research has found, and that those research findings have had a major role to play in political discourse in the US, where people worry about the difference between Republican and Democratic judges and how they decide cases. So, okay, so this is like background for understanding the problem of sampling bias. So we've been using publicly available judicial opinions for like literally decades to study this really important question about the rule of law and the role of politics in judicial decision making. And we've come to conclusions about these questions that have then influenced our political discourse. Okay, now what's the problem? Well, the problem is that the data that these studies have been based on is totally problematic. Okay, now why is that? The reason is that only some decisions are published and therefore available. Okay, now I actually gave a talk years ago, kind of on an early version of some of this work. Anyone heard of Judge Posner, by the way? Does anyone know who Judge Posner is? Okay, so this is a NLP crowd, not a legal crowd. Judge Posner he's a famous American jurist, and he anyway, when I posed this problem to him, he said, "Oh, this doesn't matter because the opinions that are available, those are the important opinions. You don't have to worry about the unimportant opinions. So we can study the important opinions. Who cares about the unimportant opinions? And if Democrats decide important cases differently than Republican judges do, that's important." Okay, it's not important what happens with the unimportant cases. Okay, Judge Posner, the problem is that it's not the case that the opinions that are selected, okay, so his model, his theory went something like this. There's case features, okay? So you have the influences that are gonna affect outcomes, okay? So the influences could be things like case characteristics. Did the person shoot the other person in the head? Okay, if the answer is yes, that's a case characteristic. That means it's a criminal case. That also means that the person is probably guilty. Okay, there also could be judicial attributes, like whether the judge is a Democrat or Republican. Then there's the outcomes. And what are the outcomes? The outcomes are dispositions, okay? Then there's a publication decision. And if the answer to that is yes, then you actually observe the opinion content, okay? Now, under Judge Posner's theory of the world, one of the characteristics of cases is whether it's important or not. And then that is what determines whether the case is published or not. Which is all fine and good, and that actually may be true to a certain extent, that the opinions being important is one of the things that matters for publication. But if judicial attributes interact with case characteristics to affect the publication's decisions, then you're completely confounded, okay? You've confounded your causal structure. And if Democratic judges disagree with Republican judges about what cases are important enough to publish, which that might happen, then again, you cannot just say, if that's true, you cannot just look at the world of published opinions and say, okay, Democrats vote in this pool more favorably to criminal defendants, and therefore the case dispositions of Democratic judges favor criminal defendants. You can't say that because maybe Democratic judges are more disposed to publish decisions in which criminal defendants win, okay? And if that's true, then your data is totally biased, right? So the effect that you're seeing, Democratic judges, defendant favoring outcomes, could just be the result of publication decisions and not the result of actual case dispositions being different. So that's my response to Judge Posner. It took me 4 years to come up with that. Okay, so now that's a theoretical problem. Is this actually a problem in the real world? Well, we look to see if there were data structures. So part of the problem is that you only observe the pool of cases that we're talking about. Here we're talking about published cases. But one of the things that you can do is you can look at the pool of data that you have, and you can look for structures in that data that is inconsistent with a story in which that data is generated through a randomized process. Okay, so that's what we did. So one of the things so we have 3 judge panels in the US appellate courts. Parties are Republicans and Democrats. And so we know the percentage of Republican and Democratic judges. We also know how often Republican and Democratic judges are on panels that publish opinions in the pool of published opinions. And so we can say is the pattern of panel types, all Republican, all Democrat, 1 Democrat, 2 Republicans, 1 Republican, 2 Democrats, is the pattern in those panel types consistent with essentially a random process in which case characteristics are the only things that affects outcomes, where the party of the appointing president, the party of the judge, isn't having an effect on publications decisions. And what we find is, no, it's not consistent at all. Here, what we have are the different panel types in the brackets are what we would expect in the aggregate in our data. We look at, 40 years worth of data in the US appellate courts. And what we find is that for all panel types, there's a statistically different and substantial and truly substantial difference for 3 of the panel types, all R's, DRR, and DDD. And what you see actually is that, interestingly, there are more than expected uniform panels of all the same party, and there's fewer than expected 2 R's and 1 D panel. And that's very consistent with a story in which the Democratic judge says, oh, I don't like that outcome. If you don't publish it, I won't dissent, right? And so then what you get is you get fewer published opinions and mixed panels, which actually is the case with both of the mixed panel types, but it's just significant with the 1D. So in any case, that's interesting. And that's telling us again that our data it's not consistent with the story in which only case characteristics are driving publications decisions. It looks as though panel type is part of the story, and at least some kind of judge characteristic is part of the story. Another thing that we do, we run a topic model on the decisions. One of the things kind of in my way, the way I think about topic models is just as a simple dimensionality reduction tool for texts. And so we've taken our high dimension object and we've reduced it to distributions over 50 topics. And then we look at the relationship between those topics and the panel composition, how many Democratic judges are on a panel. And what we find is that there's correlation and quite strong effects between topic proportions and judges. Again, this doesn't make any sense. There's no reason why this should be if the only thing that leads to publication or not are case characteristics, because case characteristics should not be correlated with judicial attributes. Why? Because cases are randomly assigned to judges. So the whole structure is such that it's not supposed to. And we control for things like geography and time, right? In these regressions. So these are coefficients on in a regression that has time and has year and place circuit controls. And what do we find? We find that the topics are correlated with the judges, okay, with judge characteristics. So again, this is telling us that our data sample is really biased, right? There's something going on here where different judges are deciding to publish different kinds of cases. And what that means is that we can't draw inferences from this data set about judicial behavior at all. So it's not just we can't draw inferences about from this data about how judges act on the larger pool of cases, right? That's different. That's saying, oh, that's a model. That's a kind of external validity concern. This isn't an external validity concern. This is an internal validity concern. This is saying that you can't even make predictions on the pool of published opinions because you're confounded. Okay. All right. So what are I'll wrap up. What is the important lesson here for NLP for law more generally? One that most of us are familiar with, which is that we have serious data availability issues. Okay, there's just this problem that a lot of data isn't available, and what I want to emphasize here is it's not just that it's not available. What is available is super biased, right? It's not actually representative. If we had a random sample of the law, of judicial opinions or whatever, that would be okay. Wouldn't be as good as having a complete sample, but a random sample would be okay. But it's not random sample at all. It's highly, highly selected by the institutions that we're trying to study, that we're trying to model. So that's a problem. And so as researchers, we want to be carefully attentive to this question. Now, one of the things that I do like to emphasize for researchers here is that doesn't mean that we can't study anything. It just means that we have to be very careful about what we think we're studying. We have to be thoughtful about what we're studying. So in the judicial politics literature, we're not studying the relationship between judicial attributes and case outcomes. We're studying the relationship between judicial attributes, case outcomes, and publication decisions conjoined. And we haven't figured out how to separate those things. But that doesn't mean there's nothing to study. It's just that we have a phenomenon that's a little complex, okay? Often, I think, in the NLP literature, what we're predicting are not things like legal decisions often. We're predicting things like justifications for legal decisions, okay? And that's just worth us recognizing, is that we're not predicting outcomes, we're predicting justifications. Still interesting, still worthy of study, but just sometimes different than how we characterize what it is that we're studying. Okay, so with that, I will wrap up. Happy to, those are my collaborators on that project, Dan Brockmore and Keith Carlson, and happy to take questions and hear your comments. I'll split up that pretty picture.
Thanks a lot, Mike. That was a really great talk. And actually, I'm really happy because a legal scholar uses terms like reinforcement learning and state-of-the-art natural language processing techniques. Really, really cool stuff. I think we've been going a long way as a field. Right. So we have plenty of time for questions. Any questions? Just raise your hand and we take from there. Ilias, I'm just gonna go first.
Thank you for the talk. This was fantastic. And I have a couple of questions. The first one is related to the first part of the talk, where you concluded that search is an important part of the law. So my question about that is, how well do you think existing companies such as LexisNexis serve this functionality?
Terribly, especially in light of the amazing data that they have. I mean, they've clicked through data on this stuff. Yeah, they have a natural language search, and they've clicked through data. They know people tag it. So I don't know how much if you've ever used these tools, but people often say like, okay, I'm interested in some matter. You then start to do a search, and then you get your results, and then so they get the data about whether you click through on the results. But then often you will like put like a star or something by it, just so you know, and you like make a little file that says, okay, these are the things that are relevant for this search query that I did. This is like amazing data. And so I think that the commercial databases are, they're trying to, make some improvements, and they have invested in some of this stuff. But I think that they're, in light of the data that they have access to, maybe I'm just data jealous, right? So like, I just feel like if I had that kind of amazing data and I had the dough that these guys, I could do a better job. But, it's always harder to do in real life, I guess, than in your mind. But right now, I mean, tricky thing is, of course, all of the algorithm stuff, that's all proprietary, and which is normally fine. But when we're talking about the law, we might be more worried about that kind of stuff, right? So in a different project, I've kind of argued that it would be good for the US government to actually it's good to have the commercial ecosystem, but to create a separate, more open sourcey ecosystem around the question of law search, where you have the data available, and then maybe you have some incentives or whatever for, say you have a line under the NSF to fund, private actors to go out there and say, build good search, make their algorithms and make their data available. And then you get a good ecosystem that could, the commercial providers could take advantage of. And then also, like a not-for-profit could say, construct a search tool for regular people to use. And then you would have this, I think, good push and pull between the private sector, academia, and the commercial providers. Right now, I just think the incentive structure isn't right for them to do the cool stuff I think they could probably do.
Sounds like The second question relates to the second part of the talk, where you made a really nice point about the bias in published opinions. So I have a very naive question about that, and I apologize in advance for that. Aren't all judicial opinions in the public domain in the US? So isn't it then trivial to remove this publication bias?
The answer is no. So there's two things. So there's actually several different, it's not a naive question really, because it's kind of complicated. A lot of lawyers don't know this. So there's different concentric circles of data that you might say. So there's what are referred to as published opinions, which are actually opinions that are designated by the court as precedential or for publication. Okay, so that's one data set. And that data set is very easily available. It's been around for a long time. Okay, so and most of the social science research is based on that data. And so that's highly problematic data. Then there's a larger group that's actually called unpublished decisions. And so West, one of the commercial databases, has collected and published this domain of unpublished opinions for several decades in a different collection called the Federal Reporter Appendix. So you might say, okay, great. All we need to do is use that data, right? That's the bigger data, but that's actually not the whole world by a long shot either, actually. So so I have a paper it's basically done that does this same analysis on the unpublished opinions, or the whole pool, published and unpublished, and we find exactly the same stuff. All the same, the topic model, the panel composition, all that stuff is replicated in the unpublished opinions, because those are still highly selected. So you could say that the biggest world are dispositions. So those are just cases that are finalized in some way. And then you could say there's some of them get reported. There's some kind of reported disposition, and then there's non-reported dispositions. And it turns out there's a lot of non-reported dispositions that then, so there you go. That's so even the unpublished opinions that are available do not represent the whole world. Now, what you can do in principle in the US is we have a system called PACER, which is the electronic filing database for the US courts. So everything is in PACER. Like every time someone sneezes in the courts, like it gets written down and put in PACER, right? So that's really nice. The problem is that you have to pay to access PACER, like per page. It's completely insane. And so that's the problem with PACER. So the actual complete data set that we have is unavailable. They don't make it available to researchers systematically. No one has access to the whole thing except for the courts themselves. So that would be the trivial, in some sense, trivial solution. It's technically trivial, but politically, nothing's trivial politically in the US. So it should be, but it's not.
Thank you.
Yeah.
Nikos, just to let you know that we also have a question online. Hi, Mike, and thank you so very much for this fantastic keynote. It was a pleasure to listen to you. And I also added the link to Judge Posner and his profile in the chat if you want to check that out.
Okay, great. But everyone should know who Judge Posner is.
Totally. I'm completely with you on this one. So yeah, and Nikos, we also have a question from Marijn online.
Catalina, yeah, let's go to the online question first, and then Ilias is going to ask a question.
Yeah, so Marijn, perhaps you can go ahead and unmute yourself and go ahead with the question.
Okay, thank you. Good morning, everybody. I had a question about the first part of the talk. As I understand, you asked the students and also the different algorithms to find cases that are similar to the one that you're interested in, and then you check the overlap between those decisions by the students and the systems. But I can imagine that if you ask them to provide 10 similar cases, that maybe there are more than 10 similar cases. There might be 20 or 30. So if the sets can be disjoint, but still everything can be similar. So if you have two students and one student selects 10 cases and another student selects 10 completely different cases, but all of them are actually good. So wouldn't it also make sense to check for each result if it is indeed similar and not only if there's overlap?
Good. Yes. So that is a helpful comment. So there's a couple of quick thoughts I have on this. So one is so theoretically, everything that you described is possible. So for the student portion of the exercise, we had them work with only the Supreme Court data set. So we kind of have done various iterations of this where we ran the models on the Supreme Court, then we ran the model on Supreme Court and appellate court cases, which is obviously a much bigger set. So Supreme Court decisions are like, a few thousand, lower court opinions are like, hundreds of thousands. So the problem that you describe is much bigger if we had done this on the appellate court data sets, because there's a lot of similar cases in the appellate courts. There's actually not that many Supreme Court cases that are all that similar. So the problem actually that came up with the students is they would say, I can't get 10 cases. So we were kind of exhausting, at least what their intuitive notion of similarity was. So I would say, okay, just force yourself to come up with what you think are the 10 most similar cases, even though you don't think they actually pass a similarity, similar threshold. And so that was kind of nice. Also, the other, I don't know if it was nice, but that was a feature so that I wasn't like overly worried that there were too many similar cases and they were just like randomly drawing off of, really quite similar cases. Also, obviously, they're making a judgment about what the most similar cases are. So you say there were 11 that they thought were similar. I would told them to, essentially rank them in terms of most similar. And so it's reflecting that judgment. Yeah, so I think that kind of the features of the data set essentially mitigate the concern that you raise. But I agree, it's a theoretical issue. And it's one that, if we replicate this in the appellate court data sets, we would have to come up with some alternative mechanism like you described to deal with that. Because you would, and just the other thing I'll just add, that's what makes the predicting the citations it's not just a challenging task, like you're going to top out at how well you do at predicting citations from text, because there usually will be more than, say that there are 20 cases that are cited in a judicial opinion, there's very likely to be like 100 opinions or more that are really good candidates for citation or equally good candidates. And essentially it's a random draw off of those. So, you're never, I don't think you could, frankly, could build a model that would be like have perfect predictive power on the citations, because you're predicting what is functionally a random process. And so if you got to like 20, so in any case, I think that's a real limitation on our expectations of how good a system could get at, say, predicting citations from text, especially in the appellate court cases.
I guess in the end, you're not really interested in replicating the current citations, right? It might be interesting to find citations that are good, that are not yet in the text that you have.
Yeah, absolutely. So I think that's kind of, once the model got good enough, then there's like cool social science things that we could get out of the model. For example, like we could say, conditioned on the model predicting, say we've got a text, legal text, and we say, okay, there's the real citations that we see, and then there's whatever the model predicts the citations are. And then we could look at differences, like how is it that the selected citations, do they differ from the predicted citations, or maybe they're included in the list of predicted citations, but are there causal factors that we could try to understand why one judge selects this group of 15 cases where another judge may have selected a different group, and things like ideology or dispositions or whoever, friendship networks or lots of other things could potentially be predictive there. So I think that you're right. There is, if we could get the models, so that we felt kind of confident in them, they would essentially serve as lists of kind of eligible cases for citation that we could then potentially learn interesting things from.
Okay, thanks.
Cool. Okay, Ilias. Okay, cool. I have 3 questions and I will only do 2 in case someone else wants to ask something. So the first question is, so you just said that Margin is his name, I guess. You discussed that, of course, in a document we have like 10 citations and maybe 100 are relevant. So people, when they try to rule the decision, they just try to find the top 10 or just a random 10 out of 100 that they justify their opinion on. But I was mostly worried about false positives that we have in a citation network. So what are your thoughts on how we can deal with noise, like boilerplate citations that they shouldn't be there in the first place because maybe they are not so important to figure out the decision if there is such case, and how we deal with objectivity and bias on the citation. So how can we make better data sets out of the data that we have from the original citation networks?
Great. So again, on the noise, false positive boilerplate question. So the realm of potentially citable cases is massive, just really, really, really huge, like thousands and thousands and thousands of cases. And if you look at a distribution, there are, of course, some cases that are cited a lot more than other cases, but there are no cases that are cited like all the time. Like that's just not something that happens in the legal system. And so it's kind of like, that having been said, some cases are cited like a lot more than other cases. And so you could, in principle, if one of the things that would be interesting, an extension of the model is to say, all right, if the model picks up on cases that are cited all the time, like that, we're not going to really credit that much, right? But if it's picking up, it's kind of like a, some modified recall thing, right? And so you could build a model that kind of took that into account, which is a neat idea. That would be an extension. In terms of objectivity and bias, so I think this is actually a really interesting question because it gets to like, what do we think is happening in legal reasoning and with what's going on with the citation? So, and we actually spent some time in the paper talking about this. So the way I conceive of this is that there is, at least for purposes of our project, we don't need to have a theory that there is like an objectively correct set of cases to cite, right? It's a sociological phenomenon. What we're studying is the cases that judges cite, right? Which is a good thing to study, right? Judges are, they're legal experts. They're not just legal experts, they're the ones that make the decision. Like if a judge says this case is relevant for this outcome, it just is. It's like, that's the ground truth, right? Because they said it, right? They're like magic that way. So we're more than happy. So I don't even know if a judge can be biased in a sense about that. Like they're just stating and it becomes the case. You could have an alternative view about this, right? Which is that, there is like some objective empirical reality to the cases that ought to be cited or that are relevant outside of whatever judgment judges make or we sociologically make about that. And that what you might want to do, then you could have a thing that's like, all right, what's happening in the world, the phenomena that you observe is a noisy signal for the real truth. And then we could have a model that tries to deal with that. But we kind of abstract away from that and just say, we're just studying judgments, relevance determinations by courts. And that's the truth.
Short second question. Very good. Okay. I just want to know in your experience if this judicial attribution to describe like the political party that someone is involved in or favors is a fundamental characteristic only in the US or it happens in other places? Like, is this such a big deal in EU or other places of the world?
Like the political affiliation of judges and how that.
And other characteristics that you consider that are.
Right. So it's so funny because I guess my background is just such that like I just can't believe that politics isn't affecting judges. Like, but maybe that's just because I'm an American and I'm so embedded in politics, right? And so I know that there are folks who have studied this in other contexts and say, and there's been research that shows that, like for example, in Germany, it's a very different system in Germany, right? Like judges are civil servants, they're selected in a very different way than they are. So I think that how you appoint the judges is going to have a huge effect. Now, what I would then be hesitant to say is that I think everywhere ideology is having a lot of effect on judging, but it just might not map up to like partisan politics in a country in a way that's like traceable, or even in any way. It might not link to partisan politics, but that doesn't mean that there's not some like role of ideology or something like that.
Right. So, well, can you hear me? Well, we're running out of time. I'm really sorry. Mike's going to be around during the whole day, so you can catch up during the post session and lunch break. Okay. So now we can move to the paper presentation of the couple of.
Great. Thanks very much. Yep.
Great. Okay, well, thank you and welcome to session 2.
Okay. I think we're good. Let's start sharing. You're muted, right?
Okay, we're starting now. Our first paper is going to be data efficient end-to-end information extraction for statistical legal analysis. Thank you.
Thank you. I'm Wonsok from LBox, and I'm going to talk about end-to-end information extraction for legal analysis. So before we start, let me briefly introduce about us. We LBox provide the largest legal search engine in Korea, and many top law firms and some of the big companies and some government departments are already using our services. Okay, so motivation and contribution. So we want to do some statistical legal analysis. For instance, we want to investigate the relation between the losses and the imprisonment period. For that, one could do that first using some legal search engine, retrieve all the relevant document and doing some information extraction and to further structuralize the data. However, the problem is that legal documents virtually reflect all kinds of social phenomena, and their ontology is usually very broad and very complicated. So the question is how to build the information extraction system that scales efficiently. And our approach, we suggest that we develop data efficient end-to-end information extraction system. And by doing so, no domain-specific engineering is required, and easy to apply, and easy to prepare the data set. And also, their development and maintenance costs are quite low. Okay, so more specific research questions are following. So, is it possible to use an end-to-end generative model for information extraction in legal domain? And also, if so, how many training examples would be necessary? And also, which architecture would be better, decoder only or encoder decoder? Also, which one is better, prompt tuning or fine tuning? So, and this is our approach. We first prepared some of the legal factual description or ruling or any part of the legal document, and concatenate them with the prompt, and then feed them into a language model, and just directly generate the parts. For instance, the factual description could be something like this. On December 8, 2022, A met B and C, and A deluded B with this new such result, and received $30,000 from B, something like that. And the prompt could look like this. Write the losses from fraud in sequence. And the output could be $30,000 in this particular case. And if we use some factual description from drunken driving cases, the output could be something like the blood alcohol level and traveling distance and something like that. And also, if we feed the ruling, and then language model can generate something like the amount of fine and the imprisonment period. Okay, so we really do a lot of experiments, and while we are varying the size of the model and the size of pre-training corpus and the size of trained data and model architecture. But for the detail, please visit my poster. We also do some case study using a 24K precedent from drunk driving cases. And we do some statistical analysis and show how the average imprisonment period changed along the time. And you can see that there's some jump at this time. And it turns out that the Korean government strengthened the punishment at 2019. We also do another study from fraud cases using 11K precedent and just do statistical analysis about the relation between the losses and imprisonment period. Okay, so if you have if you want to hear about more detail, please visit our poster. Thanks.
Okay, our next talk coming up is going to be efficient deep learning based sentence boundary detection in legal text.
Hi all, I'm Reshma. I'm from National Institute of Technology, Trichy, India. So I'm here presenting my paper on efficient deep learning-based sentence boundary detection in legal text. So as we all know, sentence boundary detection is a major pre-processing step in many of the NLP pipelines, like when you want to deal the text at sentence level. So yeah, the existing SPD systems works well for generic corpora, but it poses, as we all know, legal text, it has very serious issues like the language, the structure, the content, everything. It's different, and especially the delimiters used in the text has multiple purposes. Like, for example, the period symbol. You can identify it has an end of sentence, or it could be an acronym, it could be an initialisms or numerical number. Also, it could be a part of citation. So our objective is to identify the period as a true sentence marker or not. Like, it's a classification model to identify it has a end or not. So we used a context surrounding the delimiter as input for sentence boundary detection in legal text, and we use various deep learning model frameworks for classification, and we compared with the state-of-the-art models, rule-based as well as statistical, and also even tested our performance of the models of transformer models like AraLegal-BERT and EMNLLP. Yeah, moving to the data set, we used already a publicly available data sets of 26,000 annotated sentences. And the data sets, actually, it's put in 80 decisions or 80 dogs and in 4 different domains. And we use cybercrime as the test set and other 3 as the training set. Yeah, the delimiter. The composition of delimiter in the data set, like we don't have, we have a lot of data delimiters, like not only period, we have colons, exclamations, etc. But we focused on identifying period because in the data set specifically, the period symbol occurs more frequently as the end of sentence pattern marker. Okay, moving to the architecture, as I've said, we used a context like the surrounding the delimiter as the input to the model, and we used a character-based embedding, and we fed to various deep learning models. Like we have experimented with these models, and we had an optional attention layer for the Bilestians and YGRUs, and then the last vector is fed to the dense layer for classification, binary classification. Yeah, this is an example of the input. And the experimental setup, we experimented with the context size ranging from 3 to 10, and we found that 6, the context size of 6 gives in the best value. And also the transformer models, we used subword level tokens as input because they are pre-trained using subword level tokens. And for the convolution neural network, we have used a 1D convolution layer and with 6 filters and kernel size of 5. So, and these are the experimental details. So moving to the results, like based on the model size and training time, we found that CNN, the convolution neural network model, has a better training time, and even the transformer models, as we all know, it's almost 40 times slower, more training is required than CNN models. Yeah, when compared to the baseline models, we had the rule-based PySBD model and the statistical CRF model, they based on feature conditional random feed model. And since these baseline models are evaluated based on offset boundaries, we post-process our results based on that and at the begin and end token level. And we found that the average F1 score for the CNN model is better as compared to other deep learning models. And also it outperformed rule-based PySBD by 8%. In statistical model, it had a little bit higher score. So we assume that it may be due to it has the ability to identify other delimiters also. So, but when compared to the inference time, our model, like CNN model, it's almost 80 times faster than the statistical CRF models. So these are the error analysis, like the examples, and we have taken few examples, and the sentence that is marked in gray is the original actual sentence, and that which is marked in red, the sentence is predicted by the model. So it's actually, if you want, you can go to the paper and just like we have given the, so some complement and some subsume, some errors are common for both the models. Yeah, and finally, the model classification performance, again, based on accuracy, the model architecture, based on the model architecture, the accuracy and F1 score is higher for the CNN model. So as a conclusion, we have used a context for the deep learning frameworks, and we compared with various deep learning models, including transformers. Also, we use rule-based Phi SVD as well as statistical CRF as baselines. And these are our results. And as overall, we would say like the convolution neural architecture gave the best performance when compared to model size, training, and testing time. So the next steps, we want to explore more sentence punctuations like colons, exclamation, other boundary limiters. Also, we need training data for training deep learning as well as transform models. And also we plan to chain multiple models together, like combining statistical and deep learning together so that you can improve the SPD performance. That's it. Thank you. And I thank my co-authors and my advisor, she's here, Jaya ma'am, and then my co-author, Gokul Aditya. Thank you. Thank you so much.
Great. Our next speaker, our next paper will be semantic segmentation of legal documents via rhetorical roles.
All right. Okay, thanks. Okay, so yeah, today I'm going to present our work on how to kind of automatically segment the legal documents. Okay, it's too close. Okay, yeah. Okay. Yeah, so I mean, there has been overall theme like that legal documents are long and unstructured. So we are trying to address that problem. So wait, I'm getting confused between. So it's not moving. Okay, it's there's a lag actually. Okay.
Oh, okay.
Yeah. Yeah, there's some lag. Okay. Anyways, so yeah, so I mean, the motivation is like, I mean, so like in India, you have a huge population, and consequently, there's like a huge pending cases, like millions of cases. So if you look at like the national judicial data grid from India, there are around like 41 million pending cases. And there was a kind of a rough estimate by one of the leading judges. He said that if we stop filing cases and if we had to resolve these cases, it will take around 350 years to resolve these cases. So, I mean, that you can imagine the scale at which we are addressing the problem. So, I mean, being an NLP researcher, it kind of makes sense that can we use some kind of some NLP technologies to make the entire process more efficient. Even a small change can have a big effect given the scale at which we are working. So, so that's what we try to address in this paper. And but the question is that can't we just use some existing NLP technologies to solve this problem, like of structuring the legal documents? But the problem is that legal documents are very different from regular NLP texts. Legal documents are kind of long. I mean, like in our case, like the average document size was around 3,000 tokens. And then especially with regard to Indian setting, the legal documents are structured. I mean, they are manually typed in the code. So there are all sorts of mistakes, grammatical mistakes, noise, and all sorts of things come in. And then there's a different lexicon altogether. Legal lexicon is quite different. And then also it's kind of, the laws keep changing according to the country. So what we try to propose here is that if there was an automated system that could structure the legal documents, it's going to have a very, very big impact. So that's what we propose. So trying to segment the legal document in terms of semantic segmentation. So for example, here you can see there is a legal document on your left, and then we provide like semantically coherent segments of the document. And we do this using something called rhetorical roles. So rhetorical roles is things like facts of the case, ruling by roll call, arguments by petitioner and respondent. So these are like topically coherent segments in the text, which are addressing some particular facet of the case. And we, in our research, we use 13 rhetorical roles as shown on the slide. And these are the definition for these rhetorical roles was proposed by the legal law professor who worked with us. He's also one of the co-author in this research. And so the final goal is we want to automatically segment the legal documents into rhetorical roles. And this has a lot of different applications. For example, it could be useful for prior case retrieval, something what Mike was also kind of mentioning. And if you have like segments, it could help in retrieving particular segments of other prior cases. And similarly for summarization and judgment prediction and explanation for the prediction. So these are the key, basically we make two main contributions in this paper. One is creating a corpus of legal documents annotated with rhetorical roles. And the second is developing a deep learning model for automatically segmenting the documents with rhetorical roles. So coming to the corpus, so we create a rhetorical role corpus of Indian legal documents. These are in English. And we take two domains, income tax domain and the competition law domain. And so in total, there are like 21,000 sentences. And for each sentence, we have a primary rhetorical role label, but sometimes there is ambiguity in the rhetorical role label that needs to be assigned. So we also gave the flexibility of assigning secondary and tertiary roles to the annotators. And annotators in our case was legal experts, I mean, obviously. And so the legal experts basically included law students and a law professor. And each document is annotated by three experts. And we take the max vote for deciding the final label. And as you can see, there is also like a high agreement between the legal experts for annotation based on the Fleisch-Kappa score. And since I have very less time for the presentation, you can check out more details. We did in-depth study of the annotation and also did a case study for the annotation. And so coming to the second part, so the task of rhetorical role prediction is about segmenting the document into assigning a rhetorical role label to each sentence basically in the document. And so the main intuition behind the models that I'm going to say next is that the rhetorical roles don't change abruptly across the document, but there is a kind of a smooth change, and the labels tend to maintain some kind of topical coherence, and there's some kind of inertia which is there. So we try to exploit this intuition for the modeling purposes. So basically, we incorporate something called label shift prediction, whether the label will shift or not so suppose we are going from one sentence to another sentence, if there is a label shift or not, that's what we try to predict. And this helps in making the final prediction of rhetorical roles. So this is one of the models. Maybe I'll directly go to the final model. So we have a multitask learning model where we have one auxiliary component which predicts whether the label should shift or not, and the main component which predicts the rhetorical role label basically. And so we experimented with lots of different models, some existing models as well, like AraLegal-BERT and all those. And we found that our model performs the best. Basically, having that label shift component helps a lot, basically. And then we also did some cross-domain. We took another data set and we see how does our model generalize across a different data set. That also works well. And then we also did some model distillation experiments. You can check out the details in the paper. And then we also applied the model for judgment prediction tasks. And so the main takeaway is that we can structure the legal documents using rhetorical roles, and we propose some model, multitask learning model for segmenting documents. And in future, we would like to explore more on the more applications, and also if we can do it across domains, basically. And you can check out the paper and the code at this link, basically. And just kind of a teaser. So we are also organizing a semi-val task. If anyone is interested in taking part, please, check out the details on the page. Thanks.
wish you tried it on Supreme Court document.
Yeah.
Okay. Yeah, I think we're gonna have to use it. I don't see anything.
You showed that to me, they were there. Detecting differences between similar text. Yes, yes, thank you very much. Yes, these are the slides. Thank you very much. So I'm Diana Inkpen from University of Ottawa in Canada. My co-authors are two undergrad students, Xiang Li and Zhansung Gao, who are eager research assistants in our new legal tech lab. And Wolfgang Alschner is a professor in Faculty of Law, and we founded this new lab. And I'm happy to see there is a lot of other work going on. So we are focusing on a few tasks, including legal court judgment, but this paper is about trade agreements and so other kind of text, not court judgments. How do I get to the next slide with this? No. I tried arrow. Yeah. Other arrows? And
I think just try to close it, then open it with the PDF here for this to browse.
can you just click on the next slide?
Just maybe try to do this.
Yeah. Okay, so a standard outline. So the main motivation we want to have, when we have highly similar text, lawyers are interested to see if this is an important difference, legally relevant or not. So is it like they are sort of paraphrases, but is it really saying something that's important to a legal researcher, or is just a stylistic way put in a different way? And we use as a case study international investment treaties, trade agreements between countries. Click on the next slide. So we selected a set of sentences based on legal-BERT, but we only use a legal-BERT similarity to select our candidates. For example, here I have two sentences for which a lawyer in our team would say, yes, this is a relevant difference if we look at these two sentences. I have a poster if you want to see more to see the examples in more detail. And on the next slide, I have an example that has high legal BERT similarity, cosine similarity of the vectors, but in fact is irrelevant from the point of view of our users. And we used a specific database. It's called Electronic Database of Investment Treaties by my colleague Wolfgang Alschner and collaborators. And it has almost 4,000 international treaties and pairs between Canada and France, between Canada and US, and they are kind of derived from each other. So for a while, there were some initial important trade agreements, and the new trade agreements were derived and augmented based on those. And that's why these small differences are important for lawyers, especially if they are not just similar, like if they bring new legal information. Articles have some structure, 71 structure categories. They have 144 contact categories or manually assigned when they build this database, and it's available. And it has also some sort of keyword annotations
for subcategories. And our idea is to take two treaties between two different countries and two treaties to see what is the difference between them, align at sentence level. Then for the sentences, articles, and if the article is long, maybe sentences, and say if it's a relevant difference or not. And we didn't manually annotate this. We will build new label data out of this database. We didn't manually label it, but we leveraged existing annotations. And as a subtask, we also had some prediction of structural categories for a few hundred articles who didn't have it. But this was a secondary task. Trying to get to the next slide. So this is a secondary task, structure category prediction. We use a standard deep learning tools with first classical baselines, naive based SVM with TF-IDF, and then BERT based. And we also had an extension where we look at article before or after to provide more context. And I cannot show here very much. Using a bit more context helps a little bit to improve precision, recall, and accuracy. But as I said, this was our secondary task, just to show that predicting the structural categories, there were 61 in the end, because 10 were so few that we had to remove them from the task. The main task was the one where we had 5,000 article pairs for training and number for validation and another 20% of the data for testing, so 60, 20, 20. And we experimented with as many models as we had time, classical, naive based, just baselines, and then Roberta and AraLegal-BERT and more. And here we had this high similarity between all of them, but which were relevant, which were just statistically irrelevant, and which were really different. They're not of interest because they're not aligned. They're all aligned. They seem similar, but they're not. Just to kind of summarize, we look at many deep learning models for detecting relevant differences between otherwise similar legal text in a frame of fine-tuning pre-trained models. We build our data set based on this electronic database of treaties, which is it's not much used. We are the first ones to use it, but it's available there. So all these treaties are available and nicely prepared in an electronic database. We leverage the manual annotation there. It took us quite a while to figure out how can we use these annotations to avoid having to go to the law students and ask them to label data for our specific tasks. But we figure out how to map these categories, subcategories, and keywords to figure out if these two articles that seem similar are indeed relevant differences or not. And then we were able to frame it as a machine learning, deep learning task. And for the secondary task, it was just to predict some metadata that was missing. And we managed to do that also. And for the future work that is of interest to us is to trace, to look more entailment, which treaty entails or article in a treaty entails an article in another, with a goal of saying which trade agreement was maybe used as a draft for another one in our data set, to trace back the historical evolution of treaty writing. For more details and examples of sentences, please come to the poster. Thank you. I hope I don't close your eyes. That's fine.
Now, which one is it? 40. You're gonna present?
Oh, you're gonna
Okay.
present? Oh, okay.
We thought you're not here, sorry. Okay.
GitHub. So can I go down there?
Yeah, sure. But you have to do it fast, please. Yeah.
Sorry, just give us another second here. We're downloading the next talk.
Okay. You have to start sharing this one.
The Zoom is. It's still.
Thanks so much.
Okay, I think we're ready.
Right, hello. I'm Tingwai Terence Au, the author of the paper. Together with Ingemar Cox and Vasilios Lampos, we present EDGAR-NER, a publicly available legal NER dataset. Name entities are names of specific objects in the world. So the task of NER, name entity recognition, is to identify them in a sentence. This is very helpful in other legal NLP tasks, such as record linkage, contract analysis, legal judgment prediction, and question answering systems. On the table on the right, we show an example of the task NER, where we have a sequence of words, and the task is to assign a name entity tag to each word. And by doing so, we identify names such as person names or court names. In the NER community, there are a few existing NER datasets, such as the Cornell 2003 and Onto Notes. These are general English NER datasets. For legal NER datasets, we have contract NER, which, as the name suggests, it consists of contracts. But this dataset is not publicly available. We also have FIN3 and FIN5, which are consist of EDGAR filings from the US SEC. The thing about legal NER dataset is very few of them are publicly available. One of the reasons is due to the cost of labeling. So thus we created the EDGAR-NER, where it consists of company filings from the US SEC EDGAR database. To create this dataset, we arbitrarily chose the year 2010, and we collected 52 filings from this year. And by doing so, we avoided some filings that contains almost no text, such as the example here. This is a Form 3, which is essentially a form for the filer to fill in. We believe NER is to extract name entities from sentence structures, so we avoided forms of this type. To perform pre-processing on the filings to extract the text, we will remove some elements from the filings, such as pictures and tables with no text, no sentences in it, like contains figures and numbers. And we only keep the text content from the filings. During the tagging, we will classify the name entities into one of the 7 classes, as shown on the table on the left. To decide this classification, we took reference from the existing Cornell dataset, which is a widely recognized NER dataset in the NER community. In order to allow comparison of performance for different models on the datasets, the classification can be merged according to the table on the left. On the table on the right, we present some statistics for the dataset we have. one of the conclusions we can draw is that on average, sentences in EDGAR-NER are longer, and the name entities are on average longer as well. We applied 4 different NER models in our experiments. The Cornell 2003 baseline is a word matching method that tags all the phrases during inference if they're seen during the training. And we performed 3 different experiments to train and test the models we have on different data sets. In this experiment, we use the Cornell 2003 to represent general English text and EDGAR-NER to represent legal text. On the right, we show the F1 score, the results of our experiments. The main takeaway is the performance degrades significantly when we train the model on general English text and then apply them on legal text, compared to when they're both trained and tested on general English text. If we instead allow the models to train on legal text, the performance improves significantly, showing the importance to have domain-specific data set for the legal NER task. We have published our data set on GitHub, so please feel free to visit our GitHub to check the data set, and I hope it can be useful in your future research. Thank you.
Cool. This was the last talk of the session. So before we move to the lunch break, we can take 1 to 2 questions because we are behind time. So if we have 1 to 2 questions from the public, do you have any? Catalina, do you have any questions online?
No. Maybe I have a question actually.
Okay.
So I was wondering, or maybe we see Ashish has a question. So perhaps Ashish, you can go ahead, and then if I have time, I will ask my question later. Go ahead.
Okay, yeah, sure. Thank you so much. Thank you all for the talk. I have a question for Reshma. So you mentioned in the paper that the delimiter was the period, right? So how the abbreviations were tackled in the pipeline, and where the abbreviations were tackled in the pipeline?
Yeah, we have actually, it's abbreviations were tackled, basically citations, like, a model basically contributed to the citations part, like it was like able to identify more citations. Like I have shown example part, like how the error analysis with baseline models, the examples of some examples were taken. Yeah. It was able to identify the abbreviations as well as the citations also, like the CNN model.
Okay, yeah, thank you.
Yeah, Ilias, do we still have time, or maybe we can go directly to the break?
I don't think we have any more questions. So we could go ahead to the break. We have
Good afternoon or evening or morning to everyone who's joined already. I'm just going to very briefly make you a co-host if you have to present. So we have from the first paper, Reto, I think it should come back. Then we have Sezen. I hope I am pronouncing your name correctly.
Yes, it was perfect. Thank you.
Yes, great. So you are now co-host. Then we have Prathamesh. You will be presenting the next paper.
Yeah, that's correct. Hi.
Great. Hello, very nice to see you. I just made you co-host as well. And Rizvan, you will also be presenting the last paper of this particular session.
Yes, yes.
Yes, hi. And you are co-host as well. If you want to go ahead and test your slides, you are more than welcome to do so. Otherwise, we can also just load them when you come up in the lineup. So we will wait for a few more minutes and then we are supposed to start, I believe, in around 10 minutes or so. We're waiting for folks to come back from lunch. So we might have to physically kind of take them back into the room. So Leslie, Leslie, you're muted. Wait, yeah. Leslie? We cannot hear you because you're muted. Yeah, now it should work.
Okay, here we go. Yeah, I think I can go to the poster session. Just remind people it's probably the best thing to do. I will be right back.
Yes, and maybe kind of like try to kind of have them walk towards the room in around 5 minutes.
I'll do my best to drag them back.
Great, like herd them. Yes, thank you very much. Thanks, Leslie. So wonderful.
All the talks in this session are remote or some in person?
Yeah, so we had so many factors in making the schedule because we also wanted to make sure that nobody has to wake up at 3 a.m. in the middle of the night to present. So yeah, we had some talks that were physical more earlier in the program, and now we have talks that are indeed remote. Yeah, and then we even have in the next session we will have some videos that we will be playing.
Thank you.
Looking forward to all of your presentations. And Piera, just to understand, you will also be presenting, right? So I'll make you as well. I will make you co-host.
Yes, thank you.
Yes, of course. Now you should be able to have screen sharing permissions.
Thank you. Thank you very much.
Hi, Catalina. Quick question here. It's Ivan here. I'm presenting after the break, so can you maybe also give me the rights to? I mean, I do see the share screen button here, but maybe.
Yeah, I will. Yes, I will make you as well. So I was thinking of doing that out in the Q&A.
Oh, okay. Sorry about it. Yeah, sure.
But it's fine. It's fine. We can also just do it now. I think that's also easier. So very nice to have you with us.
Thanks. I'm on 1450.
Yeah, I saw that. Yes. And Marike, you are also here to present. So you will also get co-host. Yes. And Ivan, 1 second. Yeah, you should also have a.
Okay, I did my best. I was largely ignored, but I would say just go ahead at 2 o'clock.
Yeah, no. So in law conferences, what we normally do is we kind of like physically move people. It's like, hello, now let's move, and then you just stay there until they move. Like this is the
just everybody ignored me. I don't know. Maybe it's just me.
No, it's okay. So what? Yeah, maybe in.
Okay, no, some people are coming. We got 4 or 5 people. Right now, there's only 3 people in the room.
Okay, so maybe we can wait a little bit longer.
So, well, you know what? If we run late, we run late. That's what it is.
Yeah, I think we have also we can take a little bit more from the coffee break if that's the case.
Yeah, that's true.
So I've joined I'm a legal scholar, and I have joined NLLP during the pandemic. So I've actually never been to EMNLP live. So it's on my bucket list to do. But I'm very curious how such a humongous conference looks like.
It's a big conference. These conferences get bigger every year. I don't know. I'm not as fond of them as I was 10 years ago.
Okay, I'm just going to stop the screen share.
I think they were more fun when they were a little bit small.
Well, that's so you should really start joining some legal conferences because they're always small. You know, it's like if you have 30 people in a room, it's like, whoa, what is this stadium? Really? Yeah.
You know, I'd love to do is get some of our product folks at Bloomberg Law more involved with this conference, because I try to ask them every year, you know, you guys can come up with some ideas for invited speakers. I never hear anything from them. I'll try harder this year.
Great. So let me see. So Daniel Brown. Yes, Daniel, I'm going to make you co-host as well. So I'm making everybody in the session also after the Q&A for the first theme, and then also and Dimitris. Do we have Dimitris here? Or is Ilias presenting this? Reto, now you also have a co-host.
Paper 15 is first, right?
Yes. And Reto just joined, and he's now also a co-host, so now it should work.
It looks like the first 4 are actually virtual. You're going to play them. Unless
No. The speakers are here. Yes. So.
Oh, I see. Never mind. We have the links, but it doesn't say anything better.
Wonderful. Yeah, so let's just wait for a few more minutes and then we can start.
Yeah, it's the one starting at 2:25 are play.
Sorry? The play video, that's for after the first Q&A. Yeah. I saw that, yeah.
So looks like there's only 2, but they're later after the.
Yeah, exactly. Great. Leslie, could you please ask Ilias if he's going to present the number 26 or if Dimitris will present, because I'm trying to see if Dimitris joined, but I don't think he did yet.
Ask who, what?
Ilias, he has a paper, and Dimitris, I think, should be presenting, but I don't see him yet.
I don't know where Ilias is. He wasn't at the poster session, and I don't know where Nikos is.
Okay, great.
Neither of them are at the poster session.
So just bear with us, folks. Always after lunch, it's basically an entire kerfuffle to gather the band back together. So yeah, just we will wait for 2 more minutes and then we will begin.
No problem.
Okay, I think that's fine. I mean, I can maybe try to reach Ilias on the WhatsApp.
Yeah, perfect.
Can you hear me all right?
Yeah, it's working very well.
Perfect. Thank you very much.
Okay, I suggest that we begin. So we will have also perhaps more colleagues joining after they are coming back from the poster session. But I suggest that we start with the next session because we have quite a lot of talks ahead of ourselves. And this is going to be a fantastic session because we have some really interesting presentations, as we also had in the other ones. My name is Catalina Guanta. I'm an associate professor at Utrecht University. I'm the legal scholar in NLLP. And it's really an honor for me to be here and to learn from you about how we can have different perspectives on law by using NLP. So I would like to already go to the first presentation that we have in this session. Perhaps as a quick reminder, we are going to do, we're going to bundle presentations and then have a joint Q&A session after 4 presentations in the first round. And then I believe we have 6 in the second round. And with no further ado, we have the first paper on what it means to pay for your fair share, a very interesting study on tax justice. Reto, you have the floor.
Thank you very much. Thanks for the organizers for organizing this exciting workshop and for the honor of presenting our paper here. I've never had a presentation of 5 minutes, so I did my best to cram in as much as I could. If you find interesting what you hear, or if you don't understand everything that you hear, please feel free to come to me to ask questions or to read the paper. What have we done in the paper? So this is kind of a legal expert-induced research. A legal professor came to us, to the NLP department, with an observation. So there were all these normative positions of participants in legal research literature, and he thought they are invisible. Nobody talks about that. And he wanted to use NLP to make this more visible. And that's how our research started. So These normative positions co-determine the outcome of important societal processes such as trials or legal expert opinions, and of course also lawmaking. They are essentially contested. That's a term of art. That just means it's unlikely that there will be a unanimous agreement on these topics anytime soon. We have not seen a systematic study of the potential of transformers in this area. We do such a study in close cooperation with legal experts. We contribute 2 items to the community. We kind of report on the potential of transformers in this difficult task and domain, and we provide a high quality expert verified data set for this. So what domain are we talking about? Here are some samples. They are all taken from research literature in tax law. So you could take a deontological position and say something like in the example, where we emphasize equal treatment of people in similar or equal circumstances. You could take a libertarian position. This is Nozick, kind of a famous legal scholar, not only legal scholar, who thinks that taxation is kind of per se morally questionable because it's on a par with forced slavery, in other words. You could take a procedural position and emphasize that what is just in taxation matters depends very strongly on the processes that have been used to obtain these laws. You could take a Rawlsian position where you would want to use taxation to iron out unjustified inequalities. You could be a utilitarian and emphasize kind of the net outcome of tax policy, kind of what benefit does it bring for the overall good of the entire population. And you have to distinguish all these categories from things like an income tax can be used to redistribute taxable income. This does not represent a normative position. It's just an observation, right? So difficult task. How did we approach this task? We let the expert develop these 5 normative categories. So that's kind of a pure expert input. We then also let her compile a first data set of sentences that belong to these 5 categories. And then we started with a first experiment. We conducted a grid search using different transformer models, using different support vector machine hyperparameters. The resulting configuration was then used in another more expensive experiment with an expert in the loop bootstrapping approach to kind of iteratively obtain an ever-increasing data set. We then let 2 external experts that were not connected with the experiment review the entire resulting data set to make sure that there is no kind of in-group bias in the annotations, basically. We wanted to have two people that are not connected with our lab, with our experiment at all. So here you can see how our data set has grown. So in loop 0, there were 175 samples for each of the 5 categories, about 1,700 non-normative samples that we chose such that they are maximally similar to the normative ones. And here you can see how the data set has grown with each bootstrapping loop. If you're interested what single gate and dual gate means, I'm happy to talk about that in Q&A or have a look at our paper. It's just kind of 2 different methodological approaches that we've taken. Yes, and here just one very packed slide with intra-annotator agreement, one final sentence. It shows that the task is more difficult than simple word sense disambiguation. Why is that? The topic is essentially contested. It's sometimes just also not completely clear whether a sentence is Rawlsian or deontological, for instance. There can be opinionated disagreement on that due to the topic itself. So takeaways, we have developed a method and a data set in a new NLLP domain, normative positions regarding tax justice in tax law. The domain is difficult, the topic is essentially contested, but transformers do surprisingly well. Thank you very much, and I'm happy to take any questions.
Thank you very much for this fascinating presentation. I really like this concept of contested knowledge in the legal domain. So perhaps we can come back to it in the questions. We will move now to the next presentation, and then we will take the questions after 4 presentations. So Cezanne, I think you should already have the possibility to share your screen. And when you're ready, just go ahead with the presentation. And Susan and Piera, I should say, they will be presenting combining WordNet and word embeddings and data augmentation for legal text.
So now it is working, right? You could see my screen?
Yes.
That's great. Thank you for the introduction and thank you for this exciting event. So my name is ClassActionPrediction and today we will be presenting you along with Dr. Stanton our paper combining WordNet and word embeddings and data augmentation for legal texts. Yes. Today, many of the state-of-the-art NLP methods are based on deep learning architectures having millions of parameters, which require the use of vast amount of data for their training process. And although there has been many advancements, still today, many of the high-level tasks, such as domain-specific ones, are handled in a supervised manner. So creating corpora could be a solution to address these applications. However, it is a particularly challenging and expensive process. In order to overcome these challenges, we provide a set of augmentation methods that could be used to create new synthetic samples to 3D word replacements. In these methods, a paraphrasing-based approach is adopted to preserve the semantic closeness of the new samples to the original ones, and we have also utilized the subsymbolic similarities, symbolic relationships, and a hybrid approach. Our main approach is a combination of the WordNet and the word embedding. First, a candidate pool is formed with the lemmas returned from the WordNet, and then a part-of-speech tag compatibility check is applied on the corresponding synsets and the wording process. This process will result in a prioritized list, and then the replacement is chosen as the most similar word among the candidates in this list using the glow vector space. We have also compared our method's performance with 4 other methods. In the first one, the replacement is chosen as the most similar one in the glow vector space, satisfying a part-of-speech tag compatibility using the cosine similarity. In the third one and in the second one, again the WordNet is used and a prioritized list is formed, but in the second one, the replacement is then chosen randomly among the candidates. In the third one, an additional part-of-speech tag compatibility check is applied, this time on the lemma level, and then the replacement is chosen as the first method, chosen as the first word in this list. And lastly, in the fourth method, we have used the masked AraLegal-BERT for the prediction of the replacement in place of the masked wording process. Now I will leave the stage to Dr. Stanton to provide other details.
Thank you, Suzanne. With regard to the composition of dataset, we conducted our experiments on segments of text in English language extracted from a appeal decision of the Court of Justice of the European Union on the field of fiscal state aid. In particular, we have chosen sentences that are representative of a principle of law, which can be legal maxims or razione decidendi. Such sentences are used to highlight the decisive principle of law contained in each judgment that will be useful to assure the uniform interpretation of the law with respect to the courts of first or second instance in national jurisdiction. With regards to the evaluation of the datasets, we involved 2 domain experts, which make the evaluation of each sentences, assigning a value between +1 and -1. In particular, we proceeded as follows. For each sentence, we assigned a score to each replaced word that we sum to the single value to obtain an overall score for the sentences at stake. We've chosen to use a 3-value scale to identify replacements that may be completely correct with the value of +1 for expression or word having the same meaning in the considered legal context. Imprecise word substitution, which could be imprecise for our specific domain with a value of 0, which means words or expression having either a similar or nearly the same meaning, but pertaining to an informal or non-legal linguistic register. Lastly, completely incorrect substitution, but with a value of +1, which means words or expression having a different meaning with regard to either the common sense or the legal context. That's all, and for the results and further development, I leave the stage again to Susan Perchin. We cannot hear you.
Sorry, now just as we can see from this table, we can observe that our method seems to be the most robust one, and its performance is always close to the best method per maxim. We have also observed that the most comparable method to ours is the use of MassLegal-BERT, which has more tendency to preserve the grammatic correctness of the sentences when compared to our method. And in conclusion, we have applied our segmentation method, and we have obtained the embedding-based evaluation along with the human-based evaluation that is performed by a team of experts. And we have also observed that the neural augmentation using legal-BERT also provide us with the good results. So now our next steps would be to apply our method in a task-based evaluation setting, where we will be used our method to for the extraction of the legal maxims from legal documents, and to apply our technique to some other high-level tasks such as argument mining and unfair clause detection that may suffer from unbalanced data. So thank you for listening, and we are open to any questions.
Thank you very much for your presentation. And now we move to the next presentation, and that is going to be the one on named entity recognition in Indian court judgments. And Prathamesh, you have the floor.
Thank you, organizers, for giving me the opportunity to talk in the forum. My name is Prathamesh Kalamkar, and this paper we are going to talk about named entity recognition in Indian court judgments. This work is part of Open Nyaya mission, which consists of 3 words. Like, first is open source, the second one is Nyaya, which stands for justice in Hindi, and EI stands for artificial intelligence. We have clubbed these 3 things together and named this mission. These are the other authors with me in this paper. So this mission is really aimed at developing open source software and data sets which will catalyze access to justice, and we are focusing mainly in India to begin with. In this paper, our main contributions are we have created a corpus of 14,444 judgment sentences, and they are annotated with these 14 custom defined legal named entities. And we have divided this into train, dev, and test. So this data is made open. We have also based an AI model, which is essentially a transformer-based named entity recognition model. We have experimented with different architectures and found out the best one. After this, we have also done some post-processing, which essentially is rule-driven, because all these extractions are done at sentence level. So it's important to capture the global context of the entire judgment. So we have done some rule-based post-processing activities. And as a byproduct of this work, we have also released a representative sample of court judgments, which could be used in further studies. So this is an example like how an Indian court judgment would look like. We have broken it into 2 sections. One first is what is called as preamble, as you can see here, and the second one is the main judgment body. And we extract different entities from each of these sections. So from preamble, you would extract court, petitioner, respondent, judge name, because that's where typically they are written. And from the main judgment, you would extract again like some entities appear in both, like court, then the name of people, entities, dates. So this is the list that we have. So we went about how did we go about the data annotation process was basically how do you select the raw sentences. So from the representative sample that we have created, we selected the information rich sentences which are more likely to have entities, because if you take a random sample of all the sentences, most of the sentences will not have any entities. So we did some pre-annotation. We used a pre-trained models to identify which sentences are likely to contain these entities, and they were pre-annotated and then given to humans for inspection. So the humans came in and then they inspected and corrected all the entities, and then finally this data was created. So we had like 8 annotators, out of which 4 were data scientists and 4 were legal experts at OpenAI. So finally, this data set was created, and we experimented with multiple transformer-based architectures, and two themes. One is the transformer plus a transition-based parser, and without just doing a fine-tuning on the entire transformer architecture. So our result shows that the Roberta base with the transition-based parsers were giving us a very good F1 score of 91.1. And if you look at the entities, you'll find that certain entities which are very long, like precedent and provisions, they score slightly dips sometimes, but yeah, I mean, like if you look at the average length, the highest one is that of precedent. So you have slightly poorer F1 because you can miss out on few characters here and there, but overall the model we feel that is good enough for the practical applications. On the post-processing, we have done some activities of doing the entity reconciliation, because there can be typos, they are manually written. So how do you handle those and make sure that this is the same entity? Then doing a co-reference resolution of the precedents, because same precedent can be written in multiple ways in the same judgment. So how do you identify they are the same? Doing co-reference resolution of statutes and assigning a statute to every provision, because like a provision is like on its own doesn't make any sense unless a statute is assigned. So these are all rule-based activities, not these are not ML driven. And this part is already available as a part of the Python library OpenAI, and you can try this and install this library on your own machine. You can also go to the OpenAI website and you'll find a link where you can actually go ahead and try this on your own. This is a web app. So you can just copy paste your entire judgment into this, or you can just provide a URL for this. And then it shows you multiple models that have been developed by OpenAI. So this one like is showing you the NER, but it also shows you the rhetorical rules one that Ashutosh was earlier talking about, and it also gives an extractive summary of this. So this is these are our mainly the contributions, and finally, like we look forward to collaborate with you. If you have any questions, feel free to ask them in the Q&A. Thank you.
Thank you very much for also this demonstration of your wonderful resources. That's great. So now we will move to the last presentation of this batch, and then we will do a joint Q&A, as I mentioned. And I will give the floor to Răzvan Alexandru, and he will speak about the legal named entity recognition with domain adaptation. And I think that this is a first, because I think that we also have an author who is a judge in this paper. So that's pretty cool. Răzvan, you have the floor.
Okay, I think you can see my screen, right?
Yes.
Okay, thank you. So hello, I'm Răzvan Alexandru Smadu, and I will present our work on legal name entity recognition using multitask domain adaptation. So name entity recognition, or NER for sure, aims to determine entities in a given text, such as locations, organizations, and time references. On the other hand, legal names and aims to identify additional key elements related to legal entities, such as names and numbers for laws and regulations and court names. And this task is important in processing legal documents. And in this work, we aim to investigate deep learning approaches to the Romanian and German languages. The main problem in the legal domain is the scarce availability of resources, especially for name entity recognition. And for the Romanian language, very few work address these problems, although in the last years we saw more papers emerging, such as the Romanian BERT. And in this work, we want to take advantage of these recent developments and to adapt the knowledge from general to legal domains, and to apply techniques that have proven effective in improving performance, such as multitask learning and domain adaptation. So we cast the problem to a tag level classification task, and we aim to identify labels from the bioschema and determine the class for each entity. And our proposed architecture utilizes contextualized word embeddings, which are generated using pre-trained BERT on a specific language. Then we employ multitask learning by jointly training two classification heads, one for general and one for legal. And each head ends with a conditional random field that aims to predict the labels for each token. And we include the tag level domain discriminator linked by a gradient reversal layer to the feature extractor. This is to perform domain adaptation. And in the end, to allow higher learning rates for the label predictors, we incorporate a gradient scalar layer that reduces the gradients during backpropagation by a positive factor. And the intuition is to allow slight changes to the parameters of the pre-trained BERT layer. To evaluate our approach, we employ the low-resource Albanian language, represented by RONEC V2 and Livermore, and a much larger dataset, which is the German datasets, for which we use the German FAL 2014 and German legal entity recognition datasets. So for experiments, we train baseline models that do not include domain adaptation or multitask learning, and we obtain over 80% in the F1 strict score across all datasets. Then we train the model, the complete model, so enabling both domain adaptation and multitask learning. And the optimization process involves minimizing the sum of the prediction loss, LY, and the domain adaptation loss, LDA, scaled by lambda. And we call this ADL. And we saw improved F1 scores by under 1% on the legal NERO, and generally lower performances than baselines on the other data sets. So we changed lambda sign from plus to minus, and this is reference SDAL. And the performance is improved by 3 to 4% on almost all data sets when compared with ADL. So we visualized the feature space using t-SNE plots for ADL, SDAL, and compare with the pre-trained BERT. Although ADL generates clustered and separable representations, it seems that SDAL achieves better results. And finally, we analyzed the effects of using the same data sets for both source and the target. And in this setting, we observed that this approach obtained, on average, better F1 scores than the baseline models. But when compared with SDAL, we observed lower F1 strict scores in most cases. However, this method improves the Romanian legal domain by 4%. So to conclude, we proposed an architecture that combines multiple components and evaluated them under various conditions. We observed that ADL and SDL influence the latent representation and improve the model's performance. And for future work, we aim to investigate the cross-lingual setting. So more details and analysis are in our paper. Thank you, and I'm glad to take any questions at the end of the session.
Thank you so much also for your presentation. Now we're going to go into the actual Q&A session. So I'm just going to add you here all together in the center, and we can start asking questions. So let's start with the crowd that we have online. Are there any questions that you might have for our speakers? Let's see. I think Pauline has a question. Pauline, do you want to perhaps unmute yourself and ask the question?
Yes, sure. Hi, thanks very much for your presentation. It was really interesting. I was just interested to know how you selected your experts. This is directed at Reto. And I was interested to know how you selected your experts for annotation, because as I say in the chat, it seems to me that the questions that you're looking at are at least as much philosophical as legal, especially when you're considering, for example, whether it's Rawlsian. So this seems like something where it's quite difficult for you to find an appropriate expert. And I wonder if you could say something about that. Thanks very much for the talk. It was great.
Perhaps, Pauline, before you go, Reto, perhaps you can also introduce yourself so that our speakers can also understand your background and then also shape their answer accordingly.
Certainly. So I'm Pauline McBride. I'm a postdoctoral researcher with the Cubicle project, which is at VUB in Brussels. The Cubicle is an acronym for Counting as a Human Being in the Era of Computational Law. So research looks at computational law generally. My background is as a lawyer, but I am interested in natural legal language processing. And I really was very interested in this idea of doing something a little bit different and looking at these normative threads that might appear in the cases. So I was fascinated by that. Thank you, Reto.
Should I?
Yeah, go ahead, Reto. Yeah.
Thank you very much. Of course, honored for your interest. As a matter of fact, the kind of the initiator of the whole project is a tax lawyer who is very much interested in justice theories. So he has spent a lot of time in philosophical departments, as a matter of fact, and he was kind of my main conversation partner there. And our annotators are from his chair, which are mostly lawyers, but you don't get to be an assistant to his chair if you don't have any philosophical interest. And the two external annotators actually were political philosophers. So I think you got us at an interesting point, and I think you are absolutely right that some basic expertise in philosophy or an interest in philosophy is very good for this kind of annotation work that had to be done. It wasn't easy to find the philosophers, as a matter of fact.
Pauline, any follow-ups on that?
Just to say that also is interesting and rather confirms my suspicions that I think you probably need a very perhaps an unusual person to carry out the annotations, and that might be, it's very interesting. It might be an issue for scalability of this kind of research, but I dare say that as you explore it more deeply, then, you know, perhaps this group of people who would be interested in that and who combine law and philosophy to some extent will emerge. You'll see a class of people that might be prepared to do that kind of annotation. So it'd be interesting to see how it develops.
Thanks. Take the liberty to keep you posted.
That would be lovely. Thank you.
Wonderful. Thank you so much, Pauline, for your contribution. Then I would like to invite Almila to ask her question. You already asked it in the chat, but perhaps you can also join us here and also ask the question by yourself.
Hello. Thank you for the organization and the great talks again. I have a bit more technical question coming from the computational side. This is Almila Akta. I'm an assistant professor at Utrecht University Computational Sciences Department. So we are working on dark pattern detection and trying to do it automatically. And for this workshop, we have a paper on how and if we can use models to detect legal violations on cookie banners. So cookie banners, you're familiar with them. You have to just go through them if you're living in Europe every time you access a website. And they are set up in a way to confuse the users. So the language is quite different. My question was, what would you expect in such a different type of data sets to use your data augmentation model?
Well, actually, we were working on extraction of the maxims. I'm very familiar with the field, that sort of data. But for example, I think the vocabulary may be different from the ones that we have been seen in the maxims. So we were just trying to find some methods that could be independent of these relationships. But what I would suggest, for example, we wouldn't have too much data to create our own word embeddings or sentence embeddings or stuff. So one suggestion that I could be doing, if there's enough data to form this type of embeddings, I would just try that and then apply this sort of embeddings to our data augmentation methods. But I have to think about it in a more broad sense, I guess.
Thank you. We also are in the problem of the challenge of working with really small data sets, and the expert annotation takes a long time. So hence the data augmentation, if works, would be really useful. I'll get in touch with you then later. Thanks.
Thank you so much, Almila, for your question. I think Marijn also has a question. So Marijn, please go right ahead and ask your question.
Yes, hi. I have a question for Razvan Alexandru about the Romanian named entity recognition. Because from what I saw in your examples, the legal NERs have a quite defined structure and meaning, right? So maybe they are. It's useful to do some pattern recognition on this. What are your thoughts on that instead of trying to make a model do this?
Right. So I think the baselines which were proposed for those data sets actually do some pattern recognition and much more simpler approaches than ours. And they generally perform reasonably well because, as you observe, this is quite regular structure for these legal documents. But there are some challenges which cannot be tackled using these pattern recognition approaches. For instance, you can have the context like pronouns, such as it. It can refer to anything, but it depends on the context in which it is used. So, and here the classical approaches cannot determine these pronouns, although they can be labeled because they refer to a legal entity. And here, for instance, BERT-based approaches, which takes into account also the context, performs better than the classical approaches.
Okay, thanks.
Thank you as well.
Thank you very much. Perhaps until we get more questions from the floor, let me also ask a question because I actually had some questions for Prathamesh. I was wondering whether in your data set of judgments, there are judgments that also have different structures, because I think that for me as a legal scholar, that's also something that immediately makes me think of chaos, because the way in which a German judgment looks like, and perhaps Alexander has also seen this, Răzvan has seen this also in his own work, comparing German judgments with Romanian judgments. You know, there will be some flowy narrative judgments, or there will be judgments that also have a specific structure where it's about facts, and you can really use that for the more automated detection of various entities. But at the same time, different fields of law, for instance, administrative law or criminal law or civil law, family law, there will be sometimes different structures for the documents. So I was wondering whether in your data set you have seen this type of diversity, and if so, how you dealt with it.
Yeah, so definitely this diversity is definitely present. And India being so large country geographically, each court kind of has its whole style of writing things. Okay, so what we have tried to do is like in the main judgment section, we literally break the sentences, like break the things into sentences and patch each sentence as an input to the model, so that this variations are reduced. But especially for the preamble, like sometimes they write side by side, sometimes they write one below the other. So a lot of such variations are present. And what we have tried to do is like we have categorically controlled for the various codes and various types of domains to kind of cover most of the things, but it's impossible to cover like all possible varieties. But what we have done is like try to cover most of the variety in the data set, so that the model learns to capture a lot of variety it's present, and capture most of the useful part of the data. Yeah.
Thank you very much. I don't know if Piera has, because I saw Piera was nodding in agreement. So if you have any kind of thoughts on this, please, by all means, you can unmute yourself. Yeah.
Sorry. Yeah, since for another project I was working, I'm a lawyer, a tax lawyer for the extent, and for another project we are working on tagging judgment under a structural point of view, distinguishing different parts in order to make the machine able to recognize them. And particularly we distinguished between the formal part, name of the parties, title, identification of the court, and structural, but mainly contenutistic ones. So the motivation, the decision, the anticipation of the motivation. And we worked on different legal systems, because we worked on Italian, Bulgarian, and German judgment, and trying to use the same marker, the same guidelines, and so using the same tag. And it appeared to be really, really difficult, since the organization of the judgment, the structure of the judgment, it could be really different, and it reflects different approaches to the building of the activity of giving justice. Also considering that we worked also on CJEU decision, the same one of the appeal decision here in the used for the dataset we are going to present today. And we discover how there is a significant difference in the bindingness of the formal aspect of judgment, which is very high in the CJEU decision, also due to the existence of a schema used for building up it formally. And at the opposite, for example, the Italian decision, which was first and second grade, so merit decision, are very informal, and it was very difficult to have a systematic replacement and tag them. So I was really interested in your consideration, because I found it very coherent with my experience.
Interesting. Thank you so much for sharing that with us. I don't know if Razvan has anything to add to that, because you probably also have seen some differences in the type of documents that you worked with.
Yeah, and actually we try some preliminary experiments for the cross-lingual settings, so to train both on German and Romanian languages for the same legal data sets, let's say. And we saw that the performance, at least using the current architecture, drops quite considerably. So this is because of the difference in structure, which cannot be learned by the model.
Thank you so much for that. Are there any more questions in the room, in the online room, or in the physical room? I see no questions in the chat or no hands up. Leslie, Ilias, do we have any questions on the floor? Leslie, you're muted. But I saw this wonderful microphone, and I was hoping that you would start to sing, but perhaps we can do that in the break.
Katerina, can you hear us?
Yes, now we can hear you.
Okay, we're muted, sorry. Okay, yeah, I can do a question to Prathames, if I don't misspell the name, sorry for that. If I recall correctly, in the NER datasets for EDR court judgments, there were a lot of entities that were either under the same umbrella, like, for example, there were different entities for persons, for example, like plaintiff or defendant or judge or other person or stuff like that. And there are other kind of entities that were overlapping, for example, the court name, which has a place into the court name, etc.
Yeah.
So I would like to know your thoughts about overlapping kind of entities that may exist in the dataset, and what kind of hierarchical approach someone could get when we have, for example, different sort of person and data types, stuff like that.
Right. So for this data set, we really considered flat entities and not hierarchical entities. Like, so if there is like High Court of Mumbai, then we consider the entire name as a single entity and don't break Mumbai into a separate geopolitical entity. The reason for that is like, just to make it more practical. There are a lot of data sets that have this hierarchical, but I think keeping in mind two things, like on the practical use of this, and the second one is like the simplicity of doing the annotations. We have made this decision and ask annotators that, okay, mark the most logical entity that you see on a given text and mark it. So yeah, that's what we have followed for this data set.
Cool, thanks. Do you have time for more questions, or?
Perhaps we can take one more question because we are running a little bit out of time, but we have time for one more question, I would say.
Okay. Anyone who's willing to take a question, I can make one. Somebody online wants to... Is anyone online?
I think that there's one. Oh yeah, so Piera has a question for Reto. So there we go. Let's go with the tax cross-pollination. Piera, go right ahead. Microphone.
Let the room to ask. I could ask it to Reto in a separate moment.
I would suggest that you go ahead with the question.
Yeah, yeah, go ahead. There's no question there.
Oh, okay. Sorry, I didn't understand. I was wondering to Reto if they have tried for the future to move to actual legal text. So I try to explain my question. Considering that in a certain legal system, a certain view is accepted, philosophical, but also practical, because ability to pay is part of the constitutional experience of many more countries in the EU area, but I could say worldwide, and it's considered a sort of general principle, common principle. Each country has a sort of chooses one of the philosophical approaches, and decline it in the actual legislation. Have you ever considered to search with NLLP for correspondences between legal text and philosophical theoretical approach? Or in the future, maybe.
Thank you very much. I'll try to be brief. So actually, that is how all started. Our tax law professor started out with Swiss High Court decisions, and I mean, he thought that they were sometimes conflicting, right? In one ruling, they were being very deontological, and in another one, they seem to be pulling more on the Rawlsian, from Rawlsian sources. And that's actually a development step. So kind of we focused on research literature because we thought, erroneously or correctly, that it's easier to kind of get a first grasp on the concepts, on the use, on interesting contexts. But I mean, I completely agree that it's also on our schedule to kind of start looking more in more detail on actual court rulings. And that different countries set different emphasis is certainly correct. But you also find that within one single country, right? I mean, nobody, I think, needs to remind people of the disagreements in the federal court in the US. And also within a single person, you find that they rule more in one philosophical background, and then for another ruling they switch. So thanks for the suggestion. I think we think that would be an interesting question to address.
Thank you very much to all of you for your lovely presentations and also for the wonderful discussion. Now we're going to move to the next set of videos, and we actually have a video that we need to play because the next participants are not available either online or in the room. So we are just going to listen to the presentation that they have prepared. So allow me to share that with you. Can you, yeah.
However,
so
AI have already achieved great
is this audible?
Yes.
Yes. Performance. However, in the legal domain, performance is not the only requirement. We expect models should conform to legal theories. In our paper, we take the chart prediction task as an example to explore whether current models have learned legal theory. Given a fact description, the chart prediction task aims to predict appropriate charge. In China, nearly all the judges use four elements theory to make decision. I will simplify four elements theory as FET later. The FET is a crime constitution theory, which defines that a case must satisfy four criminal elements simultaneously to constitute a crime. The four elements are subject element, which is shown in purple, mental state element, which is shown in yellow, conduct element, shown in blue, and the object element, shown in red. The FET first extract the descriptions related to these elements and then check whether all the four elements are satisfied. If any one element is not met, the defendant should be innocent. Based on FET, we think that if a model learns legal theory, it should satisfy three principles, which reflect FET in three dimensions. In the criminal elements extraction stage, models should be selective, able to distinguish different criminal elements for one charge, and sensitive can distinguish the same criminal element for similar charges. In the completeness checking stage, models should satisfy presumption of innocence, which always assume innocent unless all the elements are met. To explore whether current charge prediction models satisfy the principles, we first annotate a sentence-level criminal elements dataset. We map each sentence to its corresponding criminal elements. Totally, we label 685 factor descriptions, including more than 9,000 sentences. We use a probing experiment to check selective principle. We train a linear classifier to infer whether a sentence is related to criminal elements. The assumption here is that if a charge prediction model can identify criminal elements, the knowledge of such a scale should be reflected in its internal representations. In the probing task, we find chat prediction models significantly outperform baselines, which means they could identify criminal elements. We also noticed that the pre-trained language models, which are not fine-tuned in this task, also perform well. This implies that the capabilities of identifying criminal elements might depend on semantic information. Synonym principle requires that model to distinguish the same element from similar charges. We modify factor descriptions of one charge and evaluate whether model could notify the modification and change the prediction. We use fraud procedure and robbery as an example. If the defendant seizes with a weapon, then he should be charged with robbery. We add descriptions about the weapons, include some common ones like a knife and uncommon ones like a baton. We expect model could predict robbery for both circumstances. We report the ratio of predicting the original charges after modification. Triangle means uncommon text pattern. Star means common ones. We find that models successfully distinguish similar charges using common text patterns, while they fail when it comes to uncommon ones. In other words, models are not sensitive enough now. To evaluate the presumption of innocence, we remove sentences related to certain element and expect models change their predictions to innocent because the remaining facts don't match all the four elements. Unfortunately, we find that all models stick to their predictions with incomplete fact most of the time. When a criminal element is removed, models improve the prediction probability of innocent. However, the improvement is insufficient to satisfy the presumption of innocence. As a conclusion, we propose 3 principles to evaluate whether charge prediction models conform to legal theories and find current models do not learn legal theories well. We supplement the charge prediction dataset kill with innocent cases and provide sentence-level criminal elements annotation for future study. Thanks for your listening.
Great. So since we do not have the authors with us, then we would like to encourage you to read the papers in the collection of papers, and we are going to proceed with the next set of presentations. So I think it is now Dimitris's turn. Dimitris, you should already be co-host, so you should be able to share your screen. And we are going to listen to the paper Processing Long Legal Documents with Pre-trained Transformers.
Yes, just give me a second to share my screen a little bit.
Yeah.
Just verify they can hear me properly.
We can hear you properly and just waiting for the slides to load.
Okay. So good evening from Athens, Greece. My name is Dimitris, and today I'm going to perform a brief presentation to our paper, Processing Long Legal Documents with Pre-trained Transformers, Multi-LexSum and Informer. And of course, this is a work released in cooperation with Peter Tsochi, Untitled and Ilias Chalkidis. And just give me a second because there's no change here. Okay. Now, in terms of our, in this study, we mainly identify the issue of processing large legal documents with pre-trained transformers, as stated from the title of this paper. And the reason we choose pre-trained transformers is because they are currently one of the state-of-the-art methods used in NLP. But as we all know, the transformer-based models have some limitations in terms of the size of the sequence they can process at a time. For example, BERT-based models can process text up to 512 tokens, whereas the long-form-based models can process text up to 4,096 tokens. But as we all know, legal texts are often considered to be really large datasets, documents, excuse me. So we can easily conclude that the bag-of-words techniques sometimes combined with the sparse attention variants, they cannot easily cope with the large legal documents. And for our experimental needs, we used 6 datasets provided by the LexLu benchmark. But from that slide, we really like to focus on the text length of each dataset. So as we see here, most of those datasets contain a significant large number of words. And we can also visualize that by seeing an example from the ECTHR dataset. So as we see here, this training instance consists of multiple sections or paragraphs, each of them containing more than 500 words on average. So this is a really large text to consider. In terms of our prior work conducted by others, we have, first of all, we have a hierarchical transformers part, which is actually, this concept has to do more with separately using multiple BERT models to separately code each paragraph of the input. And then we have the sparse attention variants, which actually try to achieve linear complexity by combining the local attention, the local window attention with the global attention. And for example, you can check out the baseline model like Longformer, the Big BERT, or the ADSIM. Now, in terms of our contribution, I would really like to split this part of the presentation into two main sections. First of all, we have the bag of words concept, in which we actually perform the application and sorting by the TF-IDF scores of the subtokens decreasingly. And then moving on, we have the long-form extensions, which actually try to extend the size of the text the long-former-based models can process from 4,096 subtokens, as mentioned earlier, to 8,192 tokens. Now, in terms of our experimental results, generally for the bag of words models, or even generally, we have a TF-IDF-based SVM model as a baseline. And then we have two models that actually do not retain the original order of the text. First of all, we have the TF-IDF SRT legal-BERT, which is actually the legal-BERT by performing the application and sorting based on the TF-IDF scores. And then we have the TF-IDF SRT EMB legal-BERT, which is actually the same as the previous model, but we add an extra TF-IDF-based embedding bucket layer. Moving on, we have the variants that actually do retain the word order, the original word order of the text. So we have a legal-BERT, as mentioned earlier, and then we have a TF-IDF EMB legal-BERT, which is the same as legal-BERT, but adding again an extra TF-IDF-based bucket layer. Now, for the former variants, we split this part again of the models into two families. First of all, we have the long-former-based models, which are actually the models warm-started from Roberta. And then for that reason, we have the plain long-former, and then we have the long-former extended 8,192 tokens, as I described it earlier. And then we have the long-former 8,192 PAR, which is actually the same as the previous model, but we add the one global token to separately encode the end of each paragraph. And then as the same as the long-former-based models, we have the legal-former-based models, which are actually the same exactly, but they are warm-started from legal-BERT. But from that slide, I would really like to focus and see that we can actually observe that the optimal results most of the times, at most of the datasets, are obtained using the long-former variants. Finally, I would like to perform a performance efficiency trade-off by visually describing this diagram here. So we see that the long-former-based models do actually perform better in terms of one scores compared to the bag of words ones, but they tend to require heavier resources in order for them to be executed. This is actually something really expected due to the concept of the long-former-based models itself, because they see even bigger text. So at this point, we reach the end of the presentation. Thank you so much for your attention, and I would really like to hear your comments, recommendations, and thoughts by examining our paper into more detail. Thank you so much.
Thank you so much, Dimitrios. Great presentation. So we're going to take questions after all the remaining presentations in this session. So I would like to invite Ivan. I think, Ivan, you will be presenting the paper, right?
Yes, that's me. I'm here. Let me share my screen.
Yeah.
And I'll just find the right window I need to share. Which should be somewhere. Excuse me. Okay. So, which I can't find right now. It's kind of embarrassing. Sorry about this.
No worries. It's always
it's always the same story, right? So
always the same story, and also the story of let me not share the chat with my family. So.
Yeah, something like that. So let me just restart this application, and it's very, it should be now working. Let me see here. I need to see.
Yeah, perhaps until you are ready with the sharing of the presentation, I also want to mention that we also had a second video that we were supposed to play, but unfortunately the video has some technical difficulties. So we will not be playing that. That was the video for the paper Legal Tech Open Diaries, lessons learned on how to develop and deploy lightweight models in the era of humongous language models. So you are once more welcome to read the paper when we are going to have the publication of the proceedings.
And now I do have the right window, I guess. So
Great. Now we can
should,
also
yeah, usually
see
see also myself in the screen.
exactly. Yes.
That's great. That's what I wanted. So thank you very much. Sorry about the delays. I'm super happy to be here. And my name is Ivan, and it's a joint work with Yingyin about again, like we were saying in the legal transformer world, and we were talking about privacy preservation here. And just a quick motivation why we talk about privacy, what it means. So we take the standard GPT-2 model, for example, and prompt it with the queries. So for example, English was the time, and we want the German translation. So the model will output something which is the correct translation. So this is great. This is what we want. If you're a bad guy and try to input some, let's say, adversarial text, and then the model will tell you something which it shouldn't actually remember. So for example, it learned unique names of individuals, addresses, emails, and some other, some other sensitive information, even though these data were seen only once during the pre-training of the GPT-2 model, right? So this is not good. The model remembers something which we don't want it to remember. And, contemporary deep learning models typically neglect privacy here. And for example, what we typically do is model publishing. We take a data set. So here we have Alice, Bob, and Charlie. And we train it with stochastic gradient descent on some task, could be pre-training. And we have this model, which is just a bunch of parameters, sort of an architecture. But if you're a bad guy and somehow got access to leaked data of Bob and Charlie and want to find out something about Elise, you can do it. And you can train a model with SGD. You get a little bit different model. And, just playing with the model with the API and querying the model, you will find out quite a lot about Charlie. You can about Elise. You can find out whether she is in the data or not, and maybe some attributes of that. So it's it's an issue. So taking different paths. So actually, what Dimitrios was talking about, like pre-training for domain adaptation helps, and the better pre-training and the model, the better the model. So typically, we take some baseline models like BERT. So with self-supervised pre-training on some unlabeled data, we are creating something like a standard model, and then for a task-specific problem, we fine-tune it typically. So this is what we do, for example, for legal task. And obviously, we have these people, all these people in the room. If you do pre-training on legal data, and so we do this like domain adaptation without label data, you perform better on downstream tasks. So for example, here we have this beautiful legal-BERT figure. However, if you're a bad guy and have the access to the pre-trained legal API or legal model, and you play around long enough, then you can really find out what was in the pre-training legal data. And this could be an issue, for example, if you do some domain adaptation on your, let's say, like sensitive data from your company, for instance. So we want to, protect this. So what can we do? Again, here's a scenario with Alice, Bob, and Charlie. We train it standardly with SGD. And then the idea is that if you have two data sets which differ with one person, we add some just enough random noise during training of the gradients, such that the information leaked about each individual person is bounded from above. So there is this ugly formula, but the important part is something is lower than some epsilon constant. So this is the worst case of information which is getting lost from the privacy perspective. And this has been used in NLLP, in image processing, but we were interested in whether you can use this differential privacy pre-training also for like a legal pre-training, so domain adaptation without labeled data. So what we're using here is the same setup. We take a standard BERT and then have some bunch of, quite a lots of legal documents from these three corpora, and we want to scale up this pre-training with the differential privacy. And the technical questions, which is more in the paper, is like how to scale it up, because if you use it out of box, the frameworks and techniques that are there, it won't scale. You cannot really scale it to pre-training large language models. So we had to re-implement many things in JAX, which is kind of really fast for what we want. And we gain, through this pre-training, not only we have some privacy guarantees for the pre-trained data. So these epsilon of 5 has some meaning, some details in the paper. But also we get some 2% improvement on one of these tasks, which is multi-class classification, I guess your case hold. And so this is the scalable DPSGD. And now you might be asking, 2% improvement, is it worth the effort? Well, as Dimitrios just showed, like they had also like 2% increase. So maybe it's worth the effort because you don't have any labeled data and you have privacy. And why even do this? Well, all these questions, we discuss them in the paper, so we don't have time for this. Either approach me in the QA session or just also read a paper. And thanks a lot for your attention.
Thank you so much. And I see that you're already getting a lot of compliments also in the chat about the presentation style. So wonderful. Thank you very, very much for this. So we're going to park the questions for now. We have 2 more presentations and then we're going to have a joint Q&A. So I would like to invite Marike now to present the paper that Almila was also referring to earlier, the automatic classification of legal violations in cookie banner texts. And you should be able to share your screen as well.
Yes. Okay, so can you see the screen?
Yes.
Okay, great. So thank you for this opportunity. My name is Marike van Hofsveld. I am currently in the AI master program of Utrecht University, and I will be presenting our work on the automatic classifications of legal violations in cookie banner texts. So to comply with the GDPR website, operators have to inform European-based users and ask for the consent for the processing and collecting of their personal data. However, previous research found that 89% of cookie banners violate applicable laws, and that the language used in these cookie banners is often formulated in a way that can confuse and impact users' privacy decisions. Regulators are presently overwhelmed by the novelty and the scale at which these patterns are being deployed online. So there's a need to identify textual violations and develop tools that can automatically detect these textual dark patterns in order to support the legal proceedings of enforcement authorities. So our focus is on the automatic detection of legal violation in cookie banner text based on the language. And our aim is to understand whether large pre-trained language models can be used with little or no fine-tuning for auditing purposes. So we used a dataset that was developed by Santos and colleagues in 2021, which consists of 407 English cookie banner texts annotated by 5 legal experts. And we focus on 5 annotation categories: consent, option, presence, framing, misleading language, purpose, and technical jargon. We used 4 models. First, we have BERT, which is, of course, a widely used transformer-based model. We also use BERT in combination with LUC features. LUC stands for the Linguistic Inquiry and Word Count, which is a dictionary-based text analysis tool that calculates the percentage of words from AD, linguistic, psychological, and topical categories. We also used LegalBERT. LegalBERT is the family of BERT models that have been pre-trained on diverse English legal text. And while cookie banners themselves are not legal text, we included this model to address the utility of a domain-specific BERT model in the general legal domain. We also used pre-trained BART, which is a natural language inference model. We used this as an out-of-the-box zero-shot text classifier. And we did this by reframing the classification task as a natural language inference task with the cookie banner text as the premise and the corresponding labels as the hypotheses. So our results, this table shows the performance of all the models in terms of classification accuracy as the average out of the stratified 5-fold cross-validation we performed. And what you can see is that LegalBERT has the highest score for 4 out of 5 classes, and BERT is the best, has the best score in the remaining class. We also looked at the wrong classification examples and the F1 scores, and what we can see is that the data distribution affects the accuracy performance. So we can see here that minority labels, so labels with a low amount of occurrences, have very low F1 scores compared to the majority labels. And we can also see that BERT often has a higher F1 scores on these minority labels than LegalBERT. We also performed McNemer's test for model comparison, and we can see that the most important comparison is, of course, between BERT and LegalBERT, and we can see there's statistically significant results, meaning that these models have a different proportion of errors. So to conclude, our approach aims to give more insight into the automatic detection of legal violations in cookie banners by comparing frequently used models. The challenges of these automatic classifications are due to purposefully confusing wording, lack of classified data by experts, and the shortness of the cookie banner text themselves. And our obtained results show that using a state-of-the-art classification model off the shelf or with minimal fine-tuning will not yield reliable results for auditing or helping policymakers, since even the best performing models are affected by skewed data. And future work should include working with a data imbalance, such as using data augmentation. And since the style and language of cookie banners change very rapidly, we need robust algorithms that can adapt to these changes. And it's crucial to develop an efficient annotation pipeline to speed up the human-in-the-loop annotation and the automatic classification. And our initial tests give insight into the model performance for certain challenges and can be used to further build such a pipeline.
Yep. Is that it?
Yes.
Great. Also great photo with cats. Wonderful. I really love it. Thank you very much, Marike. Great presentation. Yes. I really want to kind of mention something that you included in your presentation, the idea of cookie banners not being legal texts. I'm trying to use this sentence to activate Pauline for another question in the Q&A section, because that's debatable. So, and that's also very interesting for the future of NLP. But now we move on to Daniel. So thank you once more, Marike. We move on to Daniel, who's going to talk to us about diachronic word embeddings for court decisions. Daniel, the floor is yours.
Yes, thank you very much. I want to start by briefly talking about what diachronic word embeddings are, if you're not yet familiar. So the idea behind diachronic word embeddings is that instead of training one word embedding module on a whole corpus, we split this corpus time-wise, for example, into chunks of years or decades, and then train individual word embedding models on each of these slices. And that allows us then, for example, to track semantic changes over time. And this technology has been applied in different domains. There's also a nice survey paper from 2018. So you might ask, well, why do we need another paper about diachronic word embeddings? I probably don't have to convince this audience that legal language and the use of language in legal context is often different from everyday language. Especially we have words that are more strictly defined and therefore arguably their meaning is also more stable. Diachronic word embeddings so far only have been trained on a legal data set once, and that was decisions from US federal courts. And there the authors looked at how a semantic shift that was started by one court decision propagated into other court decisions. And I would say that's very close to what you can also see in everyday language. So maybe one newspaper article starts using a word in a new context and then it spreads. But there's also one trigger that is very specific to the legal domain, which has not been looked at yet, and that is legislative changes. Because if there's a legislative change, then we have an immediate change of the meaning of the word in a legal context. And it's also universally valid. So I cannot choose as a court whether I want to adopt this new meaning or not. I am forced to. And that's why we looked at court decisions. Specifically, we used the data set from Open Legal Data. It contains of more than 200,000 court decisions from 1970 to 2020, at least a chunk we used, and it's the data comes from 626 different courts in Germany. So what we did is then we looked at 3 legislative changes in Germany, and for this presentation I want to focus on one particularly, and that's the broadcast fee state contract of 2013. And what that did with regard to semantic shifts is that it renamed the obligatory German public broadcasting fee from Rundfunkgebühr to Rundfunkbeitrag. And prior to this legislative change, the word Rundfunkbeitrag already had a meaning which would describe a TV or a radio report. And what we did then for all of these cases is we looked at the most similar words prior and after the legislative change. So what are the most similar words in the word embedding models prior and after 2013? And then from each of these periods, we took the most similar word and plotted the cosine similarity between the most similar words and Rundfunkbeitrag. And if we look at the most similar words, we can already see quite clearly how the meaning changed. So before 2000, we have dates, which is connected to the fact that we are talking about individual TV or radio reports. So they are referred to in judgments with a specific date when they were aired. And after 2000, we see that there are basically a list of different fees, because now the Rundfunkbeitrag has the meaning of public broadcasting fee, basically. And if we look at the time scale, then you can see that in 2013 was when the legislative change came into power, and you can see that immediately the meaning changed from pointing basically to a specific TV or radio report to this fee. And if you look at the paper, you can see more examples of it. So what does that mean? Well, first, we have shown that changes in legislation can cause almost instantaneous semantic changes, which is not very surprising. It is what we expected. And we've also shown that diachronic word embeddings can be used to track these changes. We also trained one model on the whole corpus, and there we always had the meaning of the post-2000 models, so of after the legislative change, which is not surprising. If we look at the distribution, we see that this is where most of the data is. But that, of course, has practical implications, because if we want to use such a model in a downstream task like classification or outcome prediction, we have to keep that in mind, because especially when we look at laws that recently changed, we might want to use, only part of our corpus actually to train word embedding models, because if not, we will end up with, in this context, wrong meaning because its meaning has changed. Thank you very much.
Thank you very much. And now time has come to basically have the same Q&A session. So I would like to invite all of the speakers to join us here. And I see that there are also more authors in the room. So if you would like to also contribute, please, by all means. Are there any questions? I think I already saw a question from Jonathan.
Let's start in the room first.
Oh, yeah.
This
Okay,
time.
let's go. Let's do that. So Leslie? Oh, the microphone.
One question from the room.
Okay.
I have a question for the last regarding the last presentation. So you showed that changes in legislation lead to changes of word usage as well, and that models might be affected by this. Can you comment on how, to some extent, this is expectable, right? But what can we, except for retraining our models and extreme data, what can we do about it? Do you have any ideas on this? Because, you can see that something will change if there's a change in legislation, right? And where do the diachronic embeddings come into play there?
Yeah, definitely it is to be expected, and it was what we expected. I'm not sure if the diachronic word embeddings themselves can be or are useful for the later application. I think they are more useful for identifying these semantic shifts. I think if we, for practical solutions, I think the best thing we can do is, especially if we look at tasks where these changes are relevant, to use data that includes only the meaning that we are looking for. You could also try to manually manipulate for this one word, then the embeddings, by maybe also even using artificial data. I think basically this comes down to a general problem, which is whenever we have a change in legislation, we first need some training data. And this is just a specific example where not just training data is missing, but actually also the old data might point at something that is wrong. But I don't have a solution other than carefully picking the data you train on.
Okay, thank you.
Cool. One more question from the room. Jerry?
Yes. Hi, I have a question. I'm Jerry Spanakis from Maastricht University. I have a question for Marike and the cookies paper. Well, maybe 1.5 questions. So my question is main question for the results, right? For some of the classes, it seems that you completely fail to identify them, right? So I see 0% or like, and I guess they are the most challenging ones, like negative framing or the prolixity, the technical jargon. Did you maybe have a look, like real look at this to check why is that, apart from the fact that it's difficult? And do you have any ideas on how to tackle this? Thanks.
Yes, thank you. Great question. I think that the main problem is that there's just not enough data to like really classify them correctly. So of course the negative framing, the prolixity, these only had like 20 or so occurrences in the whole data set. So it's very hard for the model to pick up on these things. And these are also the classes that are actually very difficult for humans to identify. So the class of misleading language and the class of framing are also difficult for experts to identify themselves. So it's very really not the text themselves, but how it's described. Like so that makes it very difficult to classify.
Okay, and the half, let's say, question is that so once a year, I don't know, I remove my cookies from my website, and then they start popping up one after the other whenever I visit a new page. So I'm wondering if you also plan as future work to look
maybe
at
to jump in there,
other like
one thing that we do have
patterns, like for example, yeah, design choices in the website, or sometimes the yes/no buttons, or yeah,
may
how
I
they're
take a word?
presented.
I'm getting
Yeah, just 1 second, because the question was not done yet, Almila. So I think, Jerry, perhaps you can reiterate the last part of your question, and then Almila, we can also listen to you.
Okay.
Yeah,
Jerry?
so the question was about if you plan to look in the future work, I guess, and maybe not related to NLP specifically, but like the design choices around cookie banners, right? I guess we've all seen that they come with the text, so it's not just the text that might be misleading or not exactly legal per se, but so design choices. So thanks.
Thank you. Yes, we plan to take into account the setting itself where the text is shared in the cookie banners, because that also has a big impact on how people make choices there. But to answer your question about how to tackle the problem, the first thing that we want to do is data augmentation and do more data annotation so that we have a balanced data set for the problematic classes. And as Marike said, yeah, these classes are also problematic for humans to be sure or to make decisions or to understand correctly the sentences themselves. On top of that, to have the interaction space with it, or how visually the text is supported to forward making wrong decisions, so to speak, and that's also in our to-do list, but that will come later.
Thank you so much, Almila. Any follow-ups, Jerry?
No.
Great. Any other questions in the room, Ilias?
I don't think so. Do we have any questions online?
Yeah, we have questions online. So I think there was one question that was addressed to Ivan. So Jonathan, do you also want to maybe elaborate a little bit on that, a little bit more?
Yeah, hi. Thanks for the presentation. And I think Ivan already gave an exhaustive answer. My question came from the fact. So my impression was that you were addressing the privacy problem, and that by doing so you also got a 2% percentage increase. And since it was not really maybe hypothesis driven. I was wondering if you had done some error analysis. But yeah, you explained it already, so I will read that section of the paper. Thanks.
I think we should need, we don't need to talk about, take a coffee and talk about it for 10 minutes. So I don't think there's room for it. I'm sorry about it, but I try to answer the main concern, like the data size matters.
Yeah, perfect. Thanks.
Great, thank you. And then we had, I think, another question from Pauline. Pauline, do you wanna talk to us about the legal dimension of privacy?
Yes, so I directed the question to Marika, and like you, Catalina, my ears pricked up when Marika said, "Oh, this is not legal text," and it might not matter actually. It might not matter, Marika, because it may be that you use legal experts to do the annotations anyway. So, but I am curious about this distinction between when a text is legal and when it's not legal, and whether you think this matters to your process, your methodology.
I think it doesn't matter per se, but it has to do like what kind of text you have and how you approach the problem. So of course we included AraLegal-BERT because we were curious if this would work for cookie banner text, because they're sort of in between. Like it's definitely different from like a normal a regular text, and it's also not explicitly like legal text. And I think what makes it difficult to classify is that cookie banners, of course, have a legal background, but they are not made by, I think they're not made by people with a legal background. It's usually more of a psychology background, because the people that make these cookie banners, of course, want you to accept them. So they try to word the things like, oh, it would be great to accept them, or make them difficult to, like you have the framing, you have the misleading language, but these are not necessary legal text per se. Do you want to add something to that, Emile?
I think our main way of this differentiating between legal text per se and cookie banners was more grounded in the training data that is used. For example, for AraLegal-BERT, the legal documents are used, and in comparison, the language is very, very different. So we weren't expecting such a good performance coming from AraLegal-BERT. And that's what we wanted to highlight there. But yes, we agree, definitely the cookie banners or any type of text could be legally important, and we should be also addressing this and how to make NLP answer to, in general, not for cookie banners, but in general for other types of text. I think in cookie banners, it just becomes so much to the front and visible that any type of language that is used for misleading, purposes should be taken into account.
Thank you very, very much.
And thank you for the note when you say, yes, it would be really interesting to develop this effort to make it visible for all the users how much actually cookie banners are violating the law.
Thank you very much, Almila. Looking at the time, I would suggest, Reto, that perhaps you can ask your question also to Marika in the chat, because I have a very quick question for Dimitrios, and this deals a little bit with the applicability of the models that you have been discussing, and also their perhaps actually their explainability, because we were speaking about predicting the case law. What are your reflections on the explainability of these models if we consider them as applications in this judicial field?
Can you please repeat the question, because I did not get it as much as I could get it?
Yes, are these models explainable? So for instance, if we're speaking about predicting case law, that can be in some fields and also in some jurisdictions a rather challenging question or challenging issue. So I'm wondering whether this is at all part of your research or contemplations for the research.
I think this was not part of our research. I'm not sure if Petros, a co-author who is inside right now, can add something to that. I'm not sure, Petros, if you want to add something, but we actually, we do not take this into account. Petros?
Yes, in fact, hello everyone. Do you hear me?
Yes, we hear you.
In fact, this was not in the scope of our work. Our major goal was to investigate those two different approaches, the bug of words one and the modifications of the former, and to focus on the trade-off between efficiency and performance of these two approaches. So this is in the scope of possible future work.
Yeah, great. Yeah, I was wondering, and I know that this is a completely different field of study, but I was wondering whether this was in any way a consideration for you. And I think, thank you very much. And I think that Ilias had another question for Ivan. Ilias, we cannot hear you.
Can you hear me now?
Yes.
Yes.
Cool.
Great.
Yes. Hi, Ivan. There is a question that I raised on Twitter, and we discussed it very little with like 1 or 2 tweets. It was the question of, do we really want to make all information private when we have a legal LM? For example, we know that in many cases, when we have legal corpora, by default, a lot of information is preserved, either by anonymizing the documents or by using different languages, by not stating names or gender or age or whatsoever. So depending on the situation, the court opinion is written in a different way, or the laws are written in a different way in order to preserve anonymity. So I would like to know if, can we balance this kind of situation where we want to preserve some information and we want to keep whatever has to be private, and whatever has to be public, public. And I know it's a strange question, a hard question, but I would also like to hear Ivan and then maybe some of the legal scholars what they think about this balance of private versus transparency and whatsoever. Thanks.
Okay, so thanks, Ilan. Nice to see you or hear you. I don't see you there at Abu Dhabi. Hope you're having a great time. Yeah, so this is a great question. Basically, what we have anonymization. I try to compress in 30 seconds. So anonymization, where you just remove a couple of names or entities, and there's some works from, for example, the group from Pierre Lison. They're trying to anonymize core decisions in ECHR, for example. Then you have like very high precision for these entities, but then you don't know about the rest. So you have no formal guarantees of these anonymization because they work as good as your NER, works, or as long as your adversary doesn't use some other side channel attack. So what you see in this GPT-2 scenario of the attack is that, you never know what the adversary will be able to in 5 years, 10 years, 20 years. So this differential privacy is basically taking the worst case scenario and protecting everything, whatever this everything means. In this case, it means it protects every gradient, so to say. And the gradient, what it means is it's basically a batch of whatever you pre-train on, so a sentence and the tokens. So basically everything is protected. The idea here is that you don't have to say what should be protected, and you want actually to learn something general about the population. So you want to learn a language model about language or legal information, which is a general thing, but not really particular to one exact data set. So you want to protect each exact data set because you don't care about one person there. You care about the general capability. So this is where you are. And of course, you can combine those two things. So this is very formal. This is informal, but practical. Where, how to manage these two things, it's an open question, actually. But it's a great topic, actually, yeah.
Cool, thanks.
Thank you so much. And Leslie, do we have one final question before we move to the coffee break?
Yeah, I do. Question for Dimitris, actually. So I just wondered what your opinion is. If you look at NLI, the corpora that exists are very short, pretty much, and in law they're going to be very, very long, right? Do you think what are the implications for your model on something like legal NLI? Do you see that as something that could be used for that, for more complex cases?
We guess that yes, it could be used because the long form based models, as we were introduced before, they can see longer text. So I think that it will be okay. I'm not sure if Petros, do you agree with my statement? What is your opinion about this? Can you hear us, Petrus? Or yeah.
Yes, I agree with that.
Yeah, but generally the point of our presentation was just to mention the technical differences between those two approaches. And yeah, we think that the long-form based model will be capable of handling those cases as well. Yeah. I'm not sure if I'm not sure if I answered the question properly.
No, you did. I was purely speculative. I mean, as we've heard, legal text gets increasingly complex, but there are legal inferences that can be drawn. Just the text to do that would be very large text. So it would seem like a model like yours would be pretty
exactly. And the long-form
pretty
based
applicable
models
there.
can see as well the paragraphs, can identify the paragraphs as well, as I mentioned, by placing the global token inside. So we guess that will be no problem for that.
Great. Thank you very much. This brings us to an end for our session. Thank you very much for your presentations, your papers, and also this very interesting discussion. Marika, Daniel, Ivan, and Dimitrios, the room in Abu Dhabi is going to now head for a coffee break, depending on your time zones. Then perhaps you might want to have some coffee or something else in the evening. I don't know, but thank you once again, and thank you for being part of this workshop, and wishing you a lovely day.
Thanks, everybody. Come back at 4.
Thank you.
Good afternoon, everyone. I'm just going to go ahead and make everyone the co-host who needs to present.
We still have a lot of people out wandering around.
Yeah, perhaps we can wait for a few more minutes.
Yeah. You're doing a great job, by the way.
Are you talking to me?
Yeah.
Oh, great. I didn't even play the music anymore. So let me know, everyone, if you feel like listening to some Eurovision music. I also have 90s music, but we're also trying to make sure that YouTube is not going to take our stream down. So yes.
You know, if it were up to me, it would be blasting EDM.
We can do that after the panel.
Okay. I might need that to stay awake.
So I see Suparna or Emilia, are they here already? Suparna is here. Great. Hi, Suparna. I'm just going to make you co-host. You will be presenting, right?
Yes.
Wonderful. Raisa, I already made you co-host. Then we have either Diane or Young. Let's see. Oh, yeah. Young is here. Hello. I'm just going to make you co-host as well.
Sean is here. I see
Marijn.
16 participants.
Yeah. Marijn is here, has been here since the beginning. Then we have Sagar. No, Sagar. Joshi. Let me see. Oh, or Aparna. Not yet. And I'm also going to make everybody else, so also in the second part of the session. So Sean, I saw you already. And then Leonard, not here yet, I think. Or Lena, or is Yvonne presenting again? Okay, we don't know yet. Then Kathleen, Emily.
How many folks do we have presenting?
So we are going to have, we're going to have all the presentations remotely in the next session. And yeah, we have two kind of two separate sessions, two separate themes, one with 6 presentations and then one with, another one also with 6 presentations. And then after each of these sessions, we're going to take a Q&A. So that's why I'm just making everybody co-host already.
I'm just trying to figure out, have we exhausted the people in the room in terms of presenters?
Yeah. Okay. Yes. Also, in terms of time zones. So everyone, we try to accommodate as many time zones as possible.
I know. That was really hard.
Yes, but it was, let's put it like this. I am very happy that my brain got some training in calculating time zones because I'm very bad. So it was great. I think that we're ready to go with the first session because I don't think Sagar.
Yeah, I think you should, because we're already 5 minutes after.
We're 2 minutes after, I think. Right?
2 minutes after. See, I set my watch fast so that I can keep up with myself. So otherwise I'd be late for it.
Very good tactic. Okay, so we have the first 4 presentations, and then I think that once everybody comes back into the room, so for everyone online, now that we have to do this in a hybrid way, then we're trying to get everybody who's there enjoying apparently some very delicious peanut butter cookies, as I have been told. I haven't seen any photos of that yet, but
I tried the chocolate chef. I think Ilias tried the chocolate chef.
Great.
We recommend them.
Wonderful.
It's
So yeah,
of the conference.
Cool. I think we can start. Yeah.
Yeah.
More people join
People
later.
are coming back. I think we're good.
Perfect.
To go.
Then go right ahead.
Cool. So we have, as Catalina said, the next session with 6 papers. Most of them are about language generation. The first one, I guess, it's not. Do we have Raisa with us? Yeah, we have. So Raisa, yes, the paper is, should I disclose my data set? Caveats between reproducibility and individual data rights. Raisa, the floor is yours.
Okay, thank you. Can everyone hear me?
Yes, we can.
Yes.
All right,
Okay, so I'll share my screen so you can see my presentation. So, can you see my presentation?
Yes.
Okay, so I'll start, and if anything goes wrong, please let me know. So, hello everyone, my name is Raisa Benatti, and today I will present our work, Should I Disclose My Dataset? Caveats Between Reproducibility and Individual Data Rights. I authored this paper with Camila Villarroel, Sandra Avila, Esther Colombini, and Fabiana Severi. We are from the University of Campinas and the University of São Paulo in Brazil. So we start from recognizing a scenario in which documents issued by public institutions are more and more available each day in digital format, which makes it easier to use them as data source in many domains. We stress the example of core documents, for instance, decisions, which are especially interesting in our context. In scientific settings, we are also constantly worried about the reproducibility of our work, and in the computing communities, we are particularly used to a culture of resource sharing. So, for instance, making our data sets available is a good example of this, and this is great for reproducibility. However, when our data sets are made of core documents, sometimes they can carry secret, sensitive, or delicate information, and disclosing them might cause or increase the odds of causing harm to the subjects involved, even if such documents were already publicly available in other sources, since we as researchers carry a different kind of responsibility and implications. So we might come across with this question: as a researcher, can I really disclose my data set made of core documents? We try to provide guidelines to answer to this, built up from the example of gender-based violence-related cases brought to Brazilian courts. Thinking about this scenario helps us identify some of the issues involved, since there might be human rights at stake, and such cases often carry sensitive personal information. The Brazilian legal system, in particular, is an interesting case study, since the country has an enormous amount of core documents digitally available and a strong community of scholars and practitioners interested in using them as a data source for research. Also, our system is a civil law-based one, which means that it has similarities with other civil law-based systems. So, although we focus on Brazilian law to build our guidelines, some of our suggestions might apply to other scenarios. To build those guidelines, we consider legal statutes such as the Brazilian General Data Protection Act, which is very similar to the European General Data Protection Regulation, the Brazilian Access to Information Act, and issues related to the importance of publicity, of justified secrecy, and of the disclosure of sensitive personal data. We also stress the importance of thinking about what risks we might contribute to create or increase when, as researchers, we decide to bring a data set publicly, especially risks that possibly would not exist otherwise, since our data sets are often disclosed in a more structured way than those of original sources. And this flowchart here sums up what we consider to be the main elements of our guidelines. So we should start by asking if our data is provided from cases under secrecy. If that's the case, or if we can't really tell, we should not disclose it unless we use some mitigation measures, such as data anonymization or disclosure by demand only. If our data is not really secret, but still contains sensitive personal data, mitigation measures should also be considered, especially if disclosing the data is not an essential part of the research. After all, full dataset disclosure is not essential to achieve acceptable levels of scientific reproducibility. If no restrictions apply to our data, it is not illegal to disclose it under Brazilian law and similar ones, but it is important to analyze specific context and build a proper risk-benefit assessment. For the future, we argue that having guidelines and recommendations in place provided from official data protection entities aimed specifically at researchers could help us solve some of our inquiries on the matter. Besides that, having anonymization tools available as well as official institutional data repositories might help we as researchers comply with the measures that we propose to mitigate risks associated with full dataset disclosure. We hope that this helps us comply with good scientific reproducibility practices, while also being mindful of individual data rights of the subjects involved in our datasets. Thank you for this opportunity, and I hope that we can keep this conversation going.
And we'll go to the next talk. Do we have Emilia with us?
No, this is Suparna.
Suparna, okay, perfect. So yes, Suparna is with us to present privacy pitfalls of online service terms and conditions, a hybrid approach for classification and summarization.
Okay, hope slides are visible now.
Yeah, perfect.
Thank you. Thanks for inviting us to present a paper here. I'm Suparna De. I'm from the Department of Computer Science, the University of Surrey in the UK. And this paper has been co-authored with Emilia, also from University of Surrey, and with John Johnson from the Social Research Institute at UCL, UK. So the motivations for our work was an experimental study which said that 98% of the people do not read terms of service when they hit agree to these terms of online services. And the main reasons said were because these terms are very long and also they are quite complicated. However, we know that these terms of service are legally binding as well as being unilateral contracts. And an unexpected reason is also when companies want to use third-party software in their own products, they might have some unintended consequences, as we know, when Facebook said they did not read the terms of conditions of the global scientific research work when that was used for quizzes on the Facebook platform, which led to millions of people unwittingly having their informations taken from their Facebook networks. So we aim to address this issue by selecting key clauses from such terms of service documents and then paraphrasing them for users. So we have 4 key contributions of this work. The first one is a web scraper, which we built to fetch terms of service documents from online services. And we use this to curate a terms of service data set, which we also make publicly available as part of our contribution to the community. And this has been applied to a hybrid extractive classifier abstractive model, which is used to select the important clauses using a classifier approach. And this is followed by paraphrasing them using summarization techniques. And finally, this has been applied to a website and plugin. We shall have a quick look at the website at the end. So the hybrid model consists of an extractive as well as an abstractive component. So we have the web scraper tool, which is used to fetch the terms of service document. And these are then applied to a weak supervision approach, which means that we have some heuristically defined rules based on our assessment of the labeled data set that we use in our work, as well as the terms of service documents that we have retrieved from the scraper. So for example, could be the regex, where we have verbs such as collect and sell, and they are occurring in close proximity to any references to personal information. And this is then used to train a Roberta classifier so that it is robust enough and can generalize to unseen sentences as well. So we see here at the top a sentence which we deem as important from the classifier. So we give your name and phone numbers to other companies. And this is then fed to the abstractive component, which is a sequence-to-sequence encoder-decoder architecture of our LSTM layers, which has been trained on sentence and summary pairs from this domain, and is also able to generalize to new words which do not occur verbatimly in the document itself. So for example, here we see your personal information is given to third parties, which is the summarized text. one of the main outputs of our work is that it is able to work with very few training pairs. So we see here 4,313 training pairs as compared to 297,000 in state of the art, and it's giving quite good performance in Rouge as well as Meteor scores against some extractive baselines. And if we look at the abstraction rates as well as the compression rates, we get good performance here as well, which means that these are clear as well as easy to read for users. So finally, I would sort of draw everybody's attention to this link, which is also in the paper, which we have made available, are scraped data sets for 163 online service terms of service documents. And we plan to use these for user studies to test the comprehension of the generated summaries through platforms such as mTurk. And I will take this opportunity to quickly show the terms of service website. So this is the Summarizer website. So here we fetched the Slack terms of service. And if you see here, it's quite long. There's quite a number of terms. And we would expect that people would sort of scroll to the end and just hit agree. And here we have the summarized version of this. So we see here that its service gives the personal data to third parties, which are the cookies are also used for advertising. And it also holds on to content, even though which may have been deleted. And it also secures the record of your data for analytical purposes, even after the data retention period. Okay, so thanks a lot for your attention, and happy to have questions at the end. Thank you.
Cool. Thank you, Suparna. We can move to the next talk. I think we have with us Yang Song from the University of Pittsburgh. And the paper is Computing and Exploiting Document Structure to Improve Unsupervised Extractive Summarization of Legal Case Decisions. Yang, you can start.
Thanks.
You can see your slides.
Oh, sorry. Sorry. Let me restart my slides.
Yeah.
Yeah. Hi, everyone. My name is Yang, and today I'm going to present our work on computing and exploiting document structures to improve unsupervised extractive summarization of legal case decisions. So legal documents such as case opinions tend to be long and have diverse document structures, depending on the court, the times it is being released, and the case details. To facilitate the understanding of such documents, the law committee has put some efforts in composing a short summary that can cover the main points of those decisions. However, even for human efforts, summarizing the long legal document is not easy work. Firstly, comparing to the news articles with an average length of several hundred words, legal opinions tend to be 4 to 5 times longer, similar to those of the scientific papers. Meanwhile, compared to scientific articles, which come with a fixed and explicit section structure, like starting with abstract, introduction, and so on, legal documents can be split into different sections, the paragraphs, or even just simple span text. We proceed that a good summarization model should be aware of those document structures and better utilize it to generate the final summaries. Moreover, comparing to other two domains of summarization tasks, legal data sets tend to have a small number of data points and often have the access to them are normally restricted or limited. So comparing to a supervised model that may be data hungry and they're undertrained under this setting, unsupervised method is always favored. And lastly, legal document summarization had demand for accurate wording, while works on other domains show that abstract summaries suffered from hallucination problems, generating unfaithful tokens that may be misguiding. We perceive that extractive method here could be a good first step. So one thing notice that the dataset we use in this paper also comes with the sentence-level argumentative labels. So as shown here, summaries include a high percentage of argument sentences, and the green, blue, and red are referring to the conclusion, the issue, conclusion, and reasoning of the court decision. Meanwhile, in the original documents, we saw that not like news articles, we have a dense distribution at the beginning of this article on the details. The argument notice tend to distribute equally across the sections. With those in mind, in this work, we focus on a model that is structure aware, applying unsupervised method and produce the extractive items. So our work have two main lines of attribution. We start by exploring the effects of document structures. We use the baseline model of named HyperRank, which builds hierarchical document graphs based on the sections and sentences relations to aggregate structured information on the scientific articles. However, for legal case, as mentioned earlier, the legal case may not have the same or universal explicit organization sections, but instead multiple implicit structures existed, and thus we propose to extract varying structures with different segmentation methods. We then feeding them into the baseline model, trying to evaluate how the generation quality is being affected. Here's the example of the segmented views, where we have the sections extracted from the semantic prompt view, the topic modeling, and the raw text organization from the HTML of the court decisions. We show how this baseline model behaves with a different structure input. Meanwhile, we move on to a reweighting algorithm to further improve the sentence selections. Normal attempt on the unsupervised method is to do a one-time sentence scoring and then pick the top K ranked sentences as the final summaries. However, for long legal cases, the models have bias in selecting the two unintended contents and favoring neighboring sentences when they have given the similar high score. To mitigate this bias, drawing from the observation that the high score sentences are of good quality, we divide the sentences selection stage into two phases. The first phase, we select the portion of the top ranked candidates as the seed or the anchors. And in the second phase, we use those already selected ones to penalize the neighboring sentences in the same section or are highly similar, thus encouraging selection of the middle contents, which are more important. We test our model on 1,000 case summary pairs from the Candy dataset, which is a collection of Canadian legal case decisions and their summaries written by the human experts. As noted earlier, this version dataset comes with sentence lab argument labels and about prior work. We mainly present the root-based metrics in this presentation, but we also include more semantic metrics as well as argumentative aware metrics in the paper. Our first observation is that document structures tend to play an important role in the summarization cases. Comparing to a baseline model, like the leftmost, the PEG-SUM, where the document is flattened into a list of sentences, encouraging the structured information greatly boosts the performance. We also validate the proposed reweighting algorithm. Here results show that the reweighting stably improve the performance across the root 1 and root long scores. Here's an example of the model outputs. We noted that with the structure information, setting information notice like annotated with colors here at both ends are correctly selected. However, for the baseline model, after selecting the fourth sentence, it favors neighboring due to the score commutation, and the next top ranked candidate is the non-important one, sentence 6. In contrast, with our reweighting algorithm, the score of sentence 6 after sentence 4 is selected, it got decreased. Thus, this can be totally filtered out, and we can improve the summarization quality by including more salient information of the article. So to sum up, in this work, we explored the effects of different document structures on unsupervised extractive summarization task. We further proposed a task-dependent reweighting algorithm to better select important sentences. We include more analysis and evaluation from the argumentative perspective, and you're welcome to check the paper. Thank you very much.
Thank you, Young. And we move to the next talk before we have 3 more, and then we'll have the joint QA. So the next talk is from Martin. Do I spell it correctly?
Yeah, my name is Marijn.
Okay, perfect. Nice.
See the slides?
Yeah, I see the slides. So the paper is abstractive summarization of Dutch court verdicts using sequence-to-sequence model.
Okay, thank you. So various countries across the world are providing free online access to court proceedings. But the available documents are usually long and difficult to understand for people without a legal background. Therefore, it is important to have summaries for these documents, both for different types of users, both from the general public as for the legal community. Summaries are often not there yet because it's very difficult to write summaries. It takes time and it takes expertise. So today, the research I present is to generate the summaries automatically to make them more easily available and to increase the value of online court proceedings. So the data that we use for this research is the archive of Dutch court proceedings from the website rechtspraak.nl. This website is an official website that publishes a small selection of case documents, currently around 2% of all cases per year. However, there are plans to release a much larger amount of cases in the coming years, which makes it even more important to have automatic summarization. So for a number of the cases that are released already, a manual summary is provided, written by humans, and that can be used to train machine learning models in a supervised way. So here you can see a small example document about an appellant case, and below, so the document is much longer, didn't fit on the slide. Below you can see the summary that one of our models have generated for this court decision. So the models that we use for this, there are two different types of models implemented by two master students, each for their own thesis project. They are the first two authors of the paper. The first of the models is a bidirectional long short-term memory model with a hybrid architecture that first extracts important sentences from the source documents and then rewrites them. The rewriting is intended to make sentences shorter, easier to understand, and more coherent with the rest of the summary. And the word embeddings that are used by this model are trained on the fly on the dataset itself. Then the second set of models are based on the BERT transformer model, which is a direct sequence-to-sequence architecture without an extraction step in between. The word embeddings that we used for this are pre-trained on general domain Dutch data. And here are some of the main results. We can see that the BERT model is better than the LSTM model in terms of Rouge score. So for those of you who don't know, Rouge is an automatic evaluation metric that counts different types of n-gram overlap between a reference summary and a generated summary. We also compared with the performance of the BERT model on the CNN Daily Mail dataset, which is a standard baseline evaluation data set. And you can see the performance is comparable to that, which is a good result because the legal text that we have is much longer and much more domain specific than the news articles that are in the CNN Daily Mail set. And apart from the automatic evaluation, we also did a human evaluation. So for the LSTM model, we asked law students to rate the content and readability of the generated summaries. For the BERT model, one of the authors rated the summaries himself on 4 aspects: informativeness, relevance, fluency, and coherence. And here we can see the results on a scale from 1 to 5. They show that the example summaries are still better on all aspects. So both the content related and the grammatical aspects than the generated summaries. However, the summaries are already at the level that they provide useful information about the case, which is, of course, preferable to not having a summary at all. You can see also in the human evaluation that the BERT model performs better. However, the ratings for the reference summaries in the BERT case are also higher than for the LSTM case, which means that the annotator was a bit biased towards higher scores. So yeah, we cannot really conclude from this that the BERT summaries are better in all these aspects than the LSTM ones. Okay, some takeaway messages from this. So in general, we can say that trained models perform quite well, but they are not as good as human-generated summaries yet. So both of the models are abstractive, which was also mentioned by the previous speaker, that they can sometimes hallucinate. So yeah, it's an interesting question if for legal summarization, indeed, abstractive summaries are better than extractive summaries or not. So this is an open question as far as we are concerned. Then the Rouge metric, also mentioned briefly by the previous speaker, that also used BERT score, for example. Especially for abstractive summaries, Rouge is not very good because abstractivity usually means you use different words, different word orders compared to the source text or the reference summaries. So Rouge is not the best metric for this, but it's still correlated to the quality of the summary, so it can still be used for evaluation. Then again, repeating from the previous presentation, legal documents have structure, court proceedings also. There's introduction, a context, a conclusion. Currently, we don't use that for the evaluation. We evaluate or for the production of the summaries, which may be able to increase the quality further. Then we saw that the type of law, if it's administrative law, tax law, family law, that makes a difference in the performance. I didn't show the table now in the presentation, but there are sometimes a few percent differences there. Also, the time frame, if it's an older case, a newer case, they have different performance. Because of that, we thought maybe it's interesting to cluster first the documents on these kind of aspects, and then train classifiers on these smaller clusters to improve overall accuracy. But we did some experiments for this, and it turned out not to be the case. The model that trains on all the data is always better than models trained on subsets of the data, even though the data is heterogeneous. So these are just a few aspects that provide opportunities for future work that we hope to do and present to you in following editions of this workshop. But for now, thanks for your attention.
Okay, thank you, Martin. And we'll move to the next paper. The presenter is named Sagar Joshi, and he's going to present us graph-based keyword planning for legal clause generation from topics. Sagar, you can start. Sagar, do you hear us? Sagar?
Oh, yeah, just give me a moment.
Okay, you were muted. Cool.
I'll be
Now we
sharing
can
my
hear you. And we'll see the slides.
Okay, thank you. So hello, everyone. I'm Sagar. I'm a master's student at IIIT Hyderabad. I'll be presenting on work on legal clause generation, which was a collaboration between IIIT Hyderabad and Adobe Research. So the motivations for our approach lie in lesser work done in generation of legal clauses as such when it comes to NLP. A previous work on clause recommendation was proposed for generating or recommending a new clause to an incomplete contracts draft. However, we found the approach to be limited to a specific clause set and also not have controllability in the process. So hence we started off with having some sort of an intuitive pipeline that would work on a broader set of clause topics while also having controllability in the process while involving a minimal user input for general clause generation. So our key contributions include a two-stage pipeline, which consists of a graph-based planner followed by a transform-based clause generator. The content planning, which is done prior to generation, is done in a specific order that consists of keywords that go from topic generic ones to clause specific ones. Our pipeline achieves strong empirical results for clause generation, and we show strong, robust generation for a broader set of clause topics. And we also show scope for interactive clause editing tools using our SOTA method. So this shows the schematic of our approach, consisting of initial graph panel for content planning, which takes in a user input, which may be a topic of the clause to be generated, along with a few custom keywords for generation. followed by a plan generation, which consists of an ordered plan, like I discussed, topic generic keywords followed by clause specific keywords, while incorporating the user specified custom keywords. So this content plan is fed to a transformer-based clause generator, which generates clause content incorporating the given keywords. We make use of the Ledger dataset for our experimentation, a subset of the Ledger dataset, which works on like a broad range of 939 clause topics. The Ledger dataset essentially consists of a clause corresponding to its clause topic, as we can see in these examples here. So we represent clauses using keyword order, which, like I said, like consists of topic generated clause specific keywords. So this was approximated using Ye keyword extraction on a library of all the clauses under a topic. The keyword order was used to construct a graph capturing this information. The graph is essentially a directed graph, which consists of topic and keyword nodes, which are interconnected based on the recurrences in clauses. So the edges from the topics to keywords determine the overall strength by which a specific keyword occurs under a topic, or a specific keyword is followed by the other keyword with in the particular topic in all the clauses. In plan generation, we use the constructed graph to generate an n stage plan corresponding to n keywords, which are to be used in clause generation. At each stage, we rank the keyword nodes at a particular stage based on their edge strengths, followed by random sampling from a few selected top K keywords to select a coherent keyword for applicability in that content plan. So for generating clauses, we compare against 3 baselines as input to the generator model. One of them being like a simple prompt-based baseline, which is like you specify the first K keywords of a clause and try to generate a clause based on the initial prompt. A simple topic-based clause generation, modeling on just the topic of the clause, as well as we compared against a random content plan so as to show the merit of our approach as opposed to a random keyword order. For clause generation, we used BART and GP2 based models for generation, along with a simple TF-IDF based retrieval for comparison. Experimental results show the superior performance of a BART based approach using our specified content plan, compared using blue and rouge metrics. We can also see the robust performance of our best performing approach over a broad range of clause types, which differ in 2 orders of magnitude with respect to the number of clauses under a particular topic. Here we show an applicability of our approach in interactive clause editing tools, such that taking in user input, generating preliminary generation of a plan followed by clause generation, after which the user can remove or add keywords to the content plan for controlling the clause content. And the clause generator is pretty much able to generate a clause that would be loyal to the specified content plan by either keeping the keyword which is added to the plan or removing the keyword which is removed from the plan. We can extend this work. So basically, in conclusion, we show a simple lightweight graph-based mechanism can be useful for controllable clause generation, along with promising empirical results. In future scope, we can try to include phrase level control rather than simple keyword based control. We can also try to include entity specific and contract specific information in the clauses from the user input. And we can also try to make the control of clause content more precise by ensuring that just the specific changes with respect to clause content are reflected with respect to the changes in keywords. So that's it. Thank you. We are open to questions in chat.
Thank you to Sagar for the presentation. And now we have the last talk of this session. I think we have Aparna with us. Yes, we have.
Yeah.
And the paper is called Text Simplification for Legal Domain, Insights and Challenges. And Aparna, you can start sharing.
Sure. I'm just, okay. I think it asked me to quit and reopen in order to share. I'll just be back.
Okay, we'll wait for 1 minute. Catalina, Daniel someone has to make Aparna co-host again.
Oh yeah, I will make her a co-host.
Once
again,
it joins,
yeah.
It has to be co-host again. Cool, thanks.
Yeah.
Aparna, now you're a co-host. It should work.
Yeah. Can you see my screen?
Yep, we can.
Yeah. Okay. So good afternoon, everyone. This is Aparna. Today I'll be presenting our work on text simplification for legal domain and some insights and challenges that we noted in this process. Yeah. Okay. So all this this was the work done in at Adobe Research while all the authors were at Adobe Research, and in this work we focused on two. I don't know why this keeps going, but anyway, we focused on two main two research questions. First, how well existing text simplification systems generalize to the legal domain. And second, what could be the challenges in using existing evaluation metrics for legal text simplification? So as we noted in the previous presentations, legal domain and contracts are pretty difficult to read for lay people without much legal background. So we focus on text simplification and do some preliminary studies in this work. We specifically looked at SEC contracts, and we took a few sentences from SEC contracts to evaluate existing methods and metrics on them. So first, for addressing the first question on generalizability, we focused on lexical simplification, sentence splitting, and the split and rephrase tasks. For lexical simplification, we took BERT-LS, which is a recent method, unsupervised method that uses pre-trained BERT to find candidate replacements for complex words. For sentence splitting, we looked at DISM, which is a recent rule-based discourse-aware syntactic simplification system. It breaks down complex sentences into a set of minimal propositions. So this is again an unsupervised method for our domain. We also fine-tuned BART, a denoising autoencoder, on a recent sentence splitting corpus, mini wiki split, which consists of complex and simple sentence pairs from Wikipedia. Though this is supervised, it's still out of domain because of the lack of splitting data sets for the domain. Finally, for split and rephrase, we used a recent unsupervised method, an RL-based method, keep it simple, which generates using GPT-2 while balancing rewards for fluency, salience, and simplicity. It uses reference-free scorers, so we could adapt it to our domain. Finally, we also trained BART on another data set, Small But Mighty, a recent one. It has two components, one on the Wikipedia and one for the legal domain. The legal domain one has annotations from Amazon Mechanical Turk, where the workers would still be out of domain in this case. They're not legal experts. In order to we looked at evaluation metrics on 5 dimensions. For meaning preservation, BERT score, coverage, and blank. Parse tree depth for syntactic simplicity. We used perplexity from GPT-2 for fluency. For hallucinations, we looked at an entailment-based metric and also the percentage of unseen entities in the output compared to the input, and a few standard readability metrics. So here is a snapshot of the results that we have. So first, the top row shows all the scores for legal sentences. As expected, legal sentences have poor readability and simplicity values and have high meaning preservation and hallucination, as it's just with themselves. BERT-LS for lexical simplification does not achieve much in terms of readability and simplicity. Meaning preservation and hallucination are also almost intact because it just does candidate replacements, though the fluency decreases a bit. In this case, perplexity increases, probably because of the unnaturalness of the sentences that would be resulting out of the replacements. Splitting methods, DISM and BART on mini-wiki-split, they have decent readability and simplicity scores. However, the fluency score is heavily compromised, as we see on the right, due to the abrupt sentence breaks it produces. Some of the qualitative examples are present in our paper. The Keep It Simple model, which is the unsupervised method, also achieves decent readability, simplicity, and fluency scores. However, it's heavily again compromised on meaning preservation and hallucination, as shown in the underlying numbers. So upon closer examination, we note that it generates a lot of factually inconsistent phrases, which is again expected because it's unsupervised. And then BART fine-tuned on the Wikipedia and contracts datasets achieves decent meaning preservation and hallucination scores. Also, readability, simplicity are fine. But then on, again, closer examination, it mostly copies the input sentences to the output with splitting and phrase deletions only without much rephrasing, though the datasets were meant to be split and rephrase. We suspect this may be because the annotators are not legal experts and most of the annotations in the training data are consisting of phrase deletions only. We also perform human evaluation with 2 legal experts from Upwork. And it is very interesting to note that the experts disagree in terms of how they perceive the simplicity of legal text on the model outputs. They have a negative correlation of 0.06. We note that the first annotator almost always chooses to exclude details while simplifying legal text and also uses more colloquial language. Whereas the second annotator includes most of the details in most of their simplifications while still paraphrasing the legal jargons. So we believe the target audience of our work are lay people without much legal background, though we obtain the annotations from legal experts because they could understand the text better than lay people. So target-centric simplification would be helpful, and that would be one of the future directions that I think we should look at. Whether the audience prefers to look at most of the details or just a summary view of the legal text, and whether the language is to be formal or more colloquial, and so on. As expected, the meaning preservation and hallucination dimensions have high agreement because of their superior understanding of legal text. Finally, we also look at the correlations of these automatic metrics with the human ratings. And we know that the last row shows this. We know that most of the metrics have pretty low correlation, indicating that they may not be readily suited yet for the legal domain. Readability, simplicity do have low correlation, so they don't probably capture the simplicity part of it. For meaning preservation, BERT score has a high correlation, though coverage and blank have low correlations again. Please refer to our work and the original papers of these metrics for the description of what those metrics capture. To conclude, we study some existing methods and metrics for legal text simplification. Some future directions would be that domain-specific datasets can definitely aid legal lexicons and splitting and rephrasing datasets from legal experts for the domain, as we saw that seek-to-seek methods perform only surface-level transformations. Expert annotators also interestingly have varied views on how legal text should be simplified, so understanding audiences' preferences could be aiding in building these parallel datasets. Further studies would be needed to identify appropriate metrics to capture the syntactic simplicity of legal text and also meaning preservation and hallucination parts of it. For further details, please refer to our work, and thank you. These are some examples of the results of the models.
Cool. Thank you, Aparna. And now we have the joint QA session for all the papers that we had so far on generation and text simplification. Any questions in the room? Okay, we have a question in the room.
Thank you very much. My question is for the paper on the Dutch court proceedings. Particularly, I was wondering if you ran any baseline experiments because you did this extractive summarization and then rewriting. But to me, it's not clear whether these second steps of abstractive rewriting actually gave you any benefit in the scores that you're obtaining.
Yeah, so the model does allow to adjust the parameters a bit for how much abstraction there is. But yeah, in general, this we have applied this model as it is, so including the abstractive rewriting part without just the extractive part. What I can say, however, which was interesting also for the BERT models, is that when you look how much abstraction actually takes place, it's usually not that much. The models kind of prefer to stay close to the original text. Also because the summaries that it trains on that have been written by humans usually contain verbatim phrases from the text. So the training is, in a sense, extractive, and therefore the models, even though they are abstractive, don't tend to change too much to the summaries that are generated.
Cool, thanks. We have one more question in the room.
For the last speaker on simplification, I wonder if it would be better to make it clear to the human judges that we want to simplify us in terms of having a simpler syntactic structure, or do we want to get the everyday language, layman language, which would be a different translation task, avoid legal terminology altogether is a kind of different task to translate from legal language to everyday language versus just simplify a long document into something easier to read.
Right. Yes. So in our instruction set, I think we provided a superset of most of the things like avoid legal jargons and syntactically simplify them, have shorter sentences, not a lot of less nested sentences and so on. But I agree that having a focused view, just focusing on syntactic simplicity alone or just avoiding legal jargons alone, I think that because of too many instructions, I think it could also be that in the process of achieving one, probably the other is compromised, I think. But yeah, specifically, we kept it open-ended, whether to include all the details or retain the most important information. I think that part, yes, based on, we wanted to see how well they agree on in terms of that aspect.
To follow up briefly for the paper on term of services, maybe the terms of service summarization needs to be for everyday language, because otherwise we still don't understand it.
Yes, I think that's something that we are looking at to recruit people for assessing the comprehensibility of the abstractive summaries. And this is something we've seen from current state of the art, that if we use purely extractive for those ones, they sort of tend to replicate the legal terms.
Nice. Any other question in the room? Not yet. Catalan, do you have any question online?
I haven't seen any so far, but are there any questions?
I can have a question for Jan. Okay, so Jan, you discussed about exploiting document structure for summarization. And I think you show us how different structure formats can be used, since the structure is not straightforward across documents. So can you share with us a bit more about how these different formats of structure you used affected the results?
Sorry, could you mind repeat the last part? What's the
Yeah, so
question?
I think you use different kind of formats for structure because you don't have a standard structure across all documents. So can you say to us how this characteristic affected the results by using different formats of structures?
I think the main result I reported is on the kind of automatic, like from the automatic metrics, like how the difference is performed. But later we have some evaluation on the coverage of the different, like from the argument perspective, like how many of those like argumentative labeled sentences being selected. So one finding is that comparing to the no one or original structure, the middle side, those kind of reasoning sentences are totally missed from the original structure, while the later proposed topic modeling in fine-grained level can help devising like we focus in different small sections and select the most important sentences, thus improving performance as a whole.
Nice, thanks. And I have a question for Sagar. Sagar, I thought that your approach is really interesting from a technical perspective, and I want to know what kind of use case you have in mind in generating clauses, how this could be useful in contract analysis or contract drafting or whatever. What was the use case you had in mind when you start doing this project?
Sure. So the idea is, so this is like a stepping stone towards contract drafting. So contract, like as we see, it consists of individual set of clauses. So the way this can go forward is like a typical a drafter of a legal contract, let's say a lawyer. So they may just initially, so rather than like drafting new clauses from scratch in a contract, or rather than like trying to pick up related clauses from other places, they are aware of what type of keywords they are looking for in the clause that they want to generate.
Nice, thanks, Sagar. So I think we're a bit late.
Last question.
I think we lost Sagar.
They can take it offline. Yes.
Sorry, I'm having a bit of a unstable connection. I'll switch off my video for bandwidth issues.
Sure.
So what I was saying is like the user of a legal contract may just specify a specific set of keywords and then generate a preliminary clause, and then like the whole idea lies in them controlling the content of the clause through keywords.
Okay, perfect. So we can keep the rest of the questions afterwards, and we will move to the next session. Nikos will chair.
Okay, thanks, Ilias. Right, so this is, well, one before the last session, the last session of papers. And yeah, I'm really excited because we have a great set of papers in this track. So the first presentation is by Sin Nordqvist, Adam Myers from New York University on breadth alone, improving the precision of terminology extraction systems on patent corpora. Is it the online presentation? Or?
I think so, yes, it is.
Yeah, it's on. Just a second, let me.
Say your screen, the slides, that would be great.
Yeah.
One moment.
Sean works for Bloomberg now. We're very happy.
Okay, sorry, it's making me restart. I didn't realize I was going to do this. I'll be right back.
No worries.
It's the Zoom privacy policies.
That's right.
Not something that can be investigated with NLP, but still interesting.
Okay, perfect. We can see
perfect.
it.
Yeah, we
Yep.
can see that now. Yeah.
Go ahead, Sean.
Excellent. Thank you. Sorry. Okay. Yeah, I'm Sean Nordqvist. I'm presenting virtually from New York. Thanks for the opportunity to present. I'm going to be presenting our paper on improving the precision of terminology extraction systems on patent corpora. So I'm going to get started by first giving a brief overview of the task and the motivation behind the research. So automatic terminology extraction, or ATE, is the process by which specialized domain-specific words and phrases are extracted from a set of documents. ATE systems can be used for creating domain glossaries, improving the readability of legal documents, among their other uses. We focus on a type of ATE methods known as hybrid in this paper. Hybrid methods generally use linguistic rules to extract nominal expressions from the text and then use statistics calculated from word frequency to rank those expressions. So an important component of many hybrid systems is the use of a foreground corpus from which words are to be extracted, along with a second background corpus that serves as a baseline for word frequency and co-occurrence. So intuitively, if a word appears in many documents in the foreground, but infrequently in the background, we may have found a domain-specific term. Some hybrid systems use a single general background corpus for all foreground corpora, and some encourage the user to choose a background corpus for their specific use case. The background we choose will affect how the word frequencies and the statistics used to rank the term candidates. So if we change the breadth of the background corpus, we'll naturally also see the frequency of the words change. So the question then remains, how will this change affect the terminology that we extract? So we want to vary the breadth of a patent corpus, but we have to figure out how we can vary that breadth. So we created a methodology leveraging a source of found data in the cooperative patent classification scheme, which classifies all of patents. The scheme defines a hierarchy of subject areas with the patents at the leaves. So this allows us to create the corpora of variable breadth. So for example, say we have a foreground corpus that consisted of patents in a particular group. In this case, we're looking at the ones highlighted in red here. We can, first of all, sample that and create a foreground corpus. Then we can move back one level in the hierarchy and sample from that to create a slightly wider background corpus and progressively get wider and wider until we're sampling from the pool of all patents. This allows us to create 4 patent-based background corpora. And we also, for the purpose of our experiments, created a 5th background corpus that consisted of a sample of all patents, as well as a couple of, or not a couple, quite a few documents from the Open American National Corpus, which includes excerpts from books and news articles. And we refer to this one as OANC+. With the 5 background corpora of variable breadths for each of the foreground corpora that we're testing, we use the high-performing hybrid system, the Termulator, to conduct the experiments. The Termulator uses the same statistical ranking methods used by hybrid methods that use the foreground background strategy and exploits the same kind of assumption that we described earlier. So we believe it's a representative system. So the table we're now looking at is the precision scores obtained from the 5 separate background corpora on each foreground corpus. So our analysis reveals there's not any set distance at which all background corpora can be placed optimally when extracting terminology from patent foregrounds. In fact, it appears the optimal choice is dependent on the specific foreground corpus that we're choosing. So at this point, the background corpus seems to be a parameter that we need to tune for when we're extracting terms. Our results also suggest that it's important to choose a background corpus that's composed of the same types of documents as our foreground corpus. So for instance, the reason we say this is because the OANC+ background corpus performed the worst in all the cases. So what this means in general is if one were running a AT system on, say, a set of legal contracts or something like that, using news articles as a background corpus would likely not result in the best precision. Rather, one would prefer to use a set of documents that may share characteristics. We also did a preliminary investigation to recall. We did this by sampling a small set of documents from the foreground and annotating them. Recall, however, remains elusive just because of the size of the foreground corpora we use, which is 5,000 documents wide. So getting a representative sample from the foreground is difficult. We also found runs using the OANC+ background tended to rank less specialized terms higher, and that's what we're showing at the bottom here. So the types of words extracted were also affected. So to sum up, we proposed a methodology that allows us to adjust the relative breadth of the foreground and background corpora in patent documents by taking advantage of the CPC scheme. Our results indicate that the choice of background corpus does have a significant effect on the precision of the output of an ATE system. In this analysis, we were unable to find any sort of best choice for all patent classes. We found for all 3 groups, neither the narrowest nor the broadest background corpus achieved the best precision, but it was always a background corpus that consisted of all patents. For future of work, we want to address some limitations. Namely, we believe that taking a better look at recall and how the best cutoff changes as background corpora change is important. And we also want to take a look at other document types that are less ideally suited. Patents have an inbuilt hierarchy. Many other document types don't have such a good hierarchy. All right, thank you.
Thanks a lot, Son. Right, so the second paper is the legal argument reasoning task in civil procedure. Do we have here any of Leonard, Lena, or Ivan?
Yes, that's me.
All right. Okay. Lena, please go ahead when you are ready.
Yes. Okay, so hi everyone. My name is Lena, and I'll introduce our new and fresh legal text corpus to you. And by our, I mean the work of Leonard, Ivan, and me from the Trustworthy Human Language Technologies group at the Technical University of Darmstadt. So let's get started. First of all, what our dataset is based on is the Xenon Guide to Civil Procedure by Joseph Klenner, which is a student textbook containing multiple choice questions. It is supposed to teach law students civil procedure, and it includes a textual explanation for each of the questions. So to give you a better idea of what the inside of the book actually looks like, this is a shortened excerpt taken from the second chapter, but in general, the whole book follows this structure. There is a topic for each subsection of a chapter, which is briefly introduced at first, and each question presents an application scenario and defines the problem that has to be answered. The answer choices, in this case A, B, C, and D, are labeled, and sometimes they are standalone sentences, sometimes they are completing the previous question in close form. And the analysis at the end goes for each of the possible answers and explains why it applies, or more importantly, why it doesn't apply. We pass this form into a dataset consisting of 918 answers, each of them accompanied by the question, the introduction, and so on. So now that we have a fresh data set, it is time to establish some baselines. To us, a good way to test the data and to see how difficult it really is was to try using it in a traditional question answering setup. For this, we used VanillaBERT and LegalBERT to see how well these questions can be answered with just a given context alone. So obviously, we did not pass the previously parsed analysis because that contains the actual answer in textual form, and that wouldn't make a lot of sense. So, and the text in the dataset can be rather lengthy, so we decided to also apply two of the sliding window methods to take the whole content into account and also avoid the BERT token limit. And since in this case, we are actually treating each question answer pair as a data point, the setup can be considered an entailment task. And these are the results. They are actually not very surprising. As expected, the random baseline performs with around 50% accuracy and F1 score, and the majority baseline, which is in this case, all answers are considered to be incorrect, achieves a similar F1 score but a higher accuracy. What's interesting is that only the fine-tuned version of LegalBERT is able to achieve a performance that we can consider better than randomly guessing. And we can definitely see profit from fine-tuning on the task. And also the sliding window methods we use did make a difference on the fine-tuned model. So taking the whole content into account is very important. But overall, the performance as expected is pretty underwhelming. So we decided to take a closer look at what was actually happening inside the models. And to do this, we have taken our best model and used Captum, which is an open source library for interpretability in PyTorch. And we specifically picked a question which LegalBERT, our best model in this case, always labeled as true. So each of the possible answers was labeled as true, even though only one of the answers is correct. And what you can see here is the answer that is in fact correct. And the slightly red highlighting indicates the evidence for the negative class, and the green highlights support the positive class. So what you can guess from the words that are highlighted, the analysis through Captum looks quite similar for all of the possible answers, so there's not a lot of difference to be seen. And what we deduced from this is that there are no linguistic clues which the LegalBERT model picks up. And in fact, you could even say that the actual answer to the question cannot be found neither within the LegalBERT model nor within the introductory text that we passed. So one thing we did not use in our experiments with LegalBERT and BERT was the analysis. We've only taken into account the introduction, the question, and the answer. But the most distinguishing aspect of the dataset is actually the analysis, because having an expert tell you why each answer is correct or even incorrect is very valuable. And this is also a method a student would use to study, and what made us title the work the Legal Argument Reasoning Task, because it contains the important part about answering legal questions, which is the reasoning. So that's it. Thank you very much. If you're interested in the dataset, I hope you found some new ideas or methods you would like to test on it. You can request it. We have been given permission by the author and the publisher to share it, so feel free to contact us. Well, thank you very much.
Thanks a lot for the great presentation, Lena. So now we're moving to the next presentation. The paper is called Legal and Political Stance Detection of Scottish Language. Do we have any of the authors here? Noah, Emily, or Kathleen? If we don't have any of the presenters here, we can move to the next paper, which is called Can AMR Assist Legal and Logical Reasoning? And here we have a long list of authors. Do we have any of the authors here, or are they online?
Yes, I'm online.
Okay. Hi, Nikolaos.
Nikolaos,
How are
yes.
you?
Very
You can
good,
share
thanks.
your screen.
Okay.
Perfect. We can see your slides.
Okay.
Ready when you are.
All right. Welcome. My name is Nikolaos Schrak, and I'm going to present our paper called Can AMR Assist Legal and Logical Reasoning? Now, I want to start by first explaining what AMR even is. So the underlying technology that we're using is semantic parsing, which is the process of transforming natural text into a formal meaning representation. And we're using the abstract meaning representation, which represents the meaning of a sentence as a graph. So for example, here we have this sentence, and then this is the representation of the sentence in AMR. And then here as well, we have this linearized text structure, which is an equal representation to the graph. And this is what we're using in this project. All right. So what's the idea and our approach? So understanding the logic and law is a major challenge in legal NLP. And we wanted to see, can AMR help capture logical relationships? First, we did a theoretical analysis where we looked at sentences with logical relationships, and we wanted to see how AMR is representing these logical relationships. And we found that it might help with some logical relationships, but it might not help with others. So the next step was to do some experiments. So we created model architectures that utilize AMR, and then we ran experiments on legal and logical reasoning tasks. So the tasks that we looked at were multiple choice tasks. The first one is case hold, which is a legal reasoning task. And here we have an example. So we're prompted a court decision statement, and then we need to identify the correct holding statement. And where 5 are given, and one of them is correct. And then the second data set that we looked at was logic QA, which is a question answering data set that requires logical reasoning. And yes, you're given a context and a question, and you need to find the correct answer. All right, so one of the main challenges with these that we had was, so we have AMR parser, we have our input, we parse the text, and we have an AMR graph, and then we have this linearized text version, which is the Penman notation. And then how can we use this in combination with a large pre-trained model like BERT or BART or whatever? So we wanted to, since these models are trained on natural text, right? So we wanted to use a model that is trained on AMR graphs. And so we found AMR BART, which is based on BART, which is a sequence-to-sequence denoising autoencoder that was further pre-trained on linearized AMR graphs. And for this model, we only used the AMR inputs, and then we did predictions on this. So the next sort of natural step is to combine text and AMR input, so we call it the fusion model. So we have our text input, then we have an AMR parser, we create our AMR graphs, and then we have two large pre-trained models. So for the AMR input, we have AMR BART, where we can then extract the AMR embeddings. And then we have, for our text input, we use a BERT-like model to extract the text embeddings. And then we concatenate them, and then we put them into a multiple choice prediction head. So let's look at the results. For the case hold, for the legal reasoning task, the diffusion model performed similar to baseline models. And then for logic QA, for the logical reasoning task, the AMR model underperformed compared to baselines. So we wanted to know what happens. And so we did some error analysis, and we found that parser quality is a big problem. So when we looked at the parsed AMRs, we saw that some of the examples, entire sentences were missing, which is not a surprise since AMR has a history of being, it's hard for most of the AMR parsers to parse multiple sentences, and most of our input were multiple sentences. And then we also wanted to see if there was a correlation between missing information in AMRs and accuracy, and we were able to show that for the AMR BART model. Now let's look at some discussion. So what could be done to improve the performance of these models? So one thing that's known is that cross-domain AMR parsing is a problem. So if we have our AMR parser that is trained on, let's say, news articles, and then we want to use it for legal documents, it's going to have a hard time processing this. So what could be done, for example, domain-specific pre-training and fine-tuning on in-domain Silva AMRs are a way to improve the AMR parser. And then for the fusion model in particular, so we're using a very simple fusion mechanism. We're using the concatenation, but for example, using a co-attention layer, which allows for embedding level interactions, could be a way to improve the performance. All right, that was it for me. Thank you very much.
Thank you, Nikolaos. That was a very nice presentation. So now let's move to the next paper, which is long NLI, if I have pronounced it correctly, a long premise benchmark for evaluating models on in-domain generalization to long context and implication-based retrieval. William or Dan, is anyone here to present the paper? Online? No? Okay, so it's not bad because we are running late, and we are now moving to the last paper presentation of the day. Legal prompting, teaching a language model to think like a lawyer. Do we have any of the presenters here, Fungi, Lee, or Frank?
Fungi is here, but perhaps
Probably yeah, they didn't expect for us to. Let's give them a couple of minutes, and if they respond, then we can move to the presentation. But I mean, in the meantime, does anyone have any questions from the papers that have been presented already in this session?
Online, Ivan has a question as well. Yes,
if we have online, yeah, Ivan.
Okay, so very quick. Yeah, thank you. So I have a question to Nikolaos, the last paper. So the AMR kind of parsing the issue of the domains is clear. So, but what was your motivation actually to use AMR in the first place? Because you merge it into like another deep learning, another deep network, and why should it work? Why not just using everything just end to end and just more data in the domain and so on? So why AMR should be actually helpful here?
So our idea was that AMR is able to understand the logic of the text better than just simply using the text alone. So sort of having this additional representation of the documents make it easier for the models to identify logical relationships in our documents.
Okay, thanks.
Mm-hmm. Yeah.
And Margin.
Yes, hi, Marijn. It is
Marijn.
This is only for Belgian people who know how to say it. So yeah, I had a question for the paper about legal argument reasoning, because so the models, most of them don't perform very well, and you said that maybe if you use also the analysis part, then the information is in there. But my question is the information, do you expect it to be there in the introduction alone? Because if you look at the example that you gave on the slide, then this introduction doesn't say anything about the reasoning that you have to apply, right? And if the introduction is not enough, maybe there are other resources that you can add to perform the reasoning better without using like the answers given in the analysis. What are your thoughts on this?
Yes, exactly. So the analysis we did was more to prove that there is no clue inside the question itself that could lead to the correct answer. So to establish that this task is actually not that easy, and you would definitely need additional material to get to the right answer, because sometimes the multiple choice data sets from different domains, they have something like artifacts that can lead to the models to learn things you don't want them to learn, like the answer is always A, or the answer tends to be something that has a specific framing or specific formulation inside of it.
Okay, so if it's not in the topic title and introduction or in the question, then how is a model going to do this? What other information can you give it?
Yeah, well, you would probably have to provide it with some context on civil procedure in that case. So you will have to input information that it can gather from different resources about civil procedure, and then test it through the questions.
Okay, and is this feasible? Because I guess civil procedure is like very long.
We haven't actually tested that yet. So we have something in the pipeline which also targets the long form or longer documents, so we can input longer documents. But for now, the analysis we did, the baselines, were just to establish that we cannot answer the questions with just a given context.
Okay, so then how do you explain that the legal BERT does perform 10% better than chance?
Sorry, can you repeat that?
So you showed one model, I think it was legal BERT, that went up to 63% or so. So that learns something, or that gets information from somewhere. And so how do you explain that if the information is not there in the text that you give it?
Yeah, so basically when you think it's like 65%, that looks good. And then you look at the analysis, and then you notice that it hasn't learned anything you can read. But that's also the issue of explainability, I guess. So looking inside the model is not that easy. And when you look inside, you notice that it learns some arbitrary words like because or it, or some artifact words it's not supposed to learn, but I wouldn't say that 65% is enough to be considered solving the task.
Yeah, okay.
Okay, so Mariah, I think you can take it offline, right?
Yeah, sure.
Okay, yeah, no problem. So I have a quick question, and then we can move to the next presentation. Actually, Son, are you there?
Yeah, I'm here.
Perfect.
Sean.
Okay, cool. Yep. Right. So your work is based in primarily in English, right? And your method. So do you have any plans to check the generalizability of your approaches in other languages?
I wouldn't, no plans, but Terminator does. There's work with Terminator, the system that we were working with, in other languages. So I think that is something that we could try. I would have to look into we would have to find, kind of a similar hierarchy in another language, if that exists. And
that one with Wikipedia.
Okay, yeah.
Because we were able to use the Wikipedia's hierarchy of topics in a similar way.
Yeah, I think that's really interesting, because then you can check, for example, how difficult or how easy it is to apply your method in different languages. So I think, yeah, that's something that,
I mean, currently we have some abilities in Chinese and French.
Cool. Thanks, Adam. Thanks, Son. Okay, so now let's move to the final presentation. Fangi, are you there?
Yeah, I'm here.
Perfect. If you can share your screen.
Yeah, let me share my screen.
Yeah, we can see your screen. You can go in presentation.
Okay, great.
Perfect. Yeah, you can start. Thanks.
Okay. Hello, everyone. My name is Fanyi Yu, and I'm from Thomson Reuters Labs. Today, I'm going to present our paper, Legal Prompting, Teaching a Language Model to Think Like a Lawyer. And this is a paper, this is a collaborative work with Lee Quote and Frank Schroeder, both from Thomson Reuters. So the motivation of our work is that the Japanese bar exam is one of the most difficult bar exams in the world, with a passing rate between 20% to 40%, and passing it requires legal reasoning capabilities. And recent advances in the NLP domain showed that various techniques such as stream of thought prompting and few-shot learning on large language models can improve arithmetic and common sense reasoning performance significantly. So we want to explore how such approaches fare with legal reasoning tasks. And we take the Coley entailment task based on the Japanese bar exam for testing various state-of-the-art techniques on GPT-3. And we are using the Text DaVinci 002 model from OpenAI, which has 175 billion parameters. And the data we're using is the statute law competition data corpus from the University of Alberta's annual competition on the legal information and extraction entailment task, which is known for the Coley competition. And we're using the data from 2021 and 2022. So the input of our GPT-3 model is a set of hypothesis premise pairs, where the hypothesis is drawn from the Japanese bar exam, and the premise is a set of articles that are relevant to the hypothesis drawn from the Japanese civil law. And you can see an example from the right-hand side of the screen, where the sentence between T2 is the hypothesis, and the articles between T1 is the premise, and the label is Y, which means the hypothesis is true based on the given articles. And the data sets are balanced, so we use accuracy as our metric. We tried different approaches on GPT-3, including zero-shot, few-shot, train of thought prompting, which is an approach proposed by Kojima et al. In their large language models, a zero-shot reasoners paper. We also tried fine-tuning with and without explanations, which was inspired by a bootstrapping method proposed by Zilikma et al. And we also tried different prompt engineering approaches and proposed our own approach. We call it legal reasoning prompting, which means prompt GPT-3 to think like a lawyer by asking it to follow some legal reasoning approaches, such as IRAC, which means issue, rule, application, conclusion. And these legal reasoning approaches are approaches that legal professionals, such as law school students and lawyers, they usually use when they do legal reasoning. And the baseline accuracy we're using are from the winning teams at the Coley competition, and you can see the numbers on the slide as well. So you can find the experimental results on the bar chart, where in the x-axis shows the all the approaches that we applied on GPT-3, as well as Coley winners' performance, and the y-axis is the accuracy. So you can find that all techniques applied to GPT-3 surpass Coley winners, except for just one approach, which is the fine-tuning approach on only the binary answers in 2022. And legal reasoning prompting provides surprisingly high accuracy in 2021, but it is not so consistent across the 2 years. And few-shot and fine-tuning with pseudo-explanation perform the most consistent across the 2 years. Oh, sorry. And in conclusion, we tested multiple state-of-the-art techniques on GPT-3 to solve a legal entailment task that requires legal reasoning capabilities and also very hard and challenging to humans. So for Coley 2021 dataset, the most significant improvements in accuracy come from prompting GPT-3 with legal reasoning approaches under the zero-shot setting, which surpasses baseline by 15.79%. For Coley 2022 dataset, the most capable approach is few-shot. Specifically, when we used 8 demonstrations drawn from a bar exam preparation website. And our analysis shows significant promise in prompt engineering for high-order large language model-based reasoning tasks. And please read our paper for more information, Legal Prompting, Teaching a Language Model to Think Like a Lawyer. Thank you.
Thanks a lot, Fangi, for the interesting presentation. And well, that was the last presentation of the day. Then we're going to move into the panel. But before we do that, we have time for a couple of questions. Any questions here or online? Yep.
Thank you. I'm curious whether you have checked the possible data contamination about between a pre-training data set and a test set. I'm asking because there's a big difference between the result accuracy between result from 2021 data set and 2022 data set. So I'm just curious about the possible contamination.
So yeah, there are big difference between the two data sets. First of all, the data size is different, and also the topics covered in each test set is also different. So that's why you can see the model's performance is quite different across the 2 years. But we also want to experiment if there is one or multiple approaches that can perform consistently across different data sets. That's something that we want to continue experimenting on. Yeah. Thank you.
Cool. All right. So we are perfectly on time now. Thanks a lot, Fangi. So we can move to the panel session.
Why don't people come up here, actually, panelists? Yeah, it's easier. I'm just going to move my. Yeah, and I'll stand over here.
Yeah. So you can be here, camera.
Let's pull another chair over. We grab another chair.
Right? We are four. We need 2 more chairs. Can you squeeze?
No,
Just put them here. So, or maybe let them here because we have 3 microphones.
Then we are before here. So maybe that's fine. I can move it here. Yes, you guys will use that microphone. I'm going to speak from over here. Catalina, you can hear us. Everything's good.
Yes, and Matthias is also here. Wonderful.
Everything working well. Thank you.
Splendid. Okay, we're getting everybody. We've managed to arrange furniture, so it's
great. And actually, the camera angle is much better because now we're not staring at that plant.
Yeah, it's better, huh?
So, but it was very nice guessing voices in the room, you know.
Okay, panelists, take your seats. This is going to be fun. And then we have best presentation award after this, so don't go away.
I should load some kind of some drums noises, you know, just to make it more exciting.
Yeah. Or the person that is. Oh God. It's okay.
So I should not put it too close, then it's too loud, right?
Yeah. Well, you guys have 2 options. You could use either one.
Fine, right?
Yeah.
Is it? Can they all hear us?
Yeah, we can hear you online.
I think we're good.
Okay.
I think you could. That microphone seems to work. Okay, Catalina, you want to get us started?
Yes, absolutely. So I know it has been really a marathon of presentations today, which have been absolutely fantastic. And it's exciting to see just so much progress also in this space of law and NLP, which is why we also thought that perhaps it would be good to have an open conversation about what has been happening in this space and also what is the future of this space. So together with Leslie, what we're going to do is moderate a panel where we have 5 really fantastic guests. And this is a panel that we managed to organize with the support of the European Research Council grant on human ads. So this is it's a project also that looks at social media and NLP in regulatory settings beyond legal texts, which also gave the idea for the topic of the panel. So let me just very briefly introduce you to the wonderful members on this panel. So we have Joseph Valvoda, who's there in Abu Dhabi. Hello, and he is a PhD student at the University of Cambridge Computer Laboratory, and he focuses on legal argumentation in his work, and he studies how law and its actors use legal precedent. Then next to Joseph, we have Jerry Spanakis, my former colleague from the University of Maastricht. Jerry is an assistant professor, combining appointments at a law department at the Maastricht Law and Tech Lab, as well as his initial appointment at the Department of Advanced Computing Sciences at Maastricht University. Then we have one of the two legal members of this panel, Friederike Zufall, who is a senior research fellow at the Max Planck Institute for Research on Collective Goods. And apart from the fact that she works on hate speech, as we have seen in her wonderful presentation earlier today, she also specializes in data protection law, but also, most importantly, and I am going to say this specifically for Jerry, comparative law, because I've been trying to brainwash Jerry with comparative law in the past years. Then we also have with us our keynote speaker from earlier today. We have Michael Livermore, and in his own words, we have already heard very much just not just of him, but also from him. But in his own words, he's a legal academic who focuses on regulatory review and also areas of law such as environmental law, but also cost-benefit analyses and the application of data science techniques to legal texts. So we're going to build on a lot of the fantastic ideas that he put forth in the keynote and hear more from him in the panel. And last but definitely not least, we have online, just like myself, Matthias Grabmeier, who is also a fantastic researcher with a very interdisciplinary profile. He holds a position at the Technical University of Munich, an assistant professorship, and also combines that with a position of an adjunct professor at Carnegie Mellon University's Language Technologies Institute. And with this introduction, I would like to pass the floor to Leslie for the first questions. What we're going to do is just start having some questions for each of you, and then we will have some general questions and also hope that the audience will chime in with some points. Leslie.
Right. So thank you for the introduction. So now the first question is going to be somewhat ambiguous between applying to NLP versus applying to law. And that is, what do you feel that the biggest achievements have been in the legal NLP area recently? What are some of our biggest gains? What have we brought to the field, either field?
Shall we fight for it?
Yeah, we'll have to pick somebody if you don't jump in. Go ahead.
I mean, if I just start, I think one success already would be that there is a workshop, right?
Could you pick up the mic?
Yeah, I'll try. Yeah, is it that better? Okay, cool. Yeah, one of the big successes is that, you know, there is a workshop, right, with an increasingly number of submitting papers, so there is much more interest from the community. So I would say that is a success on its own, that there is a wide range of people working on topics on legal tech. On the other hand, I think we shouldn't forget that there is also practically taking techniques from the, let's say, mainstream NLP, like BERT. We have legal-BERT and other models that are being applied, and they are successful to the legal domain. Plus, I would add also, you know, the works like Friederike is doing, where we also think a bit the field from a different perspective and try to identify, okay, what is more, let's say, than legal text. So more than analyzing legal text. So I think all this show where we're going, what we have done, what we're going. I'm going to leave it there for starters. If anybody wants to add.
Maybe just to add a little bit to that. So I'm thinking in the US context, I would maybe say kind of two broad areas. One is kind of in the scholarly domain. There's a pretty vibrant field of empirical legal studies in the US. It also exists elsewhere, but you know, there are hundreds of scholars working in that area. We just actually held a conference, the annual Conference on Empirical Legal Studies at the University of Virginia. And a considerable number of papers involve some kind of text analysis, some kind of computational text analysis, using, maybe some more traditional tools, topic modeling, other forms of text analysis, but that's all NLP. So I think the kind of mainstreaming of NLP techniques within legal scholarship has become more, has kind of increased over the years. It's common to see in the major journals papers that employ some kind of NLP technique. So I think the field's really grown a lot, and to the point where it's become embedded in a lot of legal scholarship. And then also just commercially, there's just tons of NLP techniques that are embedded really deeply in, search and the commercial databases and how they kind of present themselves to the world. Again, is it, does it have to be a language? I mean, it's some kind of language model. It's not necessarily a transformer model, but there's all kinds of NLP techniques that are embedded in these kind of commercial operations that just make lawyers' lives easier. So I think those are two big successes in the field.
I'm going to ask a follow-on question, actually, if it's okay with my colleagues, and that is there any part of NLP currently that worries any of you? There's been some controversy over some of the things that AI is doing in the legal space, particularly in Europe. There have been some legal concerns about what AI can do, what AI predictions applied to law can do. Do any of you have any comments on that? Do you want to say that?
I can start the discussion and pass the baton. Yeah, I think that while we have a lot of attention, I'm not sure that if we've progressed on the mission, or if we even formulated it correctly. We have applied NLP to law, and that has happened thanks to development of great data sets and tasks that we've seen made a lot of progress. But the question is whether we've achieved anything meaningfully good in terms of, I don't know, providing access to law, let's say, or one of these more grander ideas. And I think that comes back to this question of what kind of hills do we want to climb, and what are we trying to achieve, where it is not clear to me if there is a consensus of what are we trying to do. Some people do want to automate, as far as automate judiciary, and others would oppose that vehemently. So I think it just points to a schism in the field. And this is perhaps the perfect place to discuss what should be the resolution, or if there is any.
Yeah, I take this microphone. That's okay. Sorry. Yeah, just when you asked the question, I thought you were referring to explainability as a huge discussion. Well, that's part of it, isn't it? Right. Really, I mean, that's a huge area of NLP itself, but it's also very relevant to NLP and law. So yes, absolutely, and a huge question for AI in general and automated decision making. So what we tried to address with our research was are there any alternatives for these end-to-end holistic approaches? I mean, we have seen a lot of interesting research that try to predict judgments. There's a lot of that, but I think the future might be, or the next steps can be to complement this with reasoning structures. That's a little bit what Michael said earlier in his talk that reminded me a lot. You had this model of law as data and law as code and hybrid. And I think we need to merge these two. And while discussing with lawyers, I see there are a lot of experimental approaches from computer science side. But from the legal side, I think it's also important that we try to conceptualize, try to build theories on how these automated decision-making systems need to look like in terms of design, in terms of legal requirements, how they could be applied in practice. Could they be applied? What are not just legal requirements, but also the technical design requirements? And there are so many questions that are not yet answered. So and I think part of the answer will be to go beyond holistic prediction, but also I think the answer cannot be that we say we don't use this technology. So
I think Matthias also had something to add, and then we can come back to Mike.
Okay.
Thank you very much. I wholeheartedly agree with what everybody has said so far. And I'd like to sort of address the two questions that Leslie posed in combination. So one, I think the aggregate achievement of this community, and by this I include the AI and law community where I'm from, so to say, would be that we have sort of put the burden on the legal profession to understand that data-driven technology is here to stay, automation is here to stay, and that it is in order for this to be, and it's not going away, and in order for this to become productive and move beyond this, provocatively speaking, very data availability driven research that's been going on so far, that, as Friederike just said, we need to lift the dialogue to a greater level. We need to be able to talk to lawyers and use more refined concept, just as we're using machine learning or we're using transformers or something. We need to lift the dialogue at a higher level with the experts. But I think that the community has, and the field has come a long way so far, which I consider an achievement.
Great. And Mike, you wanted to add something as well.
Yeah, just a kind of little short thing is, you know, on the kind of automation question, which I think of as quite distinct from NLP and law. I mean, these are kind of related, but overlapping. But I think it's important for us not to overestimate the quality of human decision making, or the quality of explanation that we get out of judges. I think that human judges think they deliver high quality results, but we can evaluate that, and so that the baseline of you know, explanation and reasoning and outputs that we get from the current system is what it is, and it's far from perfect. And so technology can certainly help us, and including things like access and democratization. So it's a pretty bad baseline. How can we use technology to improve on that? So I think that those are the questions that we should be asking ourselves. You know, where are the opportunities? And of course, there's always going to be risks and threats involved, but I think we shouldn't. And this group is certainly not going to be inclined to, but I think more broadly, society should be wary of overemphasizing the threats and the risks and underemphasizing the opportunities.
That's a great point. Yes.
Just a quickly remark. I think, I wholeheartedly agree to what you both said. And I think first, it's true that if we think of the benefits of these automated decision systems, it's true that on one side, I think we should look at, we might get something in terms of reliability. There are lots of dangers, of course, biases, a lot of things that we need to take care of. But in comparison, in certain situations, in comparison to human decisions, maybe there's also a place for these systems. And on the other side, there are a lot of digital phenomena or digital factual situations, that's like in social media, for instance, that are of such a large scale that humans cannot assess them. And if we want the law to have an effect, for instance, online, we have to use automated decision-making systems, at least to a certain degree, to assist human decision makers. Otherwise, we cannot grasp the sheer amount of phenomena that appear digital and will increase.
Leslie, perhaps if I can just build on a question that with some things that I've heard already from the crowd. So Matthias, you're also involved in the legal informatics community, and this is also what Mike was mentioning, that there are different communities. You were also saying, you know, the legal scholars who do more empirical legal studies. So there are quite a lot of groups in this space that have been shaping up for many different years. Do you think that there should be more convergence or more overlap, or what do you think, Matthias, if you have to look at the other conferences that you organize in this space?
Thank you. So for those of you in the audience who are not familiar with these venues, the one prominent area here, I wouldn't be a good program chair of that conference if I weren't advertising it. So the International Conference on AI and Law, which sort of goes hand in hand with the International Journal, Springer AI and Law Journal, and the Jurgs Conference, form sort of the major venues for the AI and law community. ICAL, the big biannual conference, has been around since 1987. So it's been through the AI winter. and it's come out alive, so to say. However, it's slightly different in focus, and this sort of gets to Catalina's question, in that it's a more holistic approach to the use of technology, AI technology in legal practice. So it includes NLP, but it also pre-neural NLP. The traditional approaches that have largely been replaced by now. But it includes rules as code. It includes legal knowledge engineering, type system design, ontologies, computational models of argument, and the like. And there have been contributions in there which we don't have the time to go into right now. Do I need? It will happen next June, by the way, in Braga, in Portugal. The call for papers is out, and I apologize, my daughter's in the background. And we have the paper submission deadline in February. Do I believe that the communities should converge or overlap? The short answer is I don't think they have to converge, because at ICAL we do have a much greater share of legal experts in the room. The basic underlying assumption of ICAL is that legal expertise matters. So as data-driven technologies appeared, the community was in this big debate about, can law be dataified? You know, can a judgment be reduced to a probability and the like? And I think these discussions are important. And so having a more legally focused venue that does not necessarily require technical contributions in order to pass peer review and be interesting to the audience, I think is important. So I think they complement each other. So yes, they should definitely overlap and crossbreed, but they don't have to converge. That would be a deprivation of what's already there. Thank you.
Thank you. And Leslie, if I may just abuse this time for just a little bit longer to ask Mike and Frederica actually something, because you were mentioning, Matthias, that there are more legal scholars involved there. What do you see the role of legal scholarship to be also in natural language processing moving forward? So we saw also a lot of papers that had a very, very proficient technical dimension. What do you think about the potential future of legal NLP in being more contextualized in terms of how exactly we can deploy these technologies in the frameworks that they are designed for?
It's such a broad question. Like I said earlier, we definitely we definitely need to talk to the computer scientists, and I think the interdisciplinary research needs to increase. So I find it today, especially at the poster session, I find it particularly interesting to see the questions that come from the computer scientists that I haven't thought about sometimes, or that I find interesting, and this inspires me then again. So I think, for instance, if you have an idea for a system for automated decision making, you could think about which legal effect should the system have in the future? Is it something that will be used in a court of law? Is it something that is part of administrative regulation that is just suggesting something, just assisting human legal decision making? Do we have legal redress against that system's output? And also regarding the design, there are so many questions, like, for instance, not just about, like, for instance, publishing the data set, or who chooses the data set, which algorithm to use, or the whole design of the system, like what we did using a reasoning structure. And then if you translate, like, legal knowledge into some reasoning structure, and then use that for classified training, who decides whether this correctly represents the law? So it is also a question of a democratic question, because you have the parliament that that has a legitimacy to decide on legal texts that are written, but just translating that into like reasoning systems or machine learning systems, or combination of both, at which point do we go too far away from the parliament and the people that need to give democratic legitimacy to these systems? And is it even possible For yeah, the parliament to understand, like then we come back to explainability. So many questions to think about.
So yeah, so just, thinking about the role of legal scholars here, I think that there's lots of different types of questions and intersections that we can imagine between law and NLP. And so I think it just depends on the nature of the intersection, what if anything, legal scholars can bring to the table. So just kind of a few came up to my mind, to mind. So one is in the domain of using the law as a sandbox or as a data set for trying to develop or get at interesting questions in NLP, right? There are just challenges in natural language processing. If you just, this is a really interesting, rich data set. And now what role is there for legal scholars? Maybe none, but maybe also just explaining the data set, understanding it, being part of a team with NLP group, that someone has some knowledge in the underlying data generating process that can provide insights into that data that can clarify, how it can be used to answer interesting NLP questions. So that would be like one area. Another one is more kind of my domain, is providing a kind of a social science perspective on the law. And the intersection there is really relying on NLP tools to process legal data, to extract information that we then use to address interesting social science-y kind of questions about the law. Like, what are the consequences of legal change, or what are the social factors that drive legal change? And then, we represent the law, legal change in that kind of situation through NLP tools that we can extract out features that we then we study. We can imagine the AI on law, or law as code kind of project. And then, obviously the role of domain experts in helping to construct expert systems or hybrid systems that are, a mix of, a data oriented NLP kind of process with expert, either not just expert labeling, but also kind of expert representation of the law. The role of legal scholars is relatively clear there, because they're the ones that are doing, the extraction or the representation of the law as a formal system that's being integrated into some kind of hybrid system. You can think about the automation prediction kind of tasks that we might want to do. And then legal scholars might have a different role there, maybe thinking about what are the normative implications of these kinds of systems and how do they integrate into, a democratic or a rule of law society, right? So I think it just kind of depends on the domain. But there's like tons and tons of intersections. I think the question is, the challenge is getting legal scholars engaged in these debates at a sufficient level. I think it has happened, but it can happen more. And the mixture of expertise is really something that's pretty unusual. You don't have a lot of legal scholars who are engaged with the technical side of things. And a lot of folks are intimidated by this work. So I think overcoming those challenges is something that we can look forward to.
Great, thank you. I'm going to change tacks a little bit. Joseph, we're going to start with a question for you, and that is,
does Matthias have a question?
I'm sorry, did I leave you out?
If I may just add something, a little thing.
Of course, I'm sorry. Go ahead.
No, everything's fine. Thank you, Michael, for what you just said, which reminds me of one thing that I think we should keep in mind is that legal modeling is difficult. Modeling legal knowledge in ontologies and rule-based systems is difficult, and it not only entails this challenge of having to derive sort of definite, unambiguous models of the law, which is sort of its own challenge. But if you do it at scale, you run into the whole spectrum of knowledge representation of how do I do this? Do I use Prolog? Do I use ontology languages? Do I use whatever? So, and this research has sort of seen its peak attention in the early to end 2000s. And it has almost been dormant since then, and is now gradually coming up in the sort of no-code, low-code startup space. So one thing, if I may sort of express a desire or a wish of the community, would be that we would appreciate legally complex but non-machine learning papers more. So because contributions can lie in ways that law is modeled, and so there are contributions can be made in ways by taking a very complex piece of law and making it computable and making it sort of breaking it down into concepts that can be interfaced with NLP or things like or machine learning. That's a challenge in and of itself, and I wish that this would be appreciated by peer review in the respective venues a tad more than just sort of technically sophisticated data work that may solve problems lawyers don't necessarily have. Thank you.
Great. Okay, so the next question that we want to talk about is what obstacles are there, if any, to making legal NLP truly interdisciplinary, folding in, say, ethics and other areas like that? And is that even desirable, I guess, is the question.
Yeah, good question. Well, I mean, education is the answer. It's very hard to learn both, at least for me it was. I did undergrad in law and then switched to computer science. And it's not entirely easy, definitely in Europe. I imagine in the US it might be a bit easier with the structure of the education, but yeah, the interdisciplinary education is hard. So that aspect is difficult. Whether it's desirable or it's possible or not, so it's possible, it's not even just desirable, it's necessary in order for the fields to progress. NLP needs fields to go into, and humanities and social sciences need technology to refresh the research that we are feeding off each other, like a chimera almost. So it is unavoidable, I think. But to me, the question I think that stands is who's going to form the law in the future? Is there a space effectively for what is now the legal scholarship as it stands? This idea that it will affect the development of law, whether that will still exist and its importance now when, let's say, the lawyers and the judges will increasingly rely on some intelligent technology to aid them in decision. Will the burden now shift from the carefully thought out legal works of legal scholarship that are supposed to influence these people, or is it going to be based on the biases in the algorithms we are using to crunch massive amounts of data? And I think that's where the necessity for the double qualification comes in. I don't think it's a question of finding a bias-free law representation either. It's clearly a question of which way we want to direct these biases. I don't think that there is a bias-free law. Yeah.
Can I add something to it? As a person maybe working with lawyers for some years now, I think the field should be interdisciplinary by definition, which means that we should get also out of our silos by also producing maybe just our usual machine learning papers that we perform our nicely done experiments, because we need to publish in our venues as well. So I get that. And it's not easy, right? Because I don't think necessarily we need double degrees. That's, of course, desirable. And I think I have big respect for anybody who does it. But then we need to be able to learn how to talk to each other, right? As a lawyer to computer scientist, make an effort, right? Which is not easy, right? We need, as computer scientists, to understand a bit how the law works. I keep asking questions. I think Katalina mentioned already that I was fascinated when I discovered what comparative law is. And learn to respect each other's limits in a way that, of course, I'm not going to be a full lawyer if I learn something about the law. And at the same time, lawyers won't understand fully, okay, what exactly are we doing behind our Jupyter notebooks and everything. Yeah, and I promised I'll share funny stories, maybe over drinks, about how it is to work together with lawyers, right? It's like an anecdote that let's write a paper together, and then the lawyer opens a Word document and starts putting footnotes everywhere. And then we open a LaTeX file and we just add references in the file. So there are all these funny stories, but you eventually overcome them just because you need to work together in what should be like a field which works in two domains, right? So, and maybe traditionally, maybe it's been like just computer scientists working on the law just because it was, maybe the traditional legal NLP was, let's take legal documents and treat them as any other documents and apply our models. But that is changing because it's becoming more like what is technology for law for technology in a way, with all the new advancements, social media, how the law is going to be applied. And there, I'm pretty sure that as computer scientists have no idea what kind of legal frameworks will be applied, but this can be provided to us. And that we can say from our perspective that, no, that's not computable. And this is the interplay which we need to push forward.
If I may just build on this point, Jerry, because perhaps what you can do is share a little bit with us some of your work in the regulatory space, because so Frederica, you were also mentioning the Digital Services Act. So there's this very big regulation which has already entered into force in the European Union, and for instance, which actually mandates access to research data from very large online companies, basically from very large online platforms, and then that it creates this need for the automation of regulatory compliance, which can lead to a completely new universe of NLP tasks in the legal domain, but not necessarily focusing them on the text of the law, but on legal fields where there might be some issues. For instance, I think Jerry was working on product safety. So would you like to perhaps elaborate a little bit on that? And I don't know, Frederica, if you have some input from the perspective of hate speech as well.
Yeah, yeah, as I said before, right, I mean, one big direction which I think we've made much progress, and many of the papers we're about today was exactly just looking the legal text and try to answer some very interesting questions on it. But on the other hand, with all the new technologies popping up, we have like hate speech frameworks where actually we're not about analyzing legal text, at least that's the first level, but it's about, yeah, just finding which law should be applicable and how it should apply to social media. That's one example. With product safety, what's the idea there in a nutshell is that the European Commission, among other things, they do have a specific list, and they curate it actually of products, non-food items, that they are dangerous. And that list is online, it's available to everybody. And actually it's very detailed. So you can find there from, I don't know, dangerous ovens that might just start exploding to hoodies that are dangerous because they might cause asphyxiation. And of course, talking to a lawyer, this is how this project came into life, is that, yeah, they told us practically that once something makes it to that list, it's kind of too late because much harm has already been done, because it means that, yeah, some oven somewhere exploded, then that was reported to the relevant country authority. They made the report, they made everything fine, that made it to the website, and then that's there. So it's kind of already too late when it's mixed there. So the question was, with all this information people are posting on social media, and maybe you all know it already, that when you buy something which is, not satisfactory, you're just going to post a bad review, right? So the question was, can we use online reviews that we all post with so much passion in order to proactively detect potentially hazardous items, right, before they make it to that list? And there, of course, the question was, okay, let's get reviews. We have so much data. But then the legal question that came into play, which was the interesting thing to answer, and I think it's very interesting for this community to start thinking about, is that, okay, how do I label this? How do I label a hazardous review? And what does that mean from, I would say, a product perspective, right, when a product is hazardous, but also from a legal perspective, when it's supposed to cause damages and other legal terms that I'm not familiar with. But that shows also like the depth of the work we have to do in the future. If I may add to that, and then I'll leave it there because I think I spoke a lot, is that also we have like social media as well. Another example would be the non-disclosed advertising, right? Advertising in the past was very much easily regulated. We had TVs and there was screen time. Now on social media, anything can be advertising. If I start showing you whatever I'm wearing now and say I'm feeling very happy here in Abu Dhabi wearing my fancy brand t-shirt, I might or might not be sponsored, right? So this is another example of, you know, interesting tasks we can build as a community and work together as, you know, lawyers and NLPers, and then have also, and here about something that Joseph said, have some, you know, impact, right? Because we're going to be eventually protecting consumers. So there is the impact that we want to have or could have as a community.
Yeah, one thing that just came to my mind was like maybe from a legal theory point of view, we have to distinguish these cases like how can we model or look at the facts, at the reality that we want to apply the law to, like the normative dimension. And the like NLP work that has been done on, for instance, like judgment prediction has in the text of the judgment, the section with the facts. So you have like the facts already represented in text. So this is a helpful task, very interesting. But it's another, from a legal theory point of view, it's another thing to look at, for instance, social media posts or product safety, because then this is actually what the facts are in the reality that you can look at through more and more data that will be available in the future. And the question is, how can I get the normative information into that? How can I select what is important from legal point of view? And also what we did with annotation to apply the law to the factual dimension. And so this is also there are different methods in common law and in continental law. This makes it even more complicated, but also very interesting. I think the task will be to distinguish these cases or build more on these phenomenon from a legal theory point of view, and to see what is actually digital and how to maybe it's not always NLP but also other techniques that help. Maybe there's information that is there explicit or that can be manually entered into systems. So it depends.
Yeah, that's a great point. I think it brings to my mind anyway Mike's second half of your talk, which is the data dilemma that's raised by, as an NLP person, you might apply, a great model to publish opinions, and well, you don't even realize you're telling half the story or telling the story completely wrong. All that matters to me is how well my model is doing. That's great. I beat Soda on this data set. Oh, it's great. I can get published. But if I didn't consult with somebody who really knows the law, then it's not going to be very meaningful, is it? So. Great. Catalina, I'm going to throw it over to you for the next question.
So we had two questions here in the chat as well, but Tumant, I think, has left. However, Ivan is still here. So Ivan, may I kindly invite you to actually ask your question yourself, because it sounds like a loaded question and I really want to hear you mention more things about it.
Well, it is actually, I mean, the question is like, so you're talking, so Joseph and other people are talking about the education, and, we should be more interdisciplinary and learn from each other, and in order to understand each other, which I really support, and I wanted to do this, so I wanted to pick up some law, and and I had really hard time to actually find something where I kind of take it over the weekend and learn something about law because of some barriers. So I couldn't find like blogs or videos, something that explains law in an easy way to somebody who has no idea about it, and everything is like behind some barrier. So I'm wondering, I mean, is there anything in the area at all, or I just couldn't find it.
Joseph, do you want to, because you mentioned the education, do you want to maybe tackle that? And then perhaps Ilias can also mention an initiative that we should revive with doing more law NLP talks. Yeah, Joseph?
Yeah, Ivan, it's a hard question. I will answer in a convoluted way by suggesting we should maybe work on what we are good as community as well, which is to find, well, to identify what's unique about law in particular. We a lot of the discussions that we are having are echoes of what NLP discusses in general. Perhaps if we kind of a rule of thumb of what could be a very interesting way of focusing on where our strength in legal NLP would be to look at the parts which are not that often discussed within the general NLP context. And I think that's quite hard to disentangle. I'm not entirely sure, in fact, that there is a meaningful difference between the question of sort of NLP and legal NLP on a meaningful level in terms of anything else but application. So yeah, I'm open.
Yeah, just what, so I took the question to be in part just, are there resources to quickly get up to speed on the law, and some frustration that there were not such resources? Is that a fair?
Sort of, yeah, kind of like
So,
law 101, you know, for computer scientists.
Right, which I definitely appreciate, and I can imagine some possible resources like this, but here's an analogy that I think might help explain why it's difficult. So imagine if what we were doing here, instead of legal NLP, we were doing moral ethical NLP, right? So what we were doing is trying to apply NLP tools to the history of moral ethical thought, which there's texts that do that, right? There's you could apply NLP to philosophical texts and to religious texts or whatever, and then you could extract information. And it would be interesting to do that, actually, right? Maybe you could come up with tasks, and you could extract topics, or do lots of different things. Maybe you could train a model to spit out moral, like, responses to moral queries, right? So you could do that. It might make sense to then say, okay, well, maybe we should know something about moral and ethical reasoning if we're going to build models like that, because we don't want to be, creating a model that tells people like terrible moral advice or something like that, right? And of course, to get an introduction to the history of moral and ethical reasoning is just going to be like, it's going to take a long time to really become familiar with this. It's just a big field. There's lots of people have thought deeply about it, and you could get a brief introduction. You could take an introductory philosophy class in moral philosophy, and would give you some of the tools, right? Actually, one of the papers that we saw today, right, the difference between deontological versus utilitarian or Rawlsian or virtue ethics kind of reasoning. You can get an introduction at a very high level, but I think with law, it's just difficult in two ways. One is that the very high level introductory material you could get, like an intro in jurisprudence or something like that, could provide you with like some of the basics about how legal reasoning works. But another kind of additional challenge is that there's a lot of domain specific knowledge. So like criminal law versus environmental law versus IP. Like, the law is such a big field that there's a lot of very specialized knowledge as well. So even if you had the 101 basics of jurisprudence, that's actually not that illuminating if what you're really interested in is like IP law. So anyway, I will just offer my condolences, and just kind of, in a sense, his sympathies, because it is just a vast and deep kind of domain. And so it's tricky and challenging, and I don't know if I have any really great advice about how to kind of quickly get up to speed on it. In a sense, I think I don't even know if that's a possible task.
Yeah, I really appreciate your answer. So, I mean, I could say the same thing about machine learning, because it's vast and it's many subdisciplines and so on. But there's, I think it's a matter of resources, and the community is actually trying to, to bring more people on board. And that's what I mentioned with, there's tons of YouTube videos and really introductory things, targeted at basically non-experts, to get them on board easily. And then go deeper. And maybe this would be interesting, you know, from the other side. Maybe there's some resources on them. So if you have any, just share them with me, please. Thanks.
Ilias perhaps has something to add to that. Oh, sorry. And then Jerry, we can go back to Jerry.
Yeah. Matthias, did you have something to say? So raised hand and then. No, I guess. Okay.
I can come after. I can speak after.
Okay,
You.
okay, cool. So talking about resource and how we can learn about law, I guess it was like a year ago, and I had some existential question and I asked Catalina, what can I do to learn law? Maybe should I take a law degree? Should I commit myself to 4 years or something? And she said that this is a really bad idea for me, probably, and should do something else. So we started thinking about having something like a book lab and do a series of talks and discussions and reading together as a community. So the idea was that we can come closer as a community by start reading, for example, some sort of a law book or whatever, and go into the fundamentals of law and then start to discuss them with legal experts and then go back and forth with NLPs. So it was like a series of law for NLPs. So I guess maybe next year we can do this and we can start this new talk series. And we can accompany this by continuing also the standard NLP series. So we can keep on with legal NLP research and in the meantime do some law courses and law discussions. So we can catch up with what law is and whatever. Yeah. Matthias, please.
I'm sorry, I'm wrangling my daughter who thinks I should be doing other things. If I may speak here quickly about my experience in teaching legal data science to computer scientists in Munich. And the thing about law is that it's a methodology, it's not a body of knowledge. So in other words, what I've done there is, so if I can give one piece of advice to keep it short for everyone involved, it is that reading about the law is one thing, but practicing to apply it is another. One thing I do is I give my students a guided tour. I apologize. I give my students a guided tour through judgments. So if I can give one piece of advice to computer scientists in the field, I'm sorry, it would be to get a legal expert to walk you through a judgment text rather than read abstract statements about constitutional law. Have them walk through a constitutional law case sentence by sentence with you and explain what's going on. That's the most fruitful way to get into it.
If I may add to that, right?
My apologies.
I think obviously, as I said, right, we just need to talk to each other and be able to understand each other. So we don't need, as computer scientists, to become legal experts. We shouldn't and we cannot, right? That's makes sense. From my experience, what helps is also hanging out with lawyers, right? Working with them and just asking them all the questions you have, right? So that's how I learned that comparative law, which I have an obsession, is not another type of law, but it's a tool, right? So it's completely different. Also, the terminology they're used, or principles like, I don't know, the proportionality principle, right? I mean, if I would read it, I would ignore it. But if you work with somebody, go think together about applications, you're going to ask them about things, you're going to learn something, or as Matthias said, right, they're going to go through a judgment and then know, okay, what I need to predict structure-wise. So this is where also the community should come together, right? If you work together with somebody, you are going to learn something from them, and that is going to be enough for you to work together, right? And not, enter each other's, let's say, fields.
Great. Perhaps Leslie, Ilias, Nikos, do we have any questions from the floor, from the room?
Sorry, would anyone like to add anything? Yes.
Yeah, thanks for the talk. I have a question. As you just mentioned, we should, like, computer scientists and legal science should work together to do more multidisciplinary, interdisciplinary study. But I have to say, like, but in the main NLP, it's very performance oriented, and as PhD students, we have the publication pressure. So all of you here as the panel, how are you going to shape this field? How are you going to support the future, like, young PhD student here?
That's a great question, actually, right? I think, yeah, nobody says that we should stop, I don't know, publishing in our venues, or we should stop, I don't know, measuring performance or anything, right? But there are other ways as well. I think also somebody said it, that we can publish other forms of articles, which also being supported by the ACL in general, right? We have also more position papers or theme papers, which can be fitting in that direction. Also, and that's also another point I would like to make, is that our research output as an interdisciplinary community doesn't necessarily have to be, you know, a paper at the EMNLP that beat all benchmarks or something, right? That could be one output. I mean, I think if we want to make our field go forward, we need that. But at the same time, we need to, yeah, write something together, let's say. And then that doesn't necessarily have to be a paper or something. If I think also my work with lawyers in the past few years, I don't know, we did submit, for example, a comment on the FTC regulations about the influencers on social media, where it was a result. I didn't write it as a first author, as you can imagine, some legal background wrote it, but it was a result of discussions about, you know, what is computationally possible, what is not possible, and that goes into, okay, how do we going to shape the new generation of law, right? So, and I think maybe the people, at least in the room, right, they will support also, let's say, alternative forms of dissemination, except the usual, let's say, to call it like that, papers we publish as computer scientists.
Yes, I can totally relate to how difficult it may be to publish or get interdisciplinary papers published, because in the computer science, when you, as you say, it's a very performance oriented. So if you get creative, or if you, it's difficult to find reviewers with the expertise to, yeah, actually see the value or what you want to, yeah, what the papers, yeah, idea is. So yeah, I also would wish for a little culture change in yeah, the reviewer scene, but I think it's already good that we have venues like this, or like AraLegal, but I guess it's difficult, yeah, if you just go to a computer science venue that is not interdisciplinary at all, yeah, to get open-minded reviews.
Yeah, well, new data sets are always a challenge, right? It's not the same old, you know, news data set that we've used for 20 years, and we get the same results on, and all we have to do is make our model a bit better, and that's great. You know, it's really understanding what a new data set means, talking to the experts in that data in law, and understanding what are, it will open our field as well, right? We'll be able to do new things. We'll be able to do them better, as a matter of fact, but of course it takes time, and that's part of pushing the interdisciplinary nature of both fields, right? So, great question.
Yeah, thank you. I have a follow-up question. So, if I don't like chase for the publication game, how do I validate measure my contribution? So for computer scientists, they might think my work is not technical, strong enough. The performance is not improved 2%. But for the legal expert, they might think the problem is not worth like discussed, or like what's the meaning of those technology. So could you please give me some input? How can I validate? How do I know my contribution is enough as a multidisciplinary PhD student?
Maybe this is only my point of view. Maybe you can add your thoughts. I think that yeah, the peer review system that yeah, you have in computer science is maybe the only option that we have at the moment. And but I feel you always have to be aware that it has its limits. So in my experience, you should still believe in your paper. If you get bad reviews, if you get rejected, because I have been surprised at which venues my papers were actually accepted after other reviewers didn't really value them. So it depends. It's surprising how much it depends on who reads the paper. And yeah, it's maybe not a satisfying answer, but finding the right venue, finding the right audience, and having confidence in your ideas is maybe the most important.
So I just add a little bit to that, which is all right, is you do have to have a contribution though. And you have to have a contribution that's going to make sense to somebody, right? And so, you know, it's either gonna, if you're thinking about, you know, computer science, NLP or law as like, you know, the overlap, it's got to make sense to the NLP people and be a contribution there, right? Or it has to be a contribution on the law side that legal people will understand. And if it's not one of those two things, it's probably not a contribution. Or if it is, it's a contribution in a really weird way that only you can understand, which is probably not great, right? So part of it is definitely just structuring your projects so that they are engaging with a ongoing conversation in at least one field in a serious way, ideally multiple fields simultaneously, right? That's the idea. But for example, like you could have a NLP, you could have a project where you're not necessarily cutting edges on the NLP side, but you're doing something that's very interesting on the law side, right? And if that's the case, then law people should understand it and appreciate it. Now, it might be that the reviewers you get will still suck, and then it will take a couple of rounds, but in principle, you should be able to get it understood. And you would want to vet that, though, with people in the field to make sure that that's the case before you dump a bunch of time into it, right? Or alternatively, it might not be that interesting from a legal perspective, but it's cutting edges on the NLP side, you know, and then you would just know that is going to be a lot easier for you to know ahead of time. But I think on a project that's not going to describe, you're going to want to work with people in the legal domain, in the legal scholarship domain, who are going to be able to tell you, yeah, this is a good project. This will make sense. I've done a lot of that working with NLP people where the NLP side is just not, it's not cutting edges at all. We're just taking off the shelf stuff and doing work with it, but it's interesting from a legal perspective. And so then, you know, this is very specific, but you got to know from your advisor within your particular department, whether that kind of publication is going to be valued in your packet, because it might not be, it just depends on your department. And then thinking about what, if you're applying for jobs, either in industry or in academia, what are those positions? And is that going to be the kind of paper that you're going to want to have in your portfolio? Because, for certain positions, it's going to be valuable, and for other positions, it's just not going to be. And so it's just going to be kind of contingent on how you see your career unfolding.
Great. Do we have any other questions from the floor? Otherwise,
Can I add I have a very practical 2 cents to it. I would say go for options that give you more space. I find it the most difficult part is to, especially if you're talking to NLP people, is to explain why the legal bit is important, rather than the fact that you have a tough time pushing the number above significance. So that part is difficult, and in order to get over it, there are two things you can do. You want to get better reviewers in the sense that they are more tailored to law ideally, and you want more space. And both of those options within the ACL space at least are provided in form of tackle. Go for journal. You will get more pages. You will get higher quality in the sense of more time and more select people to review your papers. And I found it to be much sort of easier process, even though it's perhaps longer overall, but it is constructive. Whereas the more perhaps stochastic main conference submission, which I'm sure NLP people in general complain about in the ACL anyway. So thanks.
Thanks a lot for both like high levels opinion and practical submission policy strategies. Thanks. Great.
I think we're closing the end of our time with a panel. So thank you very, very much once more for your participation. I thought it was fantastic to hear about some of your experiences and also some of the thoughts also in the audience that we need to work together on in the next years. So Jerry has a last point.
Well, maybe because, we say usually that panels are chaotic and then we try to remember, okay, what did we discuss? I have a proposal to make maybe for next year, because we say, let's work together. So why don't we, I don't know, take some time, I guess, from our agendas or everything to co-think like a shared task, but a real shared task, like, lawyers, computer science, and peers, that we can work on, for the next year's workshop, right? So find a problem and then probably find the data, maybe try to annotate it with legal experts, and then we let the community, attack the problem, which we're good at. But we have also the legal design of the task. That's my proposal. And hopefully we can do it for next year's version.
I think that's a great idea. So I think that perhaps we can organize an NLLP meeting, and then whoever would like to join in the brainstorming. I don't know, Ilias, Leslie, Nikos, any thoughts on that? No, we cannot hear you.
Sounds good. Sounds good to us.
Great. No, but we can definitely organize a meeting and then see how to actually to move on with this idea. So thank you very much for the suggestion. Once more, thank you to the panelists. I'm not going to applaud into the microphone.
Thank you.
Perhaps you can just give them a live applause. And Leslie, back to you.
Yes, I want to, first of all, thank all of you for coming. Thank you for your contributions. Thank you for your patience as we struggled with a lot of presenters and a very long day, but I think it worked out very, very well. So I would like to announce that we have a winner for our presentation competition, and that is the paper on hate speech. So thank you.
Woo!
Congratulations. With that, we are going to wrap it up. Do we have any final words, Catalina?
No, just thank you very much for hanging in there during this marathon. It was very long, but it was fantastic. I'm going to go to bed now because I've been up since 5. But with this being said, enjoy your social events, and it was absolutely delightful listening to you all.
And stay tuned for the fifth question, right? We will submit the proposal and we're looking forward to hear back.
Yes, fingers crossed for next year. Let's hope we have a 5th workshop. I think we're going to be good. All right, thanks everybody. You're all invited to dinner on Bloomberg. Oh, thank you. Oh, even wait inside.